Hi guys, I hope all of you are doing well. So I am Vishal and I will be your mentor for this Azure Data Engineering course. So if I talk about my background, so I have been in the IT industry for around last 6 years and I have been working as a data engineer for around last 4 years. So I have been working in the data engineering domain mostly on the cloud part and that too using Azure and AWS. So in this particular course, I will be letting you understand all the tools, all the services that we use in the data engineering domain with respect to the Azure cloud. We will be covering each and everything from the very basics in a very simple way and in a practical fashion. We will also be taking help of the official documentation that is there provided by the Microsoft Azure developers themselves. So what I feel is that the official documentation is one of the best resource which you can utilize to learn new things and even to understand and develop whatever you require, because that is the documentation or that is the resource that is provided by the developers themselves, right? The persons who have created those services, who have created those either if I talk about the cloud services or even if I talk about any of the programming language, the developer themselves have written that particular thing, that this is how you can utilize that particular resource or maybe the programming language in the best possible way. What I think is reading the official documentation is also an art. So what I will be letting you know is how to read and implement directly from the documentation also. Talking about the course and the curriculum that we will be doing is, so you can see right on my screen that we will start from the introduction of big data on Azure. We will cover a concept like what exactly big data on Azure ecosystem looks like. What is the difference between batch, real time and near real time processing? What is the difference between Azure, AWS and GCP for big data? The core components of Azure, that is ADLS, right? Azure Delta Lake Storage, Azure Synapse, ADF, that is Azure Data Factory, Databricks, Event Hubs and Cosmos DB. Talking about the architecture overview of the data engineering pipeline. So right from ingestion to storage to processing and consumption, we will be understanding each and everything. Then we will be going ahead and we will be learning about the storage and data lake management. So the mostly the data storage in Azure is done on two services. First one is Azure Blob, right? So Azure Blob has now become a kind of legacy storage. Okay, and the newer organizations or the people who are now started like creating the new ETL pipeline or recently they are moving to Azure. So they are now using Azure Delta Lake Storage Service Gen 2. So this is even a better version of Azure Blob. Then we will be learning about file system hierarchy. We will also be learning about the folder and file organization. Then we will learn about the access control with role based access control and access control list. So like basically this is the full form, role based access control, and ACL means access control list. Then we will also learn about blob storage. We will also learn about what hot and cool and archive tiers are. Then we will also learn about how to securely upload file using the shared access signature SAS. Then static website hosting for dashboards. This is what we will learn in the storage and data management part. Then the data ingestion in Azure. So Azure Data Factory. If I talk about the Azure data engineering role, Azure Data Factory is one of the most heavily used tool in Azure ecosystem. Okay, people get onboarded if they are very skillful only in one single tool, that is Azure Data Factory. If you are very well and if you know in depth how to use ADF, you may get hired only on this particular skill. But again, let me give you a disclaimer. I am not discouraging you and I'm not saying that you need not learn about the other services. You should be aware about all the services that are there in Azure cloud with respect to the data engineering domain. Okay, but this is, I would say, why I am emphasizing is this is one of the, not one of the, I would say this is the most used tool in Azure, that is Azure Data Factory. Sorry. Okay. Then we will learn about what is ADF. We will learn about copy activity, data flows, triggers. We will learn about pipeline creation, how to ingest data from SQL Server, how to ingest data from Blob and REST API, debugging and monitoring the pipelines, parameterization and dynamic pipelines, event sub. We will learn about real-time data ingestion platform. We will learn about that how we can create a Kafka compatible ingestion pipeline. Then we will learn about consumer and producer setup with Spark, and telemetry, log and clickstream also we will be learning about. Then we will learn about Azure IoT Hub, and using Azure IoT Hub itself we will be creating a kind of streaming data for the real-time data ingestion platform. Okay, and then we will be learning about how to integrate the stream analytics and event grid. Now, if I talk about processing and transformation, so for processing, Azure Synapse Analytics is one of the most widely used tool in the data engineering domain. So we will learn about Synapse, what exactly dedicated SQL pools on MPP engine is, serverless SQL pool we will be learning about. Then we will be integrating our ADLS and ADF. We will learn about notebooks, pipelines, Spark pool uses, right? Then we will create an analytics dashboard with Synapse and Power BI. We will also learn about Azure Databricks. So introduction to Azure Spark on Azure, right? We will learn about PySpark data frames, reading and writing to ADLS, Delta Lake with ACID compliant data lakes, job orchestration and parameterization of notebooks we will learn, right? Then cluster configuration and cost optimization we will be learning about. We will learn about batch ETL pipeline, then stream analytics, SQL based stream processing engine. We will learn about IoT hubs and much more. Okay. Then we will go on to the orchestration part. So we will learn about Azure Data Factory in advanced, how we can use pipeline to orchestrate our how we can use the workflows basically to orchestrate our pipelines. We will then learn about the control flow conditions, custom activities. We will also learn about integrated runtime, different types of what integrated runtimes are, how we can trigger Databricks notebook from ADF. Then Azure Logic apps we will be learning about. Then event driven orchestration, how based on certain event we can do our orchestration. Then we will be connecting and connecting our email or maybe Slack to send some kind of notification and alerts. Okay. Then we will learn about connecting our BI tools with APIs and directly using the Azure service also. So we will learn about Power BI plus Synapse, connecting our Synapse SQL to Power BI, visualizing processed Lakeflow data, live dashboards, API, how we can expose using Azure functions, REST APIs on top of processed data sets, then securing APIs with Azure API management, and then we will be scaling our API for real-time responses. And ultimately, after learning all these services, we will be doing projects so that we will be implementing and connecting all these services together into one to create one single ETL industry level of pipeline in this whole course. So these are the things which are listed. Okay, let me make you very clear that we will be first of all for sure covering all these topics that are listed, as well as you guys for sure will be learning much more things that are not even listed here right now. Okay, why I am saying this? Because I will be giving you some real-time examples. I will be explaining you the topics in such a way that I think that you guys have never experienced before. So I hope you will for sure enjoy this particular course. You will learn something new and we will be creating a good bond together. So I will see you in the next video that I would say will be the starting video of this particular course. I will see you in the next one. Till then, bye bye and take care of yourself. Guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course. And in this particular video, we are going to talk about what is big data. Okay. So if I talk about today's world, right? So there are multiple sources where the data can be made from. If I talk about just my smartphone, right? So my smartphone is creating a lot of data every day, right? From my email, right? To sharing my social media things, right? My call logs. I talk about my gallery and everything, right? Anything and everything in today's world is creating some data. So it can be a smartphone, it can be some kind of IoT device, it can be sensors, right? It can be vehicle and whatnot, right? Anything that is right in today's world is connected to the internet is creating or is using some kind of data in today's world, right? If I talk about some numbers, right? If I talk about some numbers, so on a per minute basis, okay, on a per minute basis, I would say every minute, per minute basis, right? Snapchat, all of you must have used it, deals with 2.1 millions of snaps in 1 minute, right? If I talk about Google search, okay, Google search deals with 3.8 million searches in one single minute. If I talk about Facebook, it deals with around 1 million posts per minute. YouTube, 4.5 million videos watched in one single minute. If I talk about email, so just look at the numbers, 188 million emails are getting sent in one single minute, right? And these are all separate. I am not combining all these things, right? All these social media platforms, Google searches, Facebooks, YouTubes, and emails, they are running separately, and on a per minute basis they are dealing with such a large volume of data, right? So how first of all this data is getting created, right? How this data is getting stored, and later on how this data is getting utilized to create some kind of insight, some kind of value for us. So let's understand that part. Okay. So firstly, handling the data, or I would say managing the data, is called as extract. Okay. Once we extract the data from the sources, we transform it, and then after transformation, we load the data. This is called ETL. Then there is something called as extract, load, and transform. This is called as ELT. Okay. Basically the short form. So these are the two kinds of pipelines that we usually create while dealing with big data. Okay. And in most of the cases, we usually create ELT pipeline, right? What is the difference between ETL and ELT? I will be discussing that particular thing in the coming videos in great detail. So don't worry about that part, right? Now let's understand what exactly a big data is and how can I categorize that a data is big data. So can I say 1 MB of data is big data, or should I say 1 GB of data is a big data, or should I say 1 TB or maybe 100 TB of data is big data? right? You guys just stop the video, think about it, right? And uh, just try to guess that what amount of data would we call as a big data. Okay, now let me clarify what is the, okay, like what kind of data is categorized as big data. So it is called as 5V concept. Okay, there is a concept in big data that is called as a 5V concept. So first V understands for volume, second V understands for velocity, and third V understands for variety. Okay, so first of all, let's understand what is volume, what is velocity, and what is variety, and then later on we will be learning about the next two V's. Okay, volume means how much data is getting produced. Again, as I said, that is the data 1 MB or 1 GB or 1 TB or how much. Okay, so this is the volume of the data, means how much data. How much data. Okay, if I talk about velocity, okay, so in how much time, how much data is getting produced. So if I talk about, let's say 1 MB per second, right? So let's say 1 TB, I am having 1 TB of data. Okay, I can easily store 1 TB of my data on my laptop, right? If I, let's suppose, if I am having a 2 TB of hard drive installed on my laptop, I can very easily store 1 TB of data. So the volume of 1 TB data will not be considered as a big data for my system or for my laptop. Whatever I am utilizing to store that particular data, it will be not considered as a big data. Understand it, right? Whereas let's say if I am having 10 petabytes of data and I want to store it on some kind of PC, right, on some kind of computer. So this 10 petabyte of data is like I would say out of the world thing to get stored on some kind of personal computer. In that particular case, 10 petabytes of data can be considered as a big data for PC. Okay, it can be considered as big data for that PC or for that system. Now if I'm talking about, if I'm getting the data, right, as let's suppose 1 MB per second, right, or let's suppose if I'm getting 100 records per second. Okay, let's say 1 GB of the 1 GB of data per hour. Okay, so this is what will define the velocity of the data, means how much data in how much interval. So this time is basically interval, that are we getting the data on an hourly basis, are we getting the data on a let's say per second basis, right? Maybe a per minute basis, maybe on a weekly basis, right? This interval can be anything. Okay, so that will define the velocity of the data. Then there is called as variety of the data. Okay, so basically if I talk about the data, so we can have three types of data. If I talk about the variety, so we can have structured data, we can have semi-structured data, okay, and we can have unstructured data. Okay, now if I talk about structured data, so the data that is stored in a form of a tabular format that can be stored in columns and rows is termed as structured data. So it can be stored in columns and rows. So data like CSV, right, TSV, Excel, right, all these formats of data are categorized as structured data. If I talk about semi-structured data, so it will have some kind of this key value pair format. Okay, it will have, let's suppose, key 1 and it will have some kind of value 1. It will have key 2, right? It can have, let's suppose, value 2, and inside this value 2 also it can have some kind of key 2, let's say key 3 and value 3 kind of pair. Okay, so if I talk about the file formats, so file formats like JSON, BSON, and let's suppose XML, all these formats are basically a semi-structured data format. And if I talk about the unstructured data, so like images, right, audio, video, all these formats of data are categorized as unstructured format of data. Okay, so handling what variety of data at what volume and at what velocity, right? If I combine all these three factors, okay, will define the complexity firstly, right? Will define the complexity and will define basically if that data is a big data or not. Okay, so let's suppose if I am having a structured data, right, which is coming at a velocity of 1 mbps, right, and the total volume of the data can even be, let's suppose, 1 TB. So it can be easily managed, easily processed, right? So that particular data I won't be categorizing as big data. Okay, but let's say if I am having a structured data itself, which is coming at a velocity of, let's suppose, let's say 1 million records per second, right? And the total volume of the data can grow up to, let's say, 10 petabytes. So that volume of data and at that velocity, right, even if the variety is structured, that can be considered as a big data. Okay, so this is what a big data is. Then talking about the third V of, the fourth V of big data is the veracity. Okay, so veracity means what is the accuracy and the trustworthiness of the data is. Okay, so the accuracy, how much accurate for my use case. Okay, so if I'm ingesting the data, that data can also be a junk data that is not useful for my business use case, for my business insights, or maybe training some kind of machine learning model or something. Okay, so what is this machine learning model? What is this pipeline? I will be just discussing next. Okay, so just understand that the veracity means what is the accuracy of the data and what is the trustworthiness of my data is. Then the fifth thing will be value. Okay, that after doing all these things, after creating my ETL pipeline, right, maybe running it through some kind of transformations, loading in somewhere, doing some kind of machine learning training, creating some kind of dashboards and all these stuffs, what is the end goal? What is the value am I getting for my business? So this value is mostly related to the business aspect. Okay, that how I can make my, let's suppose, business profitable, like, right, let's say what is my customer churn, right, how I can maybe revenue growth, grow my revenue growth, right, and all these things, right? Sorry. Basically answering the business related questions from the data that we have received will be the value of that particular data. Okay, now the pipeline, the ETL pipeline or the ELT pipeline that we have talked about, ELT or ETL pipeline, right, what is the flow of it? Okay, let's understand basic. So this will be just a basic flow. Okay, so firstly we will have multiple sources of data. Okay, so let's suppose we can have some kind of database as my data source, right? I can have some kind of sensor or maybe an IoT device. Okay, I can have some kind of API, I can have some kind of mobile device, right? I can have some kind of, let's say, SMTP server, right? And whatnot. There can be multiple more data sources that can be there. Okay. Now this whole data, it will be dumped somewhere. Okay. So usually we dump these data to something called as a data lake. Okay. We dump these data to something called as data lake, and this data will be in a raw format. Okay. This data will be in a raw format. Now from this data lake, what we will do is we will do some kind of transformation. What kind of transformation, right? What things will be done and everything we will be discussing in great detail in the course itself. So don't worry about it. Just assume right now that we will be doing some kind of transformation, and again we can store this particular data to some kind of, let's suppose it can be a data warehouse. Okay. It can be some kind of database. Okay. It can be some kind of delta table or whatnot. Okay. Then from this transformation, what we can do is either we can, let's suppose, train our machine learning model, right? We can do some kind of forecasting, right? We can do some kind of reporting, right? We can connect it to some kind of BI tool for my reporting purpose itself to create some kind of value. Okay. So this is what it will be. Okay. So this is my data source, right? So these sources will define what volume of data, right? What variety of the data, variety, okay? What variety, what volume, and at what velocity the data is getting produced, right? Then after uh, storing it on the delta lake, we will perform some kind of veracity. Okay. Means, is the data accurate? Is the data trustworthy? And after doing the transformations, we will make the data as we will make the veracity of the data as high, that okay, the data is of high accuracy and it is highly trustable, right? And then after doing the transformations, right, when we'll be doing these things, whether we are training our machine learning model, right, whether we are doing some kind of forecasting of our data, whether using some kind of BI tool, we are creating a report for it, or we are getting some kind of business insights and all these stuffs. So this particular thing will create the value for us. Cool. Now if I talk about processing the big data and doing all those things, right? So earlier we used to have something called as Hadoop. Okay. So Hadoop was basically the processing engine. Hadoop was the processing engine that we earlier, okay, so this was, I would say, if I create a star, so this star means it was in early days, or I won't say early days, I would say in past. Okay, right now also people are using Hadoop. I'm not saying that Hadoop has become extinct, right? But now this Hadoop has now been changed to Spark. Okay, so Spark is again a big data processing engine itself. Okay, with much more advantages as compared to Hadoop. Okay, so in this whole course, we will be utilizing Apache Spark as our processing engine in any of the services that we will be using in Azure. Okay, so underlying processing engine will be Spark itself. or maybe SQL also. In some cases, it will be SQL also. But mostly, if I talk about the big data processing engine, so under the hood, it will be Spark only. Okay. And for storing and ingesting all these kinds of different varieties of the data, we have two types of databases. Okay. So if I talk about the databases, so we have something called as SQL database, and we have something called as NoSQL database, right? So SQL database will be utilized to store the structured data, the data that is there in a form of rows and columns. So MySQL, right? Postgres, right? Oracle DB, okay? All these databases are the form of SQL databases. Then if I talk about NoSQL databases, so the data type of uh, semi-structured and unstructured. So semi-structured and unstructured data will be stored in the NoSQL databases, right? And if I talk about NoSQL databases, so MongoDB, right? Cassandra, okay? So, and even if I talk about so HDFS and all these things can be, so HDFS is basically Hadoop distributed file system. Hadoop distributed file system. Okay. And nowadays we are using something called as DBFS. Okay. That is called as Databricks file system. Okay. So sorry. Okay. So these are the tools, or I would say the databases that can be utilized. So these file systems are not databases. Let me first of all clarify this also, right? That these file systems are a separate concept as compared to the databases. But just for your knowledge, okay, because moving forward we are going to utilize all these terms, so you don't feel like that okay, this is something as unheard. Okay, even though I have not talked about all these concepts in a great detail or in depth, right? But why I am saying all these things is so that you guys have heard, at least heard about all these tools, all these databases, file systems, processing engines, right? The five V's of big data, what exactly a big data is, and all these things like what is ETL, what is ELT, right? Extract, transform, load, right? Or extract, load, transform, all these concepts at least you have heard about. Okay. So this is pretty much it for this particular video. Okay. This video was just the basic introduction of the concepts of big data and what exactly a big data is. Okay. So if from tomorrow anyone asks you what is a big data, how you can define a big data, so always try to define him big data in the five V's that we have talked about. Okay. That what will be the volume of the data, what will be the variety of the data, what will be the velocity of the data, what will be the veracity and the volume of the data will decide that if a data is a big data or not. Cool. So I hope you guys learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye. Hi guys. I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course. And in this particular video, we are going to understand what is cloud. We are going to understand the fundamentals of cloud. Why do we need a cloud environment? As well as we will be understanding how many different type of components are there inside a single cloud. So let's get started with this particular video and let's get straight into the system. So the very first thing that we will be understanding is what is a cloud. So cloud computing is a revolutionary technology that has fundamentally transformed how organizations and individuals access, store and manage data and computing resources. Okay. Rather than relying on physical infrastructure located on premises, cloud computing delivers computing services including servers, storage, databases, networking, software, and analytics over internet, allowing users to access these resources from anywhere with an internet connection. Okay, so let me just first of all tell you what exactly this on-prem thing is, right? So let's suppose you are opening a company, right? And you need to create a application. Okay, let's say you need to create an application and a simple website, right? Now once you have created this application, so the development can be done on our laptop, right? The development can be easily done on our local system, on the PCs, on the laptops and everything, right? But once you have developed your application and your website, these things should be available to everyone in the world, right? So to make it available to everyone, you will have to host it somewhere, right? You will have to host it somewhere so that it's available to the world. So to do that, what we require something called as servers, right? To store the data that the data that we will be producing using the, let's suppose, user interaction by using logs, right? And whatever uh, different ways. So to store the data that we will be producing will be, for storing that we will require databases, right? To make it secure, right? To, let's suppose, prevent it from some kind of cyber security attack and all those things, we will require some kind of networking thing, right? And all these stuffs. So let's suppose we did not have any kind of cloud infrastructure available for us. So after creating this application and our website, we will have to set up each and everything on our own expense and on our own premises. This is what it is called as on-prem. Okay, so we will have to buy the servers first of all, right? We will have to then manually on these servers, we will have to ourselves host the databases, right? So it will be like one other kind of headache for us, that first of all you can buy a server, you will have to add databases, then you will have to attach the networking and everything, right? So that these servers can talk to each other, right? Then you should have some kind of space where you will be handling and managing these servers, right? Again, you should have some kind of storage and all those stuffs ready for you, right? Again, if something goes down, you should have a technician who will be managing all these servers. If something goes down, right? The networking of the servers, right? The handling these storage and everything. Okay, you should have a separate person to manage all these things. Then you will require a cooling infrastructure, okay, because these servers produce a lot of heat. So to manage that heat and everything, you will require a whole cooling infrastructure. So all in all, the complexity will be very, very high. Okay, cost again will be very high. Okay, time to set up this infrastructure and all those things, again it will be very high, as well as the running cost, the recurring cost will also be very high, right? So setting each and everything on prem just to host a simple application or a simple website can be very expensive, very complicated, time consuming, and even maintaining those things can be a very uh, big headache for an organization. So to overcome that particular issue, what these larger companies like Amazon, so mostly we use the cloud services of these three companies. Amazon, that is AWS, then we have Microsoft, that provides us the cloud as Azure, and then we have GCP, that is Google. Okay, there are much more companies. There is Oracle, right? There is this Alibaba, right? And many more companies are there which provide these cloud services. But the top three players managing more than, I guess, 70% of the total cloud consumption are these three big players. So what they did is they said that we will manage each and everything from for you. We will have our uh, we will have our data centers. Okay, so these are called data centers. So data centers are places where a large number of servers, a large number of storage devices, networking, right? Keeping in track that all the hardware and everything, all the stuffs should be up and running. So all these things are managed by these organizations. Okay, we as a user, okay, I made this user inverted. So me as a user, I should have a laptop, okay, and an internet connection. So let's suppose this is my LAN or something. So this is my internet. So using this internet only, I can access this data center from anywhere. Okay, and there is not one single data center that is available. There are multiple of data centers that are available. So here again, if I talk about the on-prem thing, let's say if I want to maintain the replication of my data, right? Because any organization will not keep only a single copy of the data. It will replicate its data to prevent it from any kind of fault tolerance. Let's suppose a earthquake happens or a fire breaks out and this particular whole thing goes down, right? So organization will lose all the data, right? So it will it will do what? It will create a replica of this on-prem infrastructure somewhere else, in some, maybe some other place, on a rented place, or maybe if it is having some office at some other location, it will create a replica of it, right? So again, to set up, to manage, to run and do all those stuff, the cost and the complexity increases, keeps on increasing, right? But handling all these things, right from the maintenance to creating the replica to managing it, uh, managing the available zone and all those things will be the headache of the organization. I should just have some money. Okay, I don't, and here there are multiple services for multiple use cases. Okay, so I just have to use the particular service that I require. So let's suppose I have a single website that I have to host. So on Azure, I can host it on Azure virtual machine, right? And I can use, let's say, Azure Cosmos DB to store my data. Okay, that's it. I need these two services, and these two services will be very cheap for me as compared to setting up this whole infrastructure. It will be very cheap. Okay, again, complexity is very low, right? I just have to understand basically how I can use this cloud platform. That's the only complexity, right? So complexity is low as compared, again, I am emphasizing that, as compared to this on-prem infrastructure. Cost is very low. Time to set up again is very low. We just have to sign up, right? Provide our a few credentials, and then we can just log in and start using the resources. And the maintenance cost is near about zero for me. Okay, all the maintenance and each and everything will be the headache of the of the cloud service provider. Okay, so this was a great shift in basically the 21st century, right? So this shift from traditional on-prem system to remote means this cloud system is basically a remote thing, right? It is present somewhere else and I can access it sitting from any corner of the world. Internet based infrastructure and became one of the most significant technological innovation of the 21st century. Okay, then the core concept of cloud. At its essence, cloud computing refers to the delivery of computing services over the internet on as you pay basis. Means as much as you use those services, you only have to pay for that much. Let's suppose if you are, and again, if I talk about this on-prem thing, right? So this on-prem system will keep on running on a 24/7 basis. I can't switch it off, right? Because if I switch it off, let's suppose if any other team is working on that, even they will not be able to work on it and things like that. So on-prem thing will be working on a 24/7 basis. Here, if I'm using, let's suppose, a server for, let's say, 4 hours a day. So I will only have to pay for those 4 hours which I am using the server for. For the rest of the time, I will not have to pay a single penny. But again, it's not that simple. Okay, let me make this thing also very clear. So let's say if you have attached any kind of storage to the server, in that case you will not be paying for the cost of the running of the server, but you will have to pay for that storage if it is attached on a 24/7 basis. Okay, so again, it's not even that simple, but again, it's not even that complex. Okay, the term cloud is used metaphorically to represent the internet or a large network of remote servers. Okay, so cloud is basically a metaphor that represents the internet or large network of remote servers. Rather than purchasing expensive hardware and maintaining it yourself, cloud computing allows you to rent computing resources from third-party providers who manages the infrastructure, the security, and maintenance. Okay, so it will be the responsibility, it will be the job of the cloud service providers such as Amazon, Microsoft, or Google, or any other third-party cloud provider to maintain that particular infrastructure, to maintain the security of that infrastructure, and the normal maintenance of the servers, of the databases, and all those things. Any kind of update is there, any kind of bug fix is there. So it will be the responsibility of the third-party provider. If I am doing it on a self-hosted way, then managing each and everything, right from the infrastructure to the security to the maintenance, updates, bug fixes, and everything will be my responsibility. This model fundamentally changes how businesses approach information technology, converting large upfront capital expenditures into more manageable operational expenses. Okay, so if we are going ahead with the on-prem system, so there will be an upfront large capital expenditure, right? Again, as I told you, that we will have to buy all those hardwares, manage everything, hire a team who can manage the networking, who can manage the infrastructure, the security of the on-prem thing. Here, it's more of the operational thing. Whatever we require on the fly, we can use it. We can use it on the fly. If we want an other service, any other service that we want to use, we can attach it and we can start using it. Okay. The concept of cloud computing is built on several foundational technologies and principles. Cloud computing architecture typically consists of front-end, a user-facing side with application and interfaces, a back-end, the service provider's infrastructure including servers, storage, databases, and management systems. Okay, so basically the cloud will again have two kind of system. The front-end system. So the front-end system will be basically a UI, a user interface, using which the user can interact with the remote servers and the storages, the databases that are present in the other part of the world. Okay. So let's suppose this is Microsoft data center. Okay, Microsoft data center. It is there in USA. Okay, this data center is present in USA. Okay, I am sitting here in India, right? So this is Vishal, and Vishal is sitting in India. Okay, so what Vishal requires a laptop, right? And using his laptop, Vishal will go to, let's say, azure.com, right? And using the UI, Vishal will be able to spin up a server. Okay, I can host a database. I can maybe train my machine learning model and whatnot. Okay, whatever is required to me as a user from Azure, I can do all those things using this UI on my laptop, and I can spin up that resource in USA or maybe any other region which I am using. Okay, so here there are two things. So this is the front end part of the cloud, right? And this is the back end part of the cloud. Okay, this is front end and this is the back end part of cloud. Okay, these components are connected through networks, usually the internet, allowing seamless communication between user and cloud resources they access. Again, as I previously told you, that in middle, obviously, I will require an internet connection using which I will be sending the request to this particular data center. That, okay, you need to spin up this, you need to maybe bring down this, right? You can attach a new service and whatnot. Cool. Now let's talk about a brief evolution of cloud computing. So the history of cloud computing spans more than half a century, tracing back to the concepts developed long back before the internet as we know it today. In the 1960s, the concept of time sharing emerged, allowing users to access a single powerful mainframe computer simultaneously. Okay, so in 1960s itself, this time sharing concept emerged where multiple users were using one single powerful computer, which laid the foundational theory of modern cloud computing, right? So talking about today's world, so that that whole data center can be compared to this mainframe computers, and the users can be compared to the multiple users who are accessing this mainframe computer simultaneously. This era saw pioneering projects like ARPANET launched in 1969, which was the predecessor of today's internet and was explicitly designed as a resource sharing tools between different institutions. Okay, so in 1969, this ARPANET was designed, or it was basically developed as a project, which later on became the base for today's internet. Okay, the modern cloud computing era began in early 2000 with the emergence of commercial cloud provider. In 2004, Amazon launched its first cloud computing service, SQS, followed by the official launch of Amazon Web Services in 2006. So AWS, the most widely used web service or cloud service, is AWS, which was launched in 2006, with which introduced Amazon EC2 instance, which is again one of the highest used cloud I would say service till date. Okay, and S3. So these are the two mostly used cloud service till date that was launched in back 2006, around 20 years ago. Okay, these services allowed users to rent virtual computers and storage over the internet, making a paradigm shift from traditional IP infrastructure. Subsequently, other technology giants entered the market. Google launched Google App Engine in 2008. Microsoft launched Azure in 2009. So 2 years later, Google launched Google App Engine, and 3 years after AWS, Microsoft launched Azure, and other providers followed, creating a competitive landscape that drove innovation and affordability. In 2010s, the 2010s witnessed further maturation of cloud technologies, including the introduction of containerization, Docker in 2013, Kubernetes orchestration in 2015, and the emergence of serverless computing with AWS Lambda in 2014. Okay, so with time, okay, as the time grew, multiple new technologies came into picture, such as containerization. So I won't be discussing containerization in much detail in this video, but Docker is the tool using which we can containerize our application. Okay, which came into picture in 2013. Okay, then comes the Kubernetes, right? Which came. Okay. So, with the introduction of the Docker, or you can say the containerization in 2013, the landscape of cloud technologies or the cloud infrastructure again changed. And with the introduction of orchestration tool of these containers, such as Kubernetes in 2015, again some kind of paradigm shift was noticed in the cloud environment. And in 2014, right, AWS came with something called as serverless computing. Okay, so serverless computing basically means that the servers will only be running for the time that you need it for. Okay, rest of the time you will not be paid, or you will not be charged basically for that particular, even the servers. Okay, uh, so once your job is done, that server will again go down, and you will be only charged for, let's suppose if you have ran that server for half an hour, so you will only be charged for the half an hour of running that server. Okay, so with all these advantages, right, all these infrastructure, like less complexity and flexibility, right, it like these cloud servers, or I would say these cloud providers, grew in a very short period of time. Then in 2019, when COVID-19 pandemic in 2020 accelerated cloud adoption as organizations worldwide scrambled to enable remote work and ensure business continuity, further establishing cloud computing as essential infrastructure, right? So when in 2020, when COVID-19 hit, right, everyone and every business and everything went online, right? Everyone wanted to be safe at home and wanted to basically do a remote kind of job. So even the businesses who were earlier having a kind of on-prem infrastructure, they also tried to come on the cloud part. And even the local developers, right, they started using basically these cloud services. And that particular thing, that world moving from an offline thing to an online thing, further accelerated the adoption of cloud. Cool. So this was a basic history of cloud. Now the five essential characteristics of cloud computing. So according to National Institute of Standards and Technology, cloud computing is defined by five essential characteristics that distinguish it from traditional computing models. First is on-demand self-service. So user can provision computing like server time and network storage automatically without requiring human intervention from the cloud provider. Okay, this allows organizations to independently request and receive access to services within minutes, rather than waiting an IT team to manually set up the infrastructure. Okay, so whenever a service is required to anyone, they can spin up that particular service within a few minutes, right? Rather than requiring the IT team to first of all set up that whole infrastructure and then get it going. So user can provision it within a few minutes, right? Can provision resources like server, okay, and network storage. Here it should not be time. Okay, it should be resources like server and network storage automatically without needing even any kind of human intervention from the source service provider. Okay, again, like as we are already aware about that, using this front end back end concept, right, we can automatically launch whatever kind of service we require. We don't require any kind of human intervention, means I don't have to call the Microsoft people that okay, I need this particular server and I need this particular storage device. No, using the UI that has been provided to me by the Microsoft people, I can spin up those services whenever I require without any human intervention. Okay. Then second thing is broad network access. So cloud services are accessible over standard networks and through various heterogeneous devices, including laptops, smartphones, tablets, and desktops. Okay. So if you are having an internet connection, I can access my cloud, my infrastructure using any device, be it laptop, be it the smartphone, be it the tablet or anything, right? You can access your network using any of the heterogeneous devices. User can access their application and data from any internet connected location, enabling unprecedented flexibility and mobility. Okay, so as long as your device is connected to internet, it does not matter whether you are in India, you are in USA, or you are in any part of the world. You can access your infrastructure, you can access your data, you can access your servers, right, which enabled flexibility and mobility. Then resource pooling. Cloud providers employ a multi-tenant model where physical and virtual resources are dynamically allocated to multiple customers. Okay. So here what happens is the single infrastructure or a single resource can be distributed to multiple users. This means, okay, let's suppose I am having a machine which is having 64 GB of RAM. Okay, let's say it is having 32 cores. Okay, it is having 32 cores, right? So me as user 1, okay, I have requested as 4 GB RAM and 2 core. Okay, some user 2, it has requested 8 GB RAM and let's say 4 core. So what these cloud providers will do, they can they can point these two users on the very same machine. So here some resource, let's say this much resource, will be provided to the user 1, and these resources out of this whole resource will be provided to user 2. Again, if user 3 wants to spin up some kind of server, let's say again 4 GB RAM, right, and 2 core CPU, so he can spin up this, but his or her server in this this whole system only, or this whole I would say this whole remote server will be there, right? The larger server. Inside this larger server, the users can spin up the smaller servers. So basically, this is what resource pooling is. That they can multiple users or multiple customers can be allocated the resources dynamically. So let's say if now this user goes down, okay, he has stopped his resource. So again, let's say user 4 comes into picture, he can be allocated this resource. So this is how dynamic allocation basically works. This pooling of resources allows providers to achieve greater efficiency and cost effectiveness by serving multiple organizations from the same infrastructure. Okay. So I'm just giving you a basic example here. Obviously, it is much more complicated than this. Then rapid elasticity. Cloud computing system can quickly scale resources up and down based on the demand, sometimes automatically. Okay. So this is basically called as scaling up and scaling down. So what this usually means, so if I give you an example, okay, so all of us watch IPL, right? All of us watch IPL. So talking about the Hotstar thing, okay, so in a non-IPL season, maybe the average viewership of Hotstar is 1 lakh per day. Okay, maybe in a non-IPL season. In non-IPL season, the average viewership or maybe the average user that comes on Hotstar is 1 lakh per day. Okay, but in an IPL season, this user base can grow as much as, let's suppose, 10 crore per day, right? So here we are having more than 1000x users in the IPL season. So if, let's say, Hotstar or maybe Geo or Reliance, right, is having an on-prem infrastructure to manage this thing. So if in a non-IPL season they are managing, let's say, their infrastructure on two servers, so they will have to buy 2000 servers to manage the IPL, right? So can you just imagine the first of all the cost, then the complexity, then the manpower, and each and everything that will be required to manage 2000 servers on prem, right? So to like even to I would say to erase that particular issue, right, or to mitigate that complexity, right, these cloud providers can scale up or scale down on demand. Okay, and even this 1 crore per day footfall is, or 10 crore per day footfall is, when the match is going on. When the match is done, these numbers can drastically fall, right? These numbers will fall drastically, right? So what these cloud providers do is, and the flexibility is, that during the match I can spin up thousands of servers, right? And when the match is over, I can drop these servers and I can only keep only those servers that I require to manage these many users at one single time. Okay, so this is what this scaling up the resource and scaling down the resource means. And sometimes this scaling up and scaling down can also be done automatically without any kind of human intervention. So whether an organization suddenly experience a sudden spike, just like this is a sudden spike, right, in traffic, or periods of low activity, cloud resources can instantly increase or decrease without disrupting service, and users only pay for what they actually use. Okay, so they, here the Hotstar or the Geo will only have to pay for the time. Let's suppose they're using these 1000 servers only for 2 months, so they will only have to pay for 2 months for the 1000 servers, and the for rest of the 10 months they will have to pay for only for two servers. Okay, so this is again a very uh, like a very useful service, or I would say a feature that is provided by the cloud providers. Then measured service. Cloud systems monitor, control, and report resource uses for each user, enabling transparent pay-per-use billing models. This this metering of service ensures that organizations only pay for the resource they consume, making cloud computing economically efficient. Okay, so each and everything is tracked. Okay, each and everything is tracked, how much you are using, for how much time you are using, and how much you have to pay for using that particular service. So these things may make the things transparent. The organizations know that, okay, these are the services that I have used, I have consumed it for this much of period of time, and this is what I have to pay. Okay, then cloud service models. So cloud computing is delivered through three primary service models, each representing a different level of abstraction and management responsibility. Okay, so cloud service provider provides the services basically on three levels. That is infrastructure as a cloud, platform as a cloud, and software, or like software as a service. Sorry, not as a cloud, infrastructure as a service, platform as a service, and software as a service. So let's understand the difference between these three. Okay, so infrastructure as a service is the foundational cloud service model that provides virtualized computing resources over the internet. With infrastructure as service, providers supply the complete foundation of IT operation, including infrastructure, servers, storage, networking, operating systems, virtualizations, and management tools. Okay, so infrastructure as a tool, as a service, means that these cloud providers will provide us the Virtualized computing resources. Okay, so resources like EC2 instance or Azure virtual machines, these infrastructures or these services can be categorized as infrastructure as a service. They are only providing us the servers or maybe any kind of storage, right, and the operating system. Rest of the things we will have to build on top of the servers. Okay, so let's suppose I am having an Azure VM. Okay, I am having this Azure VM. So this Azure VM will only consist of some RAM, okay, some cores of CPU, an operating system, and some storage. That's it. Nothing else will be present in this VM. Each and everything I will have to make. Let's suppose if I want to host a website, if I have to run some code, whatever I want to do, I will have to do it manually. So this thing is termed as infrastructure as service. Azure is giving me just the infra. Okay. Customer access these resources through dashboards or application programming interface APIs. So I can access this virtual machine either through the dashboard or you can say the UI, or I can also access these things using the API also, giving them complete control over the computing infrastructure. However, customers remain responsible for managing applications, runtime environments, middleware, operating system, and data. Okay, so it will be my responsibility to manage the application that is running on top of Azure virtual machine. The runtime environment means the basically what environment and what things are getting run on. Let's suppose if I want to run on Python, so I will have to manually install Python on my Azure virtual machine. If I want to work on Java, so I will manually have to install Java on that machine. Okay, middleware, if I want to use any kind of middlewares, how I will handle the data and each and everything, it will be my responsibility. Real world examples of infrastructure as a service include AWS, Azure virtual machines. Okay, it's AWS EC2. Okay, then Azure virtual machines and Google Compute Engine. Okay, so infrastructure as a service is ideal for organizations that want control over infrastructure without the burden of physical hardware maintenance. So here hardware and everything will be maintained by the cloud providers. Rest of the thing, it will be my responsibility to manage it. Then if I talk about platform as a service, so platform as a service acts as a middle layer in the cloud computing stack, bridging the gap between infrastructure as a service and software as a service. It combines the flexibility and customization options of infrastructure as a service with streamlined workflows and rapid development benefits of software as a service. Okay, so what platform as a service did is it became a middle layer, okay, in the cloud computing stack, bridging the service between the infrastructure as a service, like it was not a raw virtual machine, as well as it was not a full-fledged software. It was something in between. Okay, let's say it gives you some kind of runtime. Okay, it gives you some kind of runtime. Let's suppose if I talk about Databricks, so Databricks can be considered, or specifically if I talk about Azure Databricks, so Azure Databricks can be considered as a platform as a service, that it will give me the Spark runtime, the Spark environment, along with the operating systems and everything, so that I can run my Spark code on it. Okay, so it bridges the gap between infrastructure as a service and software as a service, which combined the flexibility and the customization option of infrastructure as a service, as well as, because I did not had to manage the runtime and everything, I can deploy and I can rapidly develop on the platform as a service. So platform as a service provides not only the basic infrastructure but also manages operating system, middleware, and runtime environment that makes it easier for the developers to deploy application and build continuous integration and continuous development pipeline. Okay, so the earlier things in the infrastructure as a code, such as the runtime environment, the middleware, operating system, was handled by the user themselves. Now it will be the responsibility of the cloud provider to manage all those things. Now it will be only my only responsibility will be to host the application and to manage the CI/CD of that particular application. Rest of the things will be managed by the cloud providers. While the platform as a service offers faster deployment and easier deployment workflows, it's it does limit customization option compared to the infrastructure as a code. So obviously, most of the things, because it is managed by the cloud providers, right? We will not have that customization option that I can do in the infrastructure as a service thing. For example, Google App Engine, AWS Lambda, Heroku, and Microsoft App Service is an example of platform as a service. So platform as a service is particularly suited for developers and organizations focused on rapid application development without managing the underlying infrastructure. Then comes software as a service. So software as a service leverages cloud computing and economics of scale to offer customers an efficient way to access, use and pay for software. With software as a service, cloud providers host applications on their servers, manage the availability, security, overall performance, and software updates. Okay. So if we are availing as software as a service. Okay. So if I talk about, let's suppose this, I'm using here Notion. Okay. So Notion is giving me a software as a service. So it's the Notion's responsibility to basically host each and everything, right? Whatever things are present, or if I don't give an example of Notion, let's say if I'm giving an example of Microsoft 365. Let's suppose we are having Excel, we are using PowerPoint and all those things, right? So hosting PowerPoint, right? Managing the PowerPoint, developing the PowerPoint, making sure that PowerPoint is always available when I want to use, making it secure, and even making software updates is the responsibility of Microsoft. I am just paying to use PowerPoint. Okay. I am just utilizing the functionalities of PowerPoint. I am making PPTs, and the rest of the things is being handled by Microsoft. So that is what software as service is. So users typically subscribe to software as a service application on a monthly or annual basis and access them using web browsers or mobile application. The key advantage is that customers don't have to worry about managing and maintaining the underlying infrastructure. The provider handles all critical services. Prominent examples include Google Workspace, Salesforce, Microsoft 365, Slack, Zoom, Dropbox, and all these things are an example of software as a service. So software as a service is ideal for organization seeking ready to use solution without worrying about deployment, maintenance, and updates, right? So if I'm an organization who wants to develop PPTs, right? Or let's say I want to develop PPT, right? So I will not first develop a PowerPoint and then I will develop my PPT, right? I will pay Microsoft, who has already developed PowerPoint, right? Who is already maintaining each and everything for me. I just have to worry about developing my PPT. So that is what a software as service is. Then the cloud deployment models. So cloud computing can be deployed in different ways depending on an organization's need, security requirement, and control preference. Okay. So let's see how many different type of cloud deployment models are. So there is something called as public cloud, private cloud, hybrid cloud, and community cloud. Okay. So now if I talk about the public cloud. So public cloud utilizes the multi-tenant architecture where multiple organizations share computing resources provided by third-party vendors, right? So public clouds will be doing what? As I've already told you, if I give you the example of AWS, Azure, GCP, these are public cloud providers that they will be sharing the resources, right, with multiple organizations. Infrastructure, platforms, and softwares are delivered over the internet on as you pay models. Okay. In Service Cloud, the provider manages the underlying infrastructure, security, and the compliance certifications, while customers control their data, application, and access management. Okay. So, maintaining the infrastructure, keeping sure that everything is secure, and the compliance certification, it will be the headache of the cloud providers. Whereas maintaining the data, controlling the data, maintaining your application, and the access management will be the headache of the users. Uh, Public cloud provider offer unmatched scalability, cost effectiveness as organizations avoid upfront capital investment and only pay for resources that are consumed. Okay, we have talked about this multiple times that first of all, these cloud providers or public cloud providers can give us a lot of scalability in a very cost effective fashion and in a very less period of time, and organizations saves millions of dollars because they don't have to set up everything on prem. Advantages include low upfront cost, instant scalability, and access to cutting edge technology. However, organizations have limited control and share infra with other tenants. Use case include web application, e-commerce platforms, and non-sensitive workload. Then comes private cloud. So private cloud refers to cloud infrastructure dedicated to a single organization. Okay. Here the resource sharing will not happen as it happens in the public cloud, either hosted on prem or third party cloud providers. Okay, so either it can be hosted on the premises, or it can be even a third party cloud provider which will dedicatedly provide you the resources for you. This deployment model provides maximum control and security, allowing organizations to customize infrastructure to meet the specific requirement and security policies. However, private clouds require significant capital investment for purchasing hardware, software, skilled personnel to manage the infrastructure. Okay, so even the on-prem thing can be called as private cloud, or even if you are managing those things on some kind of cloud providers, it can become uh, like very costly for the organization, right? If you are doing on-prem, then we will have to purchase the hardware, we will have to install multiple softwares to do the networking and all those stuffs. We will have to hire a team to manage our on-prem servers, right, and all those stuffs. Even if you are going ahead with a third party provider, then also we would require a good DevOps team basically to manage the whole infrastructure. So all in all, as compared to the public thing, the private cloud is a much more requires much more higher capital investment. Organizations must also assume responsibility for maintaining, patching, uh, updates, and troubleshooting. So now the user or the organization will have the responsibility of maintaining that cloud, doing any kind of patches or upgrades, and even the troubleshooting will be now the headache of the organization and not any kind of cloud provider. Private clouds are ideal for organizations handling sensitive data such as financial institutions, healthcare providers, and government agencies that require strict control over their infrastructure. So, organizations like financial institutions, banks, insurance companies, and all those institutions, they usually handle the sensitive data, right? Even the healthcare providers like hospitals and all, and the government agencies will have sensitive data, and we can't take the risk, right, of leaking that particular data, right? So in that case, these organizations will go ahead with the private cloud. Then comes hybrid cloud, which is nowadays the mostly used kind of infrastructure. Integrates public and private cloud environment to functions as a unified system. Okay, so hybrid cloud will be a combination of the private cloud and the public cloud. This deployment model offers maximum flexibility, allowing organizations to leverage the strengths of both public and private cloud. Applications and data can move seamlessly between infrastructure types based on requirement, cost, and policies. Okay, so based on the requirement and based on the cost and policies, we can seamlessly move and seamlessly think about if we want to host that particular thing maybe on a private cloud or on a public cloud. For example, an organization might keep the sensitive data and application to the private cloud while using public cloud for less critical workload and requiring scalability. Okay, if I talk about bank, right? So bank can use to handle, let's suppose, any kind of transactions, right? To store the credit card details, bank details, account details to a private cloud. But rest of the things, right? Let's suppose any kind of email service is there for the bank, or maybe the bank website is there. I'm not talking about the internet banking, just the simple website, right? And all these things, they can be uh, hosted on the public cloud, right? Because these are not any kind of sensitive information or a sensitive thing that is there, right? So they can be hosted on the public cloud also. Hybrid cloud requires orchestration tools, consistent security policies, and unified management across both environments. Real world patterns include cloud bursting, using cloud infrastructure, using private infrastructure during normal operation, and scaling to public cloud during the demand spike. Okay, so in real world, let's suppose if there is something unusual spike going on my private cloud, right? So I will not be able to scale up my cloud, private cloud, in a very short notice. Okay, in that case, what I will do is that I will spin up my public cloud servers, right? And I will be able to go ahead with the demand. Then data tiering, keeping frequent access data on high performance private cloud while archiving the data to cost effective public cloud. Okay, so let's suppose if my organization is saving the data from last 20 years, right? But like in a regular basis, we don't require the data from last 20 years, right? So I can archive the data, let's suppose, of last 15 years to something as a cold storage of S3, or let's say Azure ADLS, right? And rest of the things for last 5 years of data, I will be keeping it on my private cloud. So this is what basically a hybrid cloud infra is. Then comes the community cloud. So community cloud is a relatively specialized development model where cloud infrastructure is shared among several organizations and have common goal, requirement, and compliance standards. Example include a consortium of universities, government agencies, healthcare organizations that share same cloud resources. Okay, so when multiple community or multiple organizations require the same kind of infrastructure, they have the same goal, they do provide the same kind of service, in that particular case a community cloud can be hosted. Means multiple organizations can come together and host their thing on a single cloud. Such as if there are multiple universities, right, they can come together and they can host their thing on one single on-prem cloud that is there. Okay, similarly, government agencies, multiple agencies can use one single cloud platform. Healthcare agencies, right, multiple hospitals or maybe multiple insurance companies can use one single cloud, and things like that. Okay, community clouds require strong governance frameworks which clearly define decision making process and cost allocation method. While they offer enhanced security and specialized compliance features, they require agreement among multiple stakeholders and can reduce customization flexibility. Okay, then the cloud architecture and components. So cloud computing architecture refers to the design and storage of cloud based system that deliver computing services over the internet. The architecture consists of several critical components that work together to deliver the services. Okay, first one is cloud infrastructure. Okay, so client infrastructure. So client infrastructure represents the front end that and includes user interface applications that can be either a browser, mobile application, or client software that users employ to access the cloud services. We have already talked about the front end part of the cloud provider. This is the touch point through which users interact with the cloud. Then there is something called as hypervisors. So hypervisors are virtual machine monitors that provide virtual operating platform to users and manage guest operating systems in the cloud. They run separate virtual machines in the backend, each consisting of software and hardware, and their main objective is to divide and allocate resources among multiple virtual instances. Okay, so hypervisors are again a kind of virtual servers itself, but they will have some kind of specific operating system, and they will be maintaining the users, or they will be basically redirecting the users on the whole of our infrastructure or maybe the data center. So it will be the job of these hypervisors basically in the backend to allocate and to divide the resources into multiple virtual instances or to multiple different virtual machines that are there in my data center. Then comes the cloud servers, host application and data, running virtualized operating systems and managing computing resources for cloud services. These servers form the computational backbone of cloud infrastructure. Okay, so these cloud servers basically the, if I talk about the thing infrastructure as a service, so these are those cloud servers themselves. Okay, so these can be used for hosting our application, maybe for managing the data and doing all our compute resources, doing any kind of compute resources thing that we want to do, we can do on these servers very easily. Then there is something called as cloud storage. So cloud storage allows users to store the data that is accessed remotely over the internet. Data is automatically scaled at a runtime and can be modified, retrieved, and recovered from anywhere with internet access. This eliminates the need for organizations to invest in and maintain physical storage infrastructure. Okay, so these cloud storages, like let's suppose S3 or ADLS, right? So if we have stored our data in these storage services, we can access these storage services from anywhere in the world if we are having the internet service, and obviously if we have the authority to access them. Okay, and this eliminates the organizations to maintain and invest for maintaining the offline infrastructure, or basically the on-prem infrastructure of the storages. Then comes the networks. So networks connect the front end and back end of cloud architecture, allowing users to access cloud resources. They are highly flexible, secure, and cost effective, enabling users to connect and customize routes and protocols. Okay, so networks will enable, or basically will handle the authorization and the authentication of the users. Okay, if a particular user can access our application or not, right? If he has the access of let's say checking our database or not, and things like that, all these things will be managed by the network. Then management and security components. So these include software that manages cloud resources, provisions infrastructure, enforces security policies, monitors performance, and ensures compliance with regulatory requirements. These components are essential for maintaining service quality and protecting the organizational data. Then service availability and market leader, if I talk about, right? So AWS, so the global cloud computing market has experienced an explosive growth, with cloud infrastructure becoming increasingly essential with modern business operation. As of quarter 2 2025, the global cloud infrastructure business has reached $99 billion in revenue, growing 25% on an over year to year basis. The market is dominated uh, by three major providers, that is the big three. Collectively they have 63% of market share. First one is AWS, Amazon, second is Microsoft Azure, and third one is Google Cloud. So talking about AWS remains the market leader with 30% of the global cloud infrastructure market as of quarter 2 2025. Amazon or AWS maintains its positions as dominant provider through a comprehensive suite of services, strong customer relationship, and continuous innovation. Microsoft Azure holds about 20% of market, making it second largest cloud provider. Azure's strength lies in integrating with existing Microsoft product and enterprise relationships. Google Cloud commands 13% of the market, securing third place among cloud providers. While smaller than its competitors, Google Cloud has gained traction through competitive pricing and advanced AI/ML capabilities. Then remaining market share is between Alibaba, that is 4%, Oracle 3%, Salesforce 2%, IBM 2%, Tencent Cloud 2%. Then cloud infrastructure provide revenue are projected to exceed 400 billion for the first time in full year 2025. Okay, with Gen AI specific cloud services growth is around 160%, right? So the cloud providers who are specifically giving us the Gen AI service, their growth is around 160% on an year to year basis. Okay, then key benefits and business values of cloud computing. So cloud computing offers organizations numerous tangible and intangible benefit that drive adoption and create significant return on investment. First one is cost efficiency and reduced capital expenditure. We have already talked about it, right? Then comes the scalability and elasticity. Okay, again we have already talked about it. High speed and quick deployment. Then enhancing collaboration and productivity, disaster recovery and business continuity, and data security and compliance. So talking about the advanced cloud architectures, right? So beyond the traditional service models and model cloud computing involves innovative architectural approaches. So first one is microservice architectures break down complex applications into smaller, independently deployable services. Each microservice runs separately, enabling deployment teams to develop, deploy, and scale components independently. This approach is particularly beneficial for large applications like e-commerce platforms with separate services for inventory management, payment processing, and user authentication. So what microservice architecture basically is, so let's suppose we are having an application where we have multiple modules, like we have authentication, right? Then we have some kind of landing page, right? Then we can have, let's suppose, inventory page. Okay, we can then have, let's suppose, payments page, and much more pages. I'm just keeping it simple, right? So what in microservice architecture we will do is we will host all these modules on a separate server. Okay, so we will host this auth module on a separate server, landing page on a separate server. Okay, this inventory thing on a separate server, right? And this payments thing on a separate server. So what this will, and these servers will be communicating with each other. Okay, they will not be anonymous, they will be communicating with each other. Okay, so what this will do is, first of all, it will enable the deployment team to develop and deploy. Okay, like they can easily deploy these services and they can easily make any update, any changes to these services individually. Okay, and large applications like e-commerce platforms where they are managing these services. So let's suppose one of the service goes down. Let's say this payment service goes down. In that case also, the user will be able to authenticate. They can land on my landing page, they can see the inventories. They will not be able to make the payment, but at least they will be able to see the inventory. Instead of going whole of the system down, right? Even if they can see the inventory, I'm not saying that it is good for our business, but it is better as compared to the whole system going down. Okay, so this is a kind of flexibility and a kind of benefit that microservice provides us. But again, maintaining this microservice architecture is not a cakewalk. It is very, very complex. uh, if we are dealing with some complexity as the e-commerce platform. Okay, so it's complex to manage. Then comes the serverless computing. Uh, Abstracts away server management entirely. Server still exists, but customers don't manage them. Scaling, execution, resource allocation are fully managed by the cloud providers. Serverless users uh, Serverless uses a pay per execution model, charging only while code runs, which is significantly reduced cost for bursty or unpredictable workload. Examples include AWS Lambda, Azure Functions, and Google Cloud Functions. Serverless is ideal for event-driven application and workload with variable demand. Okay, so serverless computing means that each and everything, right from scaling to execution, resource allocation, each and everything will be managed by the cloud provider themselves. We will only have to manage the code that runs on that particular we will only have to manage the code that runs on the serverless computer, or you can say serverless computation system. And this particular thing is very, very useful when there is something as event driven thing. Okay, so if I give you an example, so let's say if I want to trigger an email when user buys something. Okay, so we have to trigger an invoice. So if I am deploying a whole server, of whole full-fledged server which is running on a 24/7 basis, and let's say my e-commerce platform is not that big that I am getting the orders in every few seconds, right? Let's suppose I sell only 50 orders in one day. Okay, my orders range from 50 to 100 orders in a day. So in that case, sending email server will run for only a fraction of seconds, or maybe for some seconds only, right? It will not run for the whole 24/7 thing, right? In that particular case, we don't have to we don't have to pay for all the 24 hours of time that that particular server is running. We can only pay for those 50 emails when when that particular server sent those mails. We will only pay for that time. So that is what serverless computing is. Then containers and orchestration package. So containers and orchestration package applications and dependencies into portable, lightweight containers that can that run consistently across different environments. Container orchestration platforms like Kubernetes manage deployment, scaling, and networking of containerized application. Containers excel at microservice architecture and applications with a consistent resource requirement. Okay, so whenever we are dealing with the microservice architecture, in that particular case, containerization and orchestration will be required, right? So platforms like Kubernetes will manage our deployment, it will manage our scaling and the networking inside my containers. Okay, so what exactly containers is, what is Kubernetes? This is not the part of this particular video, so I will be restricting to discuss that particular thing. Now the security challenge and privacy concerns. So the first thing is data confidentiality. Okay, confidentiality. Okay, means the security of the data basically. Okay, Data confidentiality issues represents a primary concern as organizations externalize sensitive data to third party cloud providers. Personal data must remain unreachable to unauthorized users through server access control policies and regulation. A lack of trust between user and cloud providers regarding data handling remains a major security concern. Okay. Then account hijacking is described as the most serious and pressing security threat in cloud computing. Once a hijacker compromises a user or organization's account, they can access all associated accounts and activities. Strong authorization mechanism and regular security monitoring is essential to prevent account hijacking. Then data eavesdropping poses significant risk in cloud environments as encrypted data transmission over networks can be intercepted. Organization must implement SSL certificates to encrypt data in transit, making it harder for hackers to intercept sensitive information. Then misconfiguration is one of the leading causes of data breaches, resulting from adequate security practices and poor security posture management. Cloud infrastructure, user-friendly nature design for easy data exchange creates significant challenges in restricting data access only to the targeted entities. Then share infrastructure risk result in multiple organizations sharing the same cloud infrastructure, increasing vulnerability to cross-tenant attack and data leak. The reliance on third-party providers or multiple tenant environment requires careful risk management. Then real world application, so it can be used in healthcare, right, in education, finance and banking, retail, e-commerce, media and entertainment, manufacturing and software development. So how they can be used, like you can for sure read it, not a very difficult thing to understand. Okay, so this was all about the cloud infrastructure, right? So from next video we will start understanding about the Azure cloud platforms. I hope with this particular video you have understood very in depth that what exactly cloud is, right? What all things what all services it provides, what all different kinds of cloud infrastructure there are, right? What is infrastructure as a service, platform as a service, right? Uh, then software as a service is, right? What is a private cloud, public cloud, hybrid cloud, community cloud, and all those things are there, right? So I hope you have learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course, and in this video we are going to see how we can create our account on Azure Cloud. So we have already talked about what is a cloud, what is big data, right? And in this video we are going to see uh, what is the procedure of creating an Azure account and what are the tools and services that we can use in Azure for our big data uh, big data projects. So let's get started with this video and let's get straight into the system. So here, if you will go to azure.microsoft.com, so where you will land onto a page something like this, where you can see build in the cloud where and with an Azure cloud, right? And here you can create, deploy, manage applications across multiple clouds, even on premises and at the edge. At the edge means on the IoT device with scalable, cost efficient Azure services. Okay, so if I talk more about what all things will we get, so here what we will be doing is that we will create this Azure free account, okay, where it is only available to the new customers. So if you have already created an account on Azure, so it will not be available to you. So what you can do in this particular case is, either if you have some other email ID, right, that you have not created an account with, you can use that, or you can create a fresh email ID and then you can like avail this particular service. So here we will get free monthly amounts of 20 plus services for 12 months. Okay. Then free monthly amount of 65 plus services, that will be always free, obviously until a certain limit. Access a full catalog of services to free amounts and $200 of credit. So we will get around $200 of credit. Spending protection. So credit card won't be charged. Okay. No upfront commitment. We can cancel it anytime and pay as you go beyond 30 days if you are using after it. So what I think is, if you are learning continuously on a daily basis, 30 days, I think you will be able to do all the stuffs, right? If not, you can move on to pay as you go basis. And if you I would say, if you be careful, right, with the services that you are using, you are after using it, you are not like keep it running and all those things, so you will not be very heavily charged. 1,000 2,000 rupees, you can very easily do it if you go beyond this particular given time. If you complete it in the given time, I don't think you will have to even spend a single penny, right? Then what all free services are there that we will get? So Azure DevOps we will get, then Azure Speech in Foundry Tools, Container Registry, Virtual Machines, Data Catalog, Azure Data Factory, right? So this will be the service that we will be focusing upon in this particular course. Then Azure SQL Database, Azure Document Intelligence, right? Then if I talk about the AI and machine learning thing, so you can see here, so these are the AI services that we will get in the free tier also, and you can see the limits, right? So if we want to use this Azure Document Intelligence, so 500 pages we will get the limit. AI search, 50 GB of storage for 1000 hosted 10,000 hosted documents and 3 indexes per service. Okay, Azure ML is free to use. Then Azure Vision, we can get 5,000 transactions for S1, S2 and S3 tier, right? So you can see here also, it's very clearly and transparently mentioned that, okay, these are the only like this is the service which is free, and up till this limit it is free. If you use beyond that limit, you will be charged, right? Then if you talk about the hybrid and multi-cloud, so Azure DevOps, right, Azure SQL Database, Azure Monitor, Azure Arc, then Postgres SQL, IoT, Edge device. If you talk about compute, so these are the compute services that are basically free to use. So mostly we will go ahead with the Azure Virtual Machine only, right, which is 750 hours of free time every month we will be getting. Okay, and we will also use some Azure functions. So 1 million request is free, so it's more than enough for us, right? Then containers, so Azure Container Registry, Azure App Service, AKS functions and all these services. Databases, mostly five low frequency activities. If you talk about Azure Data Factory, 1 lakh virtual core seconds of SQL database serverless users with 32 GB of storage for Azure database. So all these services are mostly free to use, whatever limit we are having. IoT device and management and governance, you can see right here, right? If you talk about, if you want to learn more about Azure using the official documentation and the videos created by the developer themselves, so you can even visit all these resources you can use. Okay, FAQs is there, and these are the locations. There is around 140 countries and regions where Azure is available. So these are the list of countries where Azure is available to use. Next, what we will be doing is, we will just click on this, try Azure for free. Okay. Now what it will do, it will, if you don't have a Microsoft account, just keep in mind your Gmail account is not your Microsoft account. Okay, so you can use Gmail to create your Microsoft account, but you will have to separately create one. Okay, if you are having a new Gmail ID, if you have created for this particular course, so you can just go here, you can put up your Gmail ID, right? Click on next. Okay, enter your password and whatnot, the few informations, your first name, last name, password and all those stuffs. simple as that. Just like how you create a social media account, in the very same way you will be able to create your Microsoft account. It's not difficult than creating a social media account. Okay, so you can create your Microsoft account, and once you have created your Microsoft account, you can just use those credentials to sign into your Azure. Like you can use to sign in into your Microsoft account, and once you have signed in into your Microsoft account, then you can come here and sign in to your Azure portal using same credential that you will be having. Okay, once you have created your so if you see here, right, so I have used my Gmail account only to create my Microsoft account. Okay, so using your Microsoft account, you can then log into your Azure cloud. Okay, if you talk about the resources, right, so resources are available here also, and in the form of documentations. Okay, if you will go in resources, and if you go to documentations, okay, so these are the services or resources that are available for us to use. Okay, so here you can even search by what kind of service you want to use. If you want to use app service, and maybe Cosmos DB, maybe Azure functions and like that. So if we search here for databases, right, so in databases we will be able to see Azure Data Factory, and in Azure Data Factory you will be able to see there are multiple things that we are given here, and with the help of documentation we can very well understand and very well get to know how we will be creating and deploying, and what all things we can do on Azure Data Factory, right? So we will be taking help of the documentation also. I will be also teaching you how we can do the things, and we will be moving simultaneously. So why I am focusing on the documentation is because, like, this is the resource, right, which you can utilize to become a master of anything, be it any programming language, right, be it any tool, be it any service. Okay, you should have the I would say the capability and the ability to read the documentation, understand it, follow it, and then use it according to your convenience. Okay, today let's suppose you are in college, right, or maybe you have taken a course, any course, right, you have taken any course, they will be teaching you. But let's say tomorrow you go to an organization where you need to work on a certain specific requirement. Okay, in that particular case, you will be your only guide and your only mentor, right? So in that case, you should have the ability to understand the documentation and think in a way that using that guidance provided in the documentation, or maybe from your senior also, for sure you can consult and do all those stuffs. You can understand the concept and you can get it done in the, like, you can get it done whatever requirement is given to you. Cool. So with that said, once you have created your account, right, and once you have signed into your account, you will land onto a page something like this. So let me zoom in. Okay, so you will land onto a page something like this, where maybe you may not see some of these things. I guess there's resources and subscriptions you will not be able to see. Rest of the things you will be seeing. Okay, so here whatever you want to do, right, let's suppose on home you will be seeing this thing. If you go to dashboard, right, so if you go to dashboard, so here you can create your own dashboard. So let's say if you want to create something, right, that whatever frequently using services you are using, right, so let's suppose I am using Azure functions on a daily basis, I am using Azure Data Factory on a daily basis, let's say Cosmos DB on a daily basis. So I can create my own dashboard, right? So if you go here, right, and I have some kind of dashboard already. Okay, so this is the default dashboard that is created, right? So I can come here, no, not resources, I can click on dashboard, right, and then what I can do is I can click on create. Okay, so there are some pre-built dashboards that are already given to us, like let's say if we want to capture our SQL database health, right, if we want to get the resource graph of Azure, if we want to get the health of Cosmos DB, we can do it. Else we can create our own custom dashboard. Okay, and here what you can do is using these options, right? So let's say if I want to do, let's say, BS17 hyphen dashboard. Okay, then, and now what I can do here, I can search for, let's suppose, Databricks. Okay, I'm not having Databricks. So from here only, let's say if I want to get all the resources. Okay, so I want to get this resource option right here. Okay, I am also, let's say, an admin. Okay, so I will have to manage the user groups and everyone, right? So I can add these user groups right here. Okay, then what else can I use, right? So let's say, here if I click on add tiles, I can, let's say, move it here and move it here. Okay, so resource group, all resources are right here. Let's say if I want to get the clock also, I can click the clock, right? I can, yeah, this is the time I want to see it in this time format, right? So based on your requirement, you can add and you can create your own dashboard here. Okay, so these are the lines. If you see the lines, so these are the lines that will be visible. So if you are having a screen with 1024 with 78 pixels, this is basically the area that you should be creating your dashboard. So if you are having a screen size with this, so you can utilize this area also. So if you are having a screen size with this, so you can utilize the whole area that is given in this particular thing. Also, if you want to have a bigger screen size, so if you are having 920 by 80 1080, you can utilize this. And if you are having 3840 with 2190, you can utilize this much area for creating your dashboard. Okay, you can move it right, you can resize it however you want to use and basically utilize this dashboard. Okay, then if you go to all services, so here, based on the kind of service that they provide. Okay, so if you talk about the AIML, so you can see these are the services that are present in the AIML domain. So Azure Machine Learning, Azure AI Video Indexer, Bot Service, right? Content moderators. So Azure in total, if I remember it correctly, it provides more than 240 plus services, right? So we need not know all the services, right? It's nearly next to impossible to know and to learn about all the services, and even it's not useful for me, right? Let's suppose if I'm working in the AI and machine learning domain, so I should be aware about not all but most of the services, right? If I'm working in some of the analytics domain or maybe in the data engineering domain, so I should be available about sorry. Okay, so if I'm working in the analytics domain or maybe the data engineering domain, so I must be available about at least most of the services. So here we will be using data factories, we will be using the data lake, right? We will be using HD Insight, Power BI, okay, Azure Synapse, Databricks, right? So most of the services for sure we will be covering. So talking about the compute, so we can have these many compute options for us. Okay, and based on the requirement and based on the kind of service. So in the previous video, we have already seen that cloud can provide us a variety of options. Like, so we can have a infrastructure as a service option, we can have a platform as a service option, we can have a software as a service option. So based on the kind of compute and the kind of service that we want to utilize, we can choose that particular compute. So here, if I talk about the virtual machines, so these virtual machines are the infrastructure as a service option, right? If I talk about functions, right? I should have a, yeah, you can see function apps. So this function app is basically an is a platform as a service, right? And if I talk about, let's suppose, Azure Databricks, right? So Azure Databricks can be considered as a software as a service, or maybe Power BI embedded. So it can be considered as a software as a service. We just have to connect to our data source using the Power BI, and then we can focus on creating our dashboards and our analytics. We don't need to focus about the managing the Power BI, creating the Power BI, doing any kind of bug fixes or updates. Each and everything will be managed by the Microsoft itself. Then talking about the containers. So containers will be used. So here compute will be used as the resource to run anything. Okay. So let me close it down so that. So compute will be used to run our, it can be used to run our code, maybe our platform, any kind of infrastructure, any kind of where we are doing some kind of processing or any computation is required, there we will be using these compute resources. Containers will be utilized to store our data. Okay, so containers can be used to store uh, basically any kind of data, right? Sorry, here. Okay, containers here is basically the my bad. So containers here is basically the Kubernetes and the Docker container services, right? So like AKS and all these services. So Azure Kubernetes services is there, app configuration is there, right? Container apps is there, container registries is also there. So if we are going ahead with the DevOps part of it, right? If we are managing, if we have containerized our application, if we are going ahead with the Docker and Kubernetes infrastructure, and if we are managing some kind of uh, like some kind of what we call a non-monolith architecture, right? Which we usually call as, which we also call as microservice architecture, right? Wherever we are utilizing the microservice architecture, there we can use these containers to deploy our microservices on multiple servers, right? Using the containerization and all those things, and we can manage those microservice architecture using these container services. Then talking about the databases. So databases will be the platform, right? Where uh, we will be basically storing our data. So these data can vary from structured data to a semi-structured data to even a unstructured data, right? To also some caching services. So here if you talk about the Cosmos DB, so Cosmos DB can be utilized basically to store our semi-structured data. Similarly, if you talk about the MySQL, so we will be storing the structured data here. If you talk about Cassandra DB, so we will go ahead with our uh, structured and semi-structured data, right? Neon basically is a uh, serverless database for Postgres and so on. Okay. So here we will be basically storing our data. Then talking about the DevOps part. So in DevOps, right? So DevOps will basically have all these services where we will try to basically do some kind of version control, right? We will integrate some kind of a continuous integration, that is CI, or even the continuous deployment, that is CD. So if you are utilizing those things, if we are doing some kind of let's suppose infrastructure as a service thing, right, where we are utilizing some Terraform scripts and all these stuff, so there we will be utilizing these DevOps services. Okay, so not too much of our use, to be honest. Okay, then talking the journal services. So here cost and billing. So I would say you guys should uh, mark this particular service as a star. Okay, so that it is available at your dashboard itself or at your home screen, and you can keep track of your spending. Okay, you can keep track of your spending. So cost and billing will be the section where you will be able to manage each and everything related to your billings. Then quotas, right? So it's basically provides the ability to oversee the control limits in Azure environment, ensuring effective allocation and utilization. Okay, so basically whatever resources that we are having, we can control those resources, and we can even see that how much resource utilization are we doing. Then operation center, education, quick start, health service, right? Free services, reservations, and all these stuffs are right here. Even support and help you can get from here. Then talking about the hybrid and multi-cloud. So we are already aware about how different types of cloud infrastructure or cloud environment can we have, right? So we can have a public cloud, we can have a private cloud, we also have a hybrid cloud, which is nowadays heavily used, right? The organizations, the larger organizations currently are utilizing the power of hybrid cloud or hybrid computing, you can say. That they even have their own private cloud for their sensitive information, right? And some kind of processing on that sensitive data, and they're also having some kind of public cloud access where they can process their non-sensitive data. And if any kind of cloud burst happens, like a very you can say a parabolic kind of spike happens, a traffic spike happens, so in that particular case they can push their private cloud to the public cloud. Okay, so for that we have multiple services like Azure Arc data control, right? Virtual vans, SQL databases, and all these services are present right here to manage multi-cloud architecture and hybrid cloud architecture. Then talking about the identity management. Okay, so if we are having our own personal account, in that case this identity management if is not that much important. But if we are working in any kind of organization, okay, in that particular case this identity management, and especially if you are on a higher role, okay, so in that particular case this identity management plays a big role. So it will be you who will decide that what access a developer should have, on what services he can access, and up to how much level he can access, right? So let's suppose if a developer, if a new developer comes, right, you will give him the access of your Azure Data Factory service, but you may not give him the service to the access to maybe start or to delete that particular service. You can only give him the access of, let's suppose, to view and to edit a pipeline. Okay, this is the only access that you can give. So managing all these accesses can be done with these services. Okay, then integration. So we can integrate from different platforms also. So if you want to integrate with Apache Airflow, we can use this particular things. Account integration we can do, right? If you want to integrate with Kafka or Flink, we can go ahead with this. So if we want to, we can utilize Event Sub if we want to integrate with some kind of IoT platform or some kind of streaming device. Basically, if we want to integrate with our Azure platform, so we can utilize Event Hub, right? Similarly, we can have multiple other services that we are having. Then IoT, Internet of Things. Okay, so if we are going ahead with, you can see also in IoT also we are having Event Hub, right? So if you are dealing with the IoT devices, these are the platforms that we can work with. Then management and governance. Again, if you want to manage your whole platform and to govern your whole platform, so you can use all these services, blueprints, carbon optimizations, and all those stuffs. Migration. So if you want to migrate to Azure or from Azure, so these are the migration services that can be helpful in the migration part. Then monitoring. So if you talk about the monitoring part, so these monitoring can be of any level. These monitoring can be from account level to maybe your service, right? And like that, maybe your activity log and all those things. So you can utilize all these services to monitor at any level of your account. Talking about the networking, so we have many options and around 34 options for the networking job that needs to be done. Security wise, so again we have many services, right? From, you can see the firewalls, right? We can create our own firewalls, we can create our own gateway, we can even have our multi-factor authentication. If we want to use, we can use our key vaults, right? DDoS protection and all these things. Talking about the service part of it. Then storage again. So in this storage, we can store anything. It will be a kind of object storage that we will be having, a kind of data lake, you can say. Okay, so we can have Delta Lake Gen 1, right? We can have disks, we can have storage accounts, right? snapshots and all these things right here. Then if you are working with web and mobile, so we can have our API connections, app configuration, function apps, right? AI searches, notification hub, like logic apps and all these services uh, ready for us to be used, right? So based on our requirement, right, what kind of job we want to do, we can come here and get to know about the services that we can use that suits us the best. And also we don't need to require and to understand about all the services, right? We can on the fly learn about the services that we basically require for our job. Okay, so in all resources, resource groups you can manage and all these things, right? Let me go to billing thing, right? This is an important thing that we should cover, right? So here if you see, so you will have some kind of billing associated with your account, right? So here you can go to cost management. Okay, you can go to cost management. Scope will automatically be selected. Okay, right? And here if you come to your scope, okay, if you go to subscription, monitoring, optimization, billing, invoices. Yeah, if you go to then from overview, you can go to monitoring, and then you can go to cost alerts, right? And if you will click on this cost alert, you can add some kind of alert. Okay, so if you click on this add, so you can see uh, resource group until this. Okay, we can create this alert also. Recipient will be my Gmail, starts on from today until, okay, from for 1 year, I guess it's more than enough. And we can create this alert. Okay, and then when you will go to budgets, you will click on this add budget, right? So here you can add some kind of budgeting thing, right? So let's suppose my budget. Okay, you can keep it by month, by quarter, or by year. Okay, so let's say billing month I am taking, and here you can give the amount of threshold. Okay, so let's suppose if you can spend, if you feel like that you can spend $10. Okay, so you can keep your amount as 10. Okay, and you can click on next. Now you can set your alert condition. So you can select that, okay, if the actual cost enters more than 80%, means I have spent around $8, right? So action group not needed. You can send me an email on this particular email. Okay, that's it. And languages will be maybe default, you can keep, no worries, right? If you want to add any other email, you can also add multiple emails. If you want to select more, like let's say if your actual cost goes more than 90%, so $9, again you should be triggered an email. Okay, so this way you can keep basically a track of your spend, right? Even let's suppose for any reason, right, maybe due to some kind of uh, carelessness, you forget to uh, delete your service, so it will be charging. But because you have set your limit to $10, so whenever your total budget will go to $8, you will be triggered a mail, right? So you can come onto your Azure platform and you can see why you are getting charged for it, right? And then you can click on create. Right, so now my budget has been created. So every month, and here you can also track. Okay, so let's say if $1 is done, so you will be having some kind of progress, right? So here you can see, okay, it's of 10 rupees, not even $10. Okay, so it's in rupees right now. Okay, I have set, I guess, my default spending to INR. Okay, so if you have set your default spend to INR, you will be, your budget can be in rupees, right? Else it will be in USD, that is US dollar. Okay, So here you can see, like, you can set your budget according to whatever you feel like that you can spend. So even as low as 10 rupees you can set your budget and you can get going. Okay, then you will be getting all your invoices and all those things here. Okay, but in most of the cases, right, if you are so you can even see 16 paisa is yet to be paid, right? So you can get all your invoices and all the things right here in your account. Okay, and if you want to do your cost analysis and all those things, you can even do the reporting part of it, right? So all in all, I would highly suggest you guys to keep a track and set up your billing alert. Set up your billing alert in the very first place when you are creating your account. Before creating any service, you should set up your billing alert, so that even if you forget uh, to maybe put down your service and all those things, so you can at least get an alert. And let me clarify this, that this billing alert will not delete your service. It's not that, let's suppose if you cross your threshold limit, so your service will go down. It's not the case. You will have to manually come and uh, get down your service. Okay, it will just send you an alert that, okay, whatever cost you have set, you have crossed your threshold limit. Cool. So I hope you guys will be able to create your Azure account, right? It's not that even difficult. You just have to go on to microsoft.azure.com. There you have to log in with your Microsoft account. So if you have a Microsoft account, you can very easily log in just the way you log into your maybe your Instagram or your Snapchat profile, just by entering your email ID and your password. If not, just how you sign up on a social media account, put up your email ID and your username and your password and all those things, your account, Microsoft account, will be created, and then you can log into your Azure account. Make sure you are going ahead with the free account that gives us $200 uh, of free uses for the first month. Okay, um, and then you will be redirected to a dashboard, something like this, where I have already discussed one of the few things, like what all services we will be having, and for what all use cases basically can we use this Azure platform for. Cool. So this is pretty much it for this particular video. I hope you learned something new. I will see you in the next one. Till then, keep learning and keep growing. Bye bye. Hi guys. I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course, and in this particular video we are going to understand about data factory. So as I have already told you guys that we will be heavily focusing on Azure Data Factory tool in this particular course, as this is one of the most utilized ETL tool in the domain. So let's get straight into our system and let's understand about ADF, that is Azure Data Factory. Okay, and talking about Azure Data Factory also, so there is a new service or a new tool basically that has launched by Microsoft, that is Microsoft Fabric, which covers everything from data movement to data science and real-time analytics, business intelligence and reporting. So we can also test that particular thing. But even for right now, if I talk about right, if I'm stating it today, so in today's uh, world also, data factory is the most utilized ETL tool in whole of the data engineering domain, that I can clearly say. Okay, so we will be focusing on Azure Data Factory for now, and for sure we will be also getting an introduction and a glimpse of Microsoft Fabric too. So in the world of big data, right, raw unorganized data is often stored in relational, non-relational and other storage system. However, on its own, data does not have the proper context or meaning to provide meaningful insights to analysts, data scientists, and business decision makers, right? So as we are already aware about this fact, right, the 5 V's of big data, that ultimately the data should also provide some kind of meaningful value to the business decision makers, right? That's the ultimate goal of the data that we usually store and we transform it, right? So the same thing it's saying, that the raw data will not provide any kind of proper context or meaning either to the analyst and even to the data scientist. If data scientist will try to just train the machine learning model on the raw data, it will, that particular machine learning model will be of no use. Okay, so we have to transform the data, uh, we have to mold the data in such a way that it can be used by the analyst to get the insights, right, to get the reporting and all. It can be used by the data science or the machine learning team to train their models and in future get some kind of prediction out of that particular model. So big data requires a service that can orchestrate and operationalize process to refine these enormous store of raw data into actionable business insight. Azure Data Factory is a managed cloud service that is built for these complex hybrid ETL or ELT and data integration projects, right? So we have already talked about what is ETL and what is ELT, just in a basic way. Now, if I tell you in a more detailed way that what exactly a ELT is and what exactly a ETL process is, okay? So let's suppose, as we have already talked about, that we can have multiple data sources from where we will be ingesting our data, right? So what we can do is, and what usually happens is, so this is, let's suppose, source 1, right? This is source 2, this is source 3. Okay, these data will be stored in something called as data lake. Let me use the red pen. Okay, these data are stored in a raw format. It will be stored in a raw format, something called as data lake. Okay, then this particular thing will be transformed and then stored in some kind of data storage. Okay, and then there can be multiple layers of transformation. After this transformation, there can be another transformation layer that can happen. Okay, and that usually happens. Then again we will be storing this particular data in a table, and then from here the maybe the data science team or the machine learning team can train their machine learning model, right? The analyst team can connect and analyze the data, right? The BI team and the business decision makers can either connect here, or maybe one level of transformation more will be done, and usually the business decision makers usually connect to this particular layer. Okay, so what this thing is, this is basically a ELT process. Okay, we are extracting the data in a raw format, we are just loading it. So this is what the process of extraction is. Okay, we are extracting our data here, we are loading our data here in the data lake, and then the transformation steps happen. Okay, so this is what the ELT process looks like. Then there is something called as ETL. So ETL will have something like this. So in ETL we don't have too many data sources, right? Mostly. So this will be my data source. Let's say this is my source 1, this is my source 2. Okay, we will do some kind of transformation right here. Okay, we will do the transformation. We will load the data. Okay, then again we can do some transformation depending on our requirement. Okay, again we can load our data, and then here my data science team or my ML team can utilize my data, and my BI team can utilize the data. So this process here, if I talk about, so this is the extraction, this is extraction, right? One step of transformation has already been done, right? So this is the transformation step, and here we are loading our data. So this pipeline will be termed as ETL pipeline, right? So it is just the difference between if we are just transforming the data and then loading it onto our first data store, or we are first of all loading it somewhere and then after that load we are transforming our data. That's the major difference between ETL and ELT. Okay, so this Azure Data Factory, it can be utilized for both of the pipelines. It can be utilized for the ELT process as well as the ETL process both. If you talk about the features of Data Factory, so data compression, okay. So during copy data activity, it is possible to compress the data and write the compressed data to the target data source. This feature helps optimize bandwidth using the data copying. Okay. So copy data activity. So when we will go in the practical thing, then you will be able to for sure understand what is this copy data activity. Let me just give you a basic thing that when we try to copy the data from one data source to the other data source, that is called as copy data activity. So when we are doing this copy data activity, we can compress our data. Means, let's suppose my data is in a CSV format. Let's say in my store 1, my data exists in CSV format, and I am doing this copy data activity and I am storing it to store 2 in, let's say, Parquet format. Okay. So as we are already aware about the fact that Parquet is a binary file format, so my data will be very largely compressed, means the volume of the data will shrink, and subsequently my bandwidth usage will also shrink, right? Because let's say this is if my CSV file is of 1 MB, right? This particular thing will be of, let's say, 10 KB, 100 KB only. Okay, or maybe even lesser. I'm not giving you the exact figure. It can be even lesser than that. Okay. Then extensive connectivity support with different data sources, right? So Data Factory provides broad connectivity support for connecting to different data sources. It is useful when you want to pull the data from different data formats. So it's not that we can only utilize the Azure storage services to connect to Azure Data Factory. We have multiple options. We can ingest it from other cloud storages like maybe Amazon, maybe from Google, maybe from Oracle, right? Some other databases there. Let's say I have externally hosted my SQL database or my Postgres database. From there, I can ingest my data from. Let's say if I am having some kind of tool, right? Let's say I'm having some Salesforce tool or some other CRM tool. I can also connect that particular CRM tool to my Azure Data Factory and I can directly ingest the data from that tool. Okay. So extensive connectivity support is there for different tools in ADF. Then custom event triggers, right? So Azure Data Factory allows you to automate data processing using custom event triggers. This feature allows you to automatically execute a certain action when a certain event occurs. Okay. So let's suppose if I have already created a pipeline and I want to trigger that particular pipeline when more than 100 rows has been added to my table. 100 rows means more than 100 new rows. My table was having 500 rows. Okay. And I have ran my pipeline on these 500 rows. Now I want to trigger an event that when 100 new rows will be added, my pipeline should run again. So I can create such kind of custom events, or maybe let's say if I want to run this, if I want to run my pipeline at 5 p.m. every day, I can run that too. I can do that too. So I can create custom events based on my requirement. Then data preview and validation. Using the data copy activity, tools are provided for previewing and validating data. This feature helps you ensure that the data is copied correctly and written to the target source correctly. Okay, so we can preview our data and do the data validation part. Then customizable data flows. Azure Data Factory allows you to create customizable data flows. This feature allows you to add custom actions or steps for data processing. Okay. So whatever my data flow should be, it's totally customizable and it's totally into my hand. What kind of data flow do I want to create? So data flow basically means the pipeline that first I will ingest my data. Then should I store directly my data to some data source, or first of all, should I do the transformation? Then after doing the transformation, what all things do I have to do? So all these things is customizable on a very, very low level. Integrated security. So Azure Data Factory offers integrated security features such as Entra ID integration, and role based access control to control access of data flows. This feature increases security in data processing and protects your data. So the underlying security features that Azure already has, such as Entra ID integration and the role based access control, all those security features can and is also implemented in our Azure Data Factory, and we can utilize those security features. Sorry, right? And we can utilize those security features to basically protect the data processing and also protect our data. Then, if I talk about the uses scenarios, so for example, imagine a gaming company that collects petabytes of game logs that are produced by games in the cloud. Okay, so if I'm having a gaming company, so I hope all of you must have heard about the BGMI, or earlier it was called as PUBG, right? So all of you must have heard and played BGMI or maybe Clash of Clans, right? All these games, right? So these games collect petabytes of data. So petabyte means 1,000 terabyte of data is 1 petabyte of data. Okay. So they are collecting uh, petabytes of data using the game logs. Means let's say when I logged in, right? So what did I do? Where did I touch? So did I log in for, let's suppose, 10 minutes, right? How many games did I play? What was my let's say I would say success rate in the game, right? How many kills did I make? And multiple more things are getting logged every second you are playing any game, right? And using these logs, these games shows you offers, right? They create new updates and all those things, right? So let's not focus on that part. Let's move forward, right? The company wants to analyze these logs to gain insight about customer preference, demographics, and user behavior. Okay, it also wants to identify upsell, cross sell opportunities, develop compelling new features, drive business growth, and provide a better experience to its customers. Okay, so using these logs itself, right, the company can get the insight of like what exactly customer wants, in what demography, means the geography or the location uh, people are using more or playing more. What is the user behavior, right? How people usually interact with the game, what is their flow, right, before playing the game, and all those things. How they can upsell and cross sell any of their products that they are making the money with, right? And what all new features can they add, or what all new things can they add to the game to drive their business more. Okay, so obviously you just using the logs. So if I show you some logs, log file example. Okay, so it's nothing but a simple text that you will be getting. Not like this. Okay, so maybe you can get a log in this particular format if you are getting in a JSON file format, or you can also get your logs in this particular way also. Okay, or in this system, right? Depends on what kind of system are you using. So images you can say, right? So this is how basically. Okay, let's not. Okay, so if you will look at this particular image, so this is also a log. Okay, this is also a log. So we will get a log in this fashion only, right? So this log, let's say if you are having petabytes of logs, so can you understand how many rows? It will be billions of rows. So obviously you can't just read those billions of rows and you can get the insight. It's humanly not possible. So for that particular thing, what we will have to do is we will have to create something using which the business decision makers can get the insights of those logs and simultaneously do their job. So to analyze these logs, company needs to use reference data such as customer information, game information, marketing campaign information that is in an on-prem data store. The company wants to utilize this data from on-prem data store, combining it with the additional log that it has to the cloud data storage. Okay, so company is also using some kind of on-prem data store where they are having the game information and the marketing campaign information, and the company wants to combine. So here there are two things. On Azure, they are storing the logs. Okay, and on on-prem service, they are storing their marketing campaign information, right? Their game information and all those things. Now they want to combine both of these things and they want to get some kind of insight. Okay, so I'm drawing this chart like this, that they want to get some kind of insight by combining both of these data, the on-prem data and the on-cloud data that basically the company is having. To extract insight, it hopes to process the joint data using a Spark cluster on the cloud using Azure HD Insight, and publish the transformed data to a cloud data warehouse such as Azure Synapse Analytics to easily build a report on top of it. They want to automate this workflow and monitor and manage it on a daily schedule. They also want to execute it when file lands in a blob store container. Okay. Now just understand the pipeline, what the organization wants. So ultimate thing, right? Basically the underlying technology or the processing, I would say the processing engine that the company wants to use is Spark. Okay. So HD Insight is the service, Azure service that provides us this Spark capability. Even Databricks is there, right? But we are using HD Insight for transforming the data, right? So we have our logs, right? We have our logs and we have the on-prem data. Okay. It is going through this HD Insight, right? There is some kind of transformation, some kind of logic, some kind of code that is written in this particular Spark thing, right? Spark computation. And after doing the computation, the transformed data is getting stored on Azure Synapse Analytics. Okay. So it is getting stored on Synapse Analytics. Okay. So again, Azure Synapse Analytics is a service where we can analyze our data. So here the data analysis will be done. Here the data analysis will be done. And now this whole thing should run on daily basis. And whenever a new data is getting attached to, when a new file lands in my blob container. So let's say this is my blob where the data is existing, and when a new file gets inserted in the blob, this pipeline should also run. Now if I have to create this kind of complex pipeline, what I can do? So Azure Data Factory is the platform that solves such data scenarios. Okay, it is a cloud-based ETL and data integration service that allows you to create data-driven workflows for orchestrating data movement, transforming data to scale. Okay, using Azure Data Factory, you can create and schedule data-driven workflows called pipelines that can ingest data from disparate data sources. You can build complex ETL processes that transform data visually with data flows, and by using compute services such as HD Insight, Hadoop, Azure Databricks, and Azure SQL database. Okay. So Azure Data Factory is the platform that will provide us this particular facility or this particular service that we can utilize to create this whole ETL pipeline that we discussed right now that satisfy these conditions. Okay. So using schedule event driven workflows, that is called pipeline, we can ingest the data from multiple sources, right? We can build complex ETL transformations using services like our HD Insight and Databricks, and we can store the data in maybe our Azure SQL database or maybe Azure Blob, ADLS, Gen2 and whatnot. Additionally, we can publish your transformed data to data stores such as Synapse Analytics for business intelligence applications to consume. Ultimately, through Azure Data Factory, raw data can be organized into a meaningful data store and data lakes for better business decisions. So using now once the transformation and each and everything has been done, we can then dump our data into something called to a service called as Azure Synapse Insight or analytics, where we can do the business intelligence part, where we can analyze our data and make the business decisions which is best suited for my business. So ultimately, using this whole workflow, I would say, or using the whole pipeline with the help of ADF, we are able to create or we are able to transform the raw data to something meaningful business insight. Okay. Now, how does it work? This is the most important question. So, Azure Data Factory contains a series of interconnected systems that provide a complete end-to-end platform for data engineers. Okay. So, let me just open this tab in a new thing, right? So here you can see the very first thing will be to ingest the data. So multi-cloud and on-prem hybrid copy data. So it can ingest the data from multiple clouds, and it can even ingest the data from on-premises infrastructure also. It has 100 plus connectors. So using without using any kind of code, we can just directly connect to more than 100 plus services. It is serverless and auto scale. Okay. So we are already aware about this fact that the serverless computation is basically that all the infrastructure and all those things, environment, runtime, and all these stuffs will be managed by the cloud itself. And we only have to pay on the event, right? Whatever time we are using it for, or on what all event we are using it for, we only have to pay for that much time, and it can auto scale. So if we require, if my traffic goes up, or let's suppose if my data volume goes up, it will upscale it, and if my data volume decreases, it will downscale it. Then use wizard to quick job copies. So we can use something called as wizard to do some kind of quick copy jobs. Then control flow. We can design code-free data pipelines, right? So this is one of the best use case, that without using a single line of code, we can create an ETL pipeline. Okay. Generate pipelines via SDK. We can also generate pipelines, or we can also write a code pipeline, and we can create an SDK for that pipeline, and we can also utilize that SDK also. Utilize workflow constructs such as loops, branches, conditional execution, variables, and parameters. Okay. So what all things we utilize in the code, we can do the same thing in the no code platform also. Then talking about the data flow. So code free data transformation that execute in Spark. So the underlying architecture or the underlying execution engine that Azure Data Factory will utilize is Spark. Scale out with Azure runtime, Azure integration runtime. Okay. So depending on our volume of data, it will either scale, like it will auto scale basically. Generate data flows via SDK. Okay. Designers for data engineer and data analytics. Okay. So mostly we can use it for the data engineering purpose and data analyst purpose. Here we will not be able to train our machine learning models, which has been included in the new service, that is Microsoft Fabric. Then we can schedule and maintain our pipeline. So build and maintain operation schedules for your data pipeline. Wall clock, event-based scheduling, tumbling windows, and change scheduling can be done. So what all these things we will be discussing moving forward. We can also monitor. Okay. So view activity execution and pipeline history, detail activity and data flow executions, and establish alerts and notifications. So we can also very easily monitor our pipeline if any kind of issue happens, if it has run successfully or not on the given schedule, right? And we can also create some kind of alert and notifications based on the requirement of our pipeline. Okay. Then this visual guide provides a detailed overview of complete data factory architecture. So let me open this again in a new tab. Okay, so what is Azure Data Factory, this and that. things to know about data factory, additional concepts, data integration. So this is just, I would say, a, a cheat code, you can say, for the data factory thing. The same thing we will be discussing here also. So need not worry too much about this picture. Okay. Then connect and collect. Okay. So enterprises have data of various types that are located in uh, disparate sources on premises in cloud, structured, semi-structured, and unstructured data, all arriving in different interval and speed. Okay, so the organizations or the enterprises, they can have their data sources at different locations, right? They may have some kind of on-prem service, they may have some of the data in some other cloud storage, maybe some external database, and like that. And even the variety of the data can be different. So it can be structured, unstructured, and semi-structured, or all arriving at different interval and different speed. So it's not that all the data will arrive at, let's suppose, 8 a.m. Right? Some of the data can arrive at, let's suppose, 8 a.m. Some can arrive at 9 a.m. Some can be streaming data. Some can be a batch data. Right? Based on the requirement. Right? The first step is building an information production system is to connect all the required sources of data and processing, such as software as requirement services, databases, file shares, and FTP web services. The next step is to move the data as needed to a centralized location for subsequent processing. So we can have multiple sources such as a SaaS platform, a database, some file shares, some file sharing transfer protocol, and whatnot. What we will be doing is that from all these different services, we will be connecting the data and we will be moving it to a centralized location to process it further. Without data factory, enterprises must build custom data movement components to write custom data movement components, or write custom services to integrate these data sources and processing. Okay. So as we are already aware about this fact that data factory provides us more than 100 plus connectors, right? If these connectors are not available, so I will have to custom write all the code, all the connectors for connecting with all the platforms that we want to utilize to ingest the data from. It's expensive and hard to integrate and manage such systems. In addition, they often lack the enterprise grade monitoring, alerting, and control over the fully managed service can offer. Okay. First of all, creating such service and maintaining such service is very hard and very complex. And on top of it, monitoring the service, creating the alerts, right? Keeping the data secure, right? Providing the role based access control, all these things, managing all these things again creates a kind of overhead. So with data factory, you can use copy data factory in a data pipeline to move the data from both on-prem and cloud data source stores to a centralized location in the cloud for further analysis. For example, you can collect the data in Azure data lake storage and transform the data later by using an Azure data lake analytics compute service. You can also collect data in Azure blob storage and transform it later by using Azure HD inside Hadoop cluster. Okay, so this is basically the ETL and the ELT process that we were talking about. Then transform and enrich. So after data is presented in the centralized data store in the cloud, process or transform the collected data by using ADF mapping data flows. Data flows enable data engineers to build and maintain data transformation graph that execute on Spark without needing to understand Spark cluster or Spark programming. Okay. So this is the backbone, I would say, of Azure Data Factory that we can create. So once the data has been dumped into the centralized data store, now to process and to transform that particular data, we can use ADF mapping data flows. Okay. And these data flows enable us to build and to maintain the transformation graphs, or basically the the transformation pipeline, the underline. So if I talk about this, so let's say this is my data store where all of my data is residing. So this is my raw data. Okay. Then from this raw data, I can utilize ADF data flows. Okay, ADF data flows, which will ultimately use Spark as the processing engine. Okay, so all the transformations and all the things will be done here. Okay, transformation will be done here. Okay, and we can write these transformation without even understanding about the Spark cluster. Okay, and without knowing Spark programming language, we can create this whole ETL pipeline. Okay, you can prefer to code transformations by hand. ADF support external activities or executing your transformation on compute services such as HD Insight Hadoop, Spark, Data Lake Analytics, and machine learning. Okay. Now, if we don't want to use the no code platform, we can also write the code by ourselves if we feel like that. Okay, that level of flexibility and that level of customization is not present in the no code platform or basically the ADF. Then we can also utilize services like HD Insight Hadoop to write our own custom code for the transformation part, and we can connect that HD Insight Hadoop to our ADF data pipeline. How we will be doing all these things? For sure, we are going to look in the further videos. Then CI/CD and publish. So Data Factory supports full CI/CD for data pipeline using Azure DevOps and GitHub. It allows you to incrementally develop and deliver your ETL processes before publishing the final product. After the raw data has been refined into the business ready consumable form, load the data into Azure Data Warehouse, Azure SQL Database, Cosmos DB, or whichever analytics engine your business users can point to for the further business intelligence tool. So the whole CI/CD, continuous integration and continuous development part, can be managed by the Azure DevOps platform or GitHub. Okay, we can incrementally develop and deliver the ETL processes after we have published the pipeline. The whole ETL pipeline we have published. We can also keep on developing and keep on updating our pipeline and making it even better. When our raw data has now been changed to or maybe transformed to a business ready data, right, we can store that particular data into Azure Data Warehouse, Azure SQL database, or maybe Cosmos DB, or whichever data store we feel like uh, is good enough for us to store our data. Talking about the monitoring part, so after you have successfully built and deployed your data integration pipeline, providing business value from refined data, monitor the scheduled activities and pipeline for success and failure rates. Okay, we can monitor our pipeline that for, how many times did my pipeline succeed, how many times did it fail, right? If it failed, why did it fail? We can analyze those logs and we can later on get it fixed. ADF has built-in support for pipeline monitoring via Azure Monitor API, PowerShell, monitor logs, and health panels on the Azure portal. So we can utilize these services for monitoring our pipeline. Cool. So this was pretty much it. If I talk about the basic of ADF, okay, the basics of Azure Data Factory. If I talk about, so this was pretty much it. In the next video, we will talk about the top level concepts of ADF, right? What is pipeline activities, data sets, and all. And we will simultaneously try to look at that particular thing in practical. And we will try to launch our first Azure Data Factory environment. Cool. So I hope you learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course. And in this video, we are going to talk about the top level concepts in Azure Data Factory. So we have already discussed about what is cloud, what is Azure, how we can create a free Azure account, and the basics of, or I would say the introduction of Azure Data Factory. Now in this video, we will be talking about the components and the top level concepts of Azure Data Factory. So with that said, let's get straight into the system and let's get started. So the top level concepts in Azure Data Factory is that an Azure subscription might have one or more Azure Data Factory instances or data factories. Azure Data Factory is composed of the following key components, that is pipelines, activities, data sets, linked services, data flows, and integration runtimes. So the hierarchy is something like this. So we have our Azure account. Okay. Inside this Azure account, we can have multiple subscriptions. Okay. So let's say subscription 1. Okay. And we can have, let's say, so I'm writing just subscription 2 as S2 and subscription 3 as S3. So we can have multiple subscriptions in one Azure account. And inside this one subscription also, we can have multiple ADF created. So we can have, let's say, ADF 1, we can have ADF 2, right? ADF 3 and so on, right? So this can be the whole hierarchy that you can follow. In your Azure account, you can create subscription, and inside your subscription, you can create your Azure Data Factory instance. And inside your Azure Data Factory, you will have these components. So let's one by one understand what these concepts are, and then we will be following them in I would say practical. These components work together to provide the platform on which you can compose data-driven workflows with step to move and transform data. The first one is pipeline. So Azure Data Factory might have one or more pipelines. A pipeline is a logical grouping of activity that performs a unit of work. Okay. So pipelines will be basically a group of activities. So here if you will look, so there is something called as activities. So group of activities that are performed together in one single unit logically, right? It's not that you can we can just randomly put these activity and it will form a pipeline. We have to define the flow and the logic of these activities. Okay. Together, the activities in a pipeline perform a task. Okay. So all these activities combined together will perform a task. For example, a pipeline can contain a group of activities that ingest the data from Azure Blob. Okay. So the data is first of all ingested from Azure Blob. This is one activity. Okay. Then runs a Hive query. This is activity 2 on HD inside cluster to partition the data. Okay. So this is basically whole. This whole is basically activity 2. Okay. So combining these two activities will together create a pipeline. The benefit of this is that the pipeline allows you to manage the activities as a set instead of managing each one individually. The activities in a pipeline can be chained together to operate subsequently, or they can operate independently in parallel. Okay. So even the activities can operate independently, like they don't require any kind of pipeline to operate, as well as they can be chained together, or basically they can be grouped together into a pipeline to perform that particular group of activity. Then mapping data flows. Create and manage graphs of data transformation logic that you can use to transform any sized data. You can build up a reusable library of data transformation routines and execute these processes in a scaled out manner from your ADF pipeline. Okay. So we can manage the data transformation logic on any volume of data. We can build a reusable library, means whatever pipeline that we are creating, we can reuse that particular pipeline whenever it is required using our ADF pipelines. The data factory will execute your logic on Spark cluster that spins up and spins down when you need it. Okay. So the Spark cluster, we don't have to keep it running on a 24/7 hour basis. Whenever we will require, or whenever we will be executing our pipeline, and if it requires some kind of a Spark job to be executed, then it will automatically spin up a cluster. And when the Spark job has been completed, it will spin down, or you can say it will delete, or it will uh, it will down that particular resource. So we are not getting charged for it. Basically, we can save our money. You won't uh, ever have to manage or maintain the clusters. Okay, so it's the responsibility of the cloud service provider, Microsoft in this case, that they will have to manage and maintain the Spark cluster on which our code will be executed. Then activity. So activity represents a processing step in a pipeline. So you can think of activity as the smallest unit of the smallest unit. Okay, so this is the smallest unit which we can have in our pipeline. For example, you might have to copy activity. You might have to use copy activity to copy data from one data store to another data store. Okay. Similarly, you might use a Hive activity which runs a Hive query on Azure HD inside cluster to transform or analyze your data. Data factory supports three types of activities: data movement activities, data transformation activities, and control activities. Okay. So inside these activities, there are further more activities. This is basically a group of activities. So data movement activities means that we have to move, or we have to copy the data from one data storage to the other data storage. Then comes the data transformation activities. It means we will be doing some kind of processing, some kind of transformation on top of our data. Okay. And then there are control activities, means how will I control, basically the access control and all these things we are talking about, that who can access what, right? What level of access, role based access basically we can provide. So all these control activities can also be done here in the data factory. Then we have data sets. So data sets represents data structures within the data stores, which simply point to or reference to the data you want to use in your activity as input or output. Okay. So data sets are basically the storage devices, or I would say the storage locations, which we will point that, okay, so let's suppose if I want to use ADLS/customers, right, /January, and inside that particular directory I will have my data. So I will point to that particular directory as a data set, that okay, you can pick up the data from here, then maybe you can run your transformation, and you can then you can write your data on, let's suppose, customers/January, or maybe customer/output/January, and in that particular directory you have to output. So I will be referencing those data storage locations as data sets in my data factory. Then there are linked services. So linked services are much like connection strings, which define the connection information that's needed for data factory to connect to external sources. Think it of this way: a linked service defines the connection of the data source, and a data set represent the structure of the data. For example, an Azure storage linked service specifies a connection string to connect to Azure storage account. Additionally, an Azure blob data set specifies blob connector and folder that connects to that contains the data. Okay. So linked services will be basically a string kind of value. Okay. And that particular value will also have, like, it will be a kind of location that we usually have, right? So let's suppose if we are working on our local system, so we have the directories, like, so let's suppose my computer. Inside my computer you have to go to D drive, then in D drive you have to go to some folder, and like that. So this is basically a location or a string of values that is basically specifying that at this particular location you can get your data or you can basically write your data, right? So let's suppose this Azure, we are using this Azure storage as a linked service. So this string will basically specify the connection to my storage account. Okay, and again this blob data set will specify that okay, in this particular container and in this particular folder you have the data. So linked services are used for two purposes. First, to represent the data store that includes, but it isn't limited to, let's suppose SQL Server database, Oracle database, file share, and blob cloud storage account. So a list of supported data types, you can see copy data activity article here. Okay, so first linked service is that it will represent that this is the data source you have to, let's suppose, pick up the data from. So that data source can be anything, right? It can be a SQL server, it can be a Postgres server, Oracle DB, right? Blob or something. Second, it can also be used to represent compute resource that can host the execution of an activity. For example, the HD Insight Hive activity runs on HD Insight Hadoop cluster. For the list of transformation activities supported compute environments, you can see this particular list right here. So if I go to this copy activity article, right? So you will be able to see the list of things we can have, right? So you can see Azure Blob, AI Search Index, Cosmos DB, Cosmos for MongoDB, and all these list of services we have. And you can see right here for what all support it is, basically for all what all sources it is supported. Okay, so you can support as source and support as sink. Here you can only if I talk about MariaDB. Okay, so MariaDB you can only connect as a source. You cannot use MariaDB as a sink. Sink basically means to write your data. So you cannot transform and write your data into MariaDB, but you can ingest your data from MariaDB for sure. Similarly, if I talk about, you can see Oracle, Amazon ADS Oracle, right? So you can connect to your ADF and you can ingest your data from your RDS SQL server. But you can't write your data. Obviously, why will Microsoft want that? Okay, you can transform your data from your Azure and then you go and write your data in your Amazon. Obviously, none of the company will want it, right? So similarly, Redshift, you can ingest your data from Redshift, do the transformation here, and then store the data on my platform itself. Okay. Again, talking about the transformation thing. So you can see what all transformations can be done here in the list. Okay, so okay, fine. So these are the list of transformations basically. So you can use HD Insight, Hive activity, Pig activity, MapReduce, streaming, Spark, and all these things, ML Studio, right? So all these activities are possible in possible as a linked service in ADF. Then integration runtime. So in Data Factory, an activity defines the action to be performed. A linked service defines the target store or a compute service. Okay, and integration runtime provides the bridge between the activity and the linked service. It's referenced by the linked service or activity and provides the compute environment where the activity either runs on or gets dispatched from. This way the activity can be performed in the region closest possible to the target store or compute service in the most performant way while meeting the security and the compliance needs. Then we have something called as triggers. So triggers represent the unit of processing that determines when a pipeline needs to be executed. Pipeline execution needs to be kick off. There are different types of triggers for different type of events. Okay, so trigger basically means a kind of condition, you can say that on what condition will I run my pipeline on, and those conditions are basically called as triggers. Then pipeline runs. So a pipeline run is an instance of the pipeline execution. Pipeline runs typically initiated by passing the arguments to the parameters that are defined in pipelines. The arguments can be passed manually or within a trigger definition. So basically the execution, or when the pipeline is in a running phase, that particular thing is called as pipeline runs. And the number of times the pipeline has basically um, completed, I won't say completed, it has tried to run, okay, even if it has failed or if it ran successfully, both will be considered and both will be represented in the pipeline runs section. Okay, now pipelines can also accept some parameters, and these parameters can be either passed manually, right, or it can be also passed in the trigger definition. Then talking about parameters, so parameters are key value pairs of read only configuration. Parameters are defined in pipeline. The arguments for the defined parameters are passed during execution from the run context that is created by a trigger or a pipeline which was executed manually. Activities within pipeline consume the parameter values. Okay, so parameters are nothing but a kind of key value pair which will only be a read only configuration. Parameters are defined inside pipeline. The arguments of defined parameters are passed during the execution of the run context when the pipeline was triggered. So these parameters will be passed when we are trying to run the pipeline. Okay, and these parameters can be either passed manually or when the pipeline, like within the trigger definition of the pipeline, both will be possible. Activities within the pipeline consume the parameter values. Okay, then a data set is a strongly typed parameter and is reusable and referenceable entity. An activity can reference data sets and can consume the properties that are defined in the data set definition. So if I will point to some kind of data set, okay, some kind of storage location that we are pointing to, right, so that is also a parameter that we are passing, that okay, this is where you have to read the data from, and this is where you have to write the data to. So this is a kind of parameter, right? Then the linked service is again a strongly typed parameter that contains the connection information to either a data source or a compute environment. Again, it is also a reusable and referenceable identity. Then talking about the control flow. So control flow is an orchestration of pipeline activities that includes chaining activity in a sequence, branching, defining parameters at the pipeline level, and passing arguments while invoking the pipeline on demand or from a trigger. This also includes custom state passing and looping containers, which is for each iterator. Okay, so custom flow is nothing but uh, a kind of you can say statements, just like we have for loops, just like we have if else loops inside a if else condition inside a programming language. Same kind of condition and same kind of custom flows, like you can say a kind of condition based flow or a kind of iteration based flow we can create inside our ADF also. Okay, then we have variables. So variables can be used inside a pipeline to store temporary values and can also be used in the conjunction with parameters to enable passing values between pipelines, data flows, and other activities. So variables can be either used to store a temporary values inside the pipeline, or it can also be used with the parameters to store some kind of values depending on our activity. Okay, cool. So these are mostly the top level components, you can say, or by using all these components together, right, we will be creating pipeline in our Azure Data Factory environment. Okay, now if we see if any kind of new thing has happened in ADF. Okay, so these are the things which you can see, the bug fixes and all those things that has been done. Cool. So if you want to read it, you can read it. Else uh, there is no too much of information that you will get in this particular section. Cool. So this is pretty much it for this particular video. I will see you in the next one, and I hope you learned something new in this particular video. Till then, keep learning and keep growing. Bye bye. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course, and in this particular video we are going to launch our very first Azure Data Factory in our Azure cloud. So we have already talked about multiple things till now in this particular course. We have seen that what is a cloud, right? What is Azure and how we can create a free Azure account. We have understood about Azure Data Factory and the key components of Azure Data Factory. So with that said, let's get started with this video and let's get straight into the system. So what I will do in this video is I will just kind of teach you, right, that how to read the documentation, how to understand it, and how you can follow the documentation to get your things done, right? From the further videos, what I will be doing is I will not be referencing the documentation for each and everything. I will be just showing you that particular thing on the fly, right? But only for this video I am teaching you and I am showing you how you can refer to the document, basically the official documentation, and you can get your things done. Okay, so if you want to create your own data factory in the Azure cloud, how we can do it, right? So let's get started and let's get directly to the documentation to see how they are like the developers of the Azure cloud themselves and the data factory themselves are asking us to do that particular thing. So welcome to Azure Data Factory. This article helps you create your first data factory and pipeline within 5 minutes. So you can just understand what is the time required. So if let's first of all, first of all, deploy our first data factory, and then we will talk about this. So the Azure Resource Manager template, ARM template, in this article creates and configures everything you need. Okay. Then you can go to your demo data factory and trigger the pipeline which moves some sample data from one Azure storage to the Azure Blob storage. So the prerequisite that we have is you don't have an Azure subscription. You can free account, you can begin your free account. So the only thing, you can also refer to this particular video, right? But we will go through the text or the documentation itself. If you are having an Azure account, you don't need anything else. So in this demo scenario, we will use the copy activity in Azure Data Factory to copy a blob named movie 2 moviedb2 CSV from an input folder of Azure Blob Storage to an output folder. In the real world scenario, this copy operation could be between any of the many supported data sources since available in the service. This could also involve transformation in the data. So in this particular case, what we will do is we will only try to do a single copy data activity, that we will try to move the data from the blob, from the Azure Blob storage to the other Azure Blob storage. In the real world scenario, only this copy activity will not happen, right? For sure, we will have some kind of transformations involved in between the copy data activity. Okay. Select the following button. So if I will click on this Azure, try it now. So I will be redirected to this particular portal. Okay. Then selecting the create button from the Azure Data Resources in Azure Data Factory and Azure Data Factory account, the Azure Data Factory that contains a pipeline with copy data activity, Azure Storage Blob with. Okay, if I will just click on this, it will have all the things attached to me already. Okay, so an Azure Blob account with this particular data uploaded to into an input folder or a source, and the link to connect to the blob storage. Okay, you will be redirected to the configuration page to deploy the template on this particular page. Okay, so for resource group, so let's just click on this particular thing, this link. So it will take a few seconds. Okay, and now I am redirected to this page. So you can see here it has automatically from like it has used a template, right? If we want, we can even edit the template. So this is a JSON file, right? You can see here what all things will we be using. Okay, here you can see, right? So resources wise, we will be using the account name. Okay, not this resources I'm talking about. PowerShell linked devices. Okay, data sets, right? You can see right here. Okay, we will be using the Azure Data Factory linked services. Okay, and this linked services will be linked to Azure Blob Storage, right? Then we will be using the data sets, right? And blob location we will be basically providing, and all those things. So basically this is a predefined format, right? Okay, I am back here, right? So let's do one thing. Let's go back again, a bit more back to the documentation, and let it open in a new tab. Then now let's come back here and let's see what documentation is asking me to do. You are redirected to the configuration page to deploy the template. On this page, for resource group, create a new resource group. You can leave all the other values with their default. You can select, then you can select preview plus create, and then you can create the deployed resources. So here I have to come here, right? I have to click on, so I have already created some resource groups, but if you don't have, if you are using it for the very first time, you will not have any kind of resource group. So you can just click on create new. You can name it. So let's say I'm using ADF group. Okay, I have created this new resource group for my the ADF. So what resource group does is, if I'm attaching a service to a resource group, so what Azure will do, from ADF itself, it will have multiple other services that will be required to spin up that particular ADF instance. Okay, we can have, let's say, Azure Blob, where it will write the service. We can have HD Insight, using which it will do the transformation and all those things. So it will attach all those services and all those resources to this ADF group itself, so that we can clearly visualize and we can clearly know that, okay, these are the services, the underlying services that we have not triggered ourselves, but ADF is using all those services. So I can create a new resource group, and rest of the things I am keeping as same. Okay, and then I will click on this review and create. Okay, so it's running the final validation. It will take a few seconds to run the validation. Now the validation is checked, completed, and I can just click on this create button now. Right, so you can see here, now it is initializing the deployment. So deployment is in process. It will take again a few seconds to do the deployment. You will see a list of services that will be deployed here. Okay, so you can see it has created the deployment script. Using deployment script, it has created the storage account. So it has created multiple storage accounts, right? It will take a few seconds, and it can even take a few minutes also, depending on what kind of template we are using. It's taking a bit long time. Okay. So now you can see after taking around 3 to 4 minutes, the deployment is now complete. Okay. So you can see all the deployment details here, that what all things was deployed, right? So the data factory resource was deployed, right? All these things, right? Copy data file was deployed, right? Storage and all these things were deployed. Storage account was deployed, deployment script, Azure data factory, right? And all these things you can see right here. Now what I can do is either I can go to my resource group, so I can just click here, right? Or I can just click on this go to resource group, or what I can do is I can just click on the resource that is saying that this is the data factory instance that you basically have. Okay, so here again, if you will look closely, so you can see that this is my data factory name, right? This is the location that we have. Output wise, so currently there is no output. If you want to check the template, so you can check the templates right here in this, right? You can also download it, right? If you want, you can edit it, and then you can redeploy also if you want to do some kind of changes, right? You can just click on this redeploy after doing the changes in template, and you can do it. If you want to download the template so that later on you can automate those things, you can do that too. Cool. Now let's click on this deployment details, and I will click on this data factory v2 thing, and now I will just click on this launch studio. Okay, let's just follow here, right? So here again, you can see that the resource group includes the new data factory, blob storage account, and the manage data activity that the deployment has created. Select the data factory resource to view it, and then once you will view that resource, you will have the option to click on launch studio. So once you will click on this launch studio, okay, so it will show you something like this. Let me just zoom in. Okay, it will show you something like this. Now what we have to do is in the Azure Data Factory Studio, we can select as author tab. Okay, so I can just click on this, I can close this, right? And then I can click on this author tab. So I guess it is 150%. Yes. So proportion is fine. This is our home page. We can click on this ingest to, if we want to ingest, if we want to create a new pipeline, a Power Query, data flow, data set, something, we can add it. We can orchestrate data transformation, connect to any SSIS. We can do it for sure. Now what the very first thing I will do is click on this author. And as soon as I click on this author tab, I am redirected to this page where I can create my pipeline. So I will just keep on following the documentation. Select the author tab, click the pipeline that the template created. Okay, so if you will come here and if you will go to this pipeline section, so you will see that there is already a pipeline that has been created, right? And you can see a copy data activity, right? So we have already seen that what is a activity, right? It is basically the smallest unit inside your data factory. So a copy data activity has been created by this template itself. Okay. So you can you have to click on this, you have to click on this pipeline, and then you have to click on this source, right? So let's click on this pipeline, and I have to click on this source. So here you can see this arm template test dataset dot in. Okay, this is the source. It has already been selected. So all these things, when we will try to create the data factory from the scratch, all these details we will have to put by ourselves. But here you can see that the data set, this is basically a parameter that we are passing, right? So the parameter has already been inserted. So select the pipeline of the template, click the source data by selecting open. In the source data set, select browse to view the input data created for the demo. Okay, so I will come here and I will click on this open, and then I will click on browse. Okay, so I can click on this thing, data factory input, right, and .csv, and I will click on OK. So okay, this is a binary data, right? So you can click on browse. Note that this was up to date in the note that db is already uploaded in the folder. Okay, fine. So it is already uploaded, right? If it would not had been a binary file format, we would have also able to see that data here in the output. I can also just click on this test connection, and you can see that the connection is successful. It means that the data exists here and we can do our thing whatever we want to do. Next we will do what? We will trigger the demo pipeline to run. So select sorry, select add trigger and then click on trigger now. So I will go back to my this. Let me close this, discard and changes. Here I will have to click on add trigger, and I can click on trigger now, right? So you can see triggering pipeline using the last published records, and I can click on OK. Let's just see what it's saying, right? I can click on trigger now. Okay, right? It will just trigger it. I can click on OK, and you can see it has successfully started running this pipeline. And now what I need to do is I need to go in this monitor tab, and you will see here that the pipeline has started. Oh, let me go to the documentation. So now we can monitor our pipeline. So select the monitor tab. This tab provides an overview of the pipeline runs, including the start time and the status. Okay, so you can see right here. Okay, so right now the status is in progress. It is trying to do the thing whatever we have written in our pipeline. So now we have got the message as run succeeded. In a few seconds, I guess it will update automatically. Else I can also refresh it. Let's wait for a few more seconds. If not, we will refresh it and the status should be changed to completed or done, something like that. Okay, it's not doing. Let's refresh it. So I had to manually refresh it, right? So after refreshing, you can see the status has been changed to succeeded. The time it took was 25 seconds. The runtime, like the pipeline started running at 14th of December 2025 at 1:35:48 p.m. right, and it started like it ended at 1:33:12 p.m. So basically it took 25 seconds to run. It was triggered manually. Okay, run ID was this, right, and all those things. If you want to get more detail, you can just click on this and you will be redirected to the pipeline with all the details that we have, right? You can see a list. If you want to see the Gantt chart, so you can also see the Gantt chart of the pipeline run, right? So you can see here in the quick start, the pipeline has only one activity of the type copy data. Select the pipeline to view the details of the pipeline data activity runs, right? So you will see all the details here. Select the details icon to display the detail copy process. Okay, so we have to click on this what do we call this specs icon or the details thing, right? So if you will click on this details, you will be able to see all the things in very detail. You can see the activity run ID, right, and what all things happened. So from Azure blob storage region in central India, right, it copied the data. You can see here, right, you can copy the data to another blob region in central India, Data read was 445 KB. File one, while one file was read at peak connection, only one connection happened, right? How much file was written? This much file was written, right? Like this was the size of the file that was written. Number of files was this. At peak connection, total connections was this. Total duration 13 seconds. Throughput was this much. Total what activity did it do from Azure Blob Storage to Azure Blob Storage? Start time. Total DIU. It means data integration unit. DIU stands for data integration units. So total 4 data integration units was used. Used parallel copies, right? So it was one duration, then queue transfer. So you can see a very in-depth information about the pipeline here, right? And then you can see we were having the same details. Obviously we will have the same details because we did the same thing what the template has given us. Then now the most important thing, right? If you are in the learning phase, clean up your resources. You can clean up all the resources that you have created in this article either by two ways. You can delete the entire resource group which includes all the resources it has created. If you want to keep some of the some resources intact, go to resource group, delete into specific resources that you want to remove. For example, if you are using the template to create the data factory for another tutorial, you can delete other resources but keep only the data factory thing. Okay, now we have to delete our resources. So what I will do, I will come back to this template and I can manually select the resource that I want to delete. So let's say if I want to delete this resource, I can click on that resource and I can click on delete and I can click on yes. So now that resource has been deleted. I can delete whole of the resource group that I have created by just clicking on this delete button. And for this time, I will be deleting my whole resource group because I will be charged for each and everything that this resource group is utilizing. Okay, I will be charged for the deployment script. I will be charged for the storage account that has been attached to my data factory. Okay, so that I am not getting charged for any unused resource, what I will do is I will just delete and I will just erase all the resources that I have created for this particular video. Okay, so I will just click on this delete, and I will click on this delete. So you can see it has highlighted all the things. So I will just click on this delete deployment, and now the deletion is in progress. Slowly and gradually it will try to delete all the resources that it has created. So again it will take a few seconds. So you can see now it has deleted the deployment. Okay, now if I will if I will try to access, you can see because recently we have accessed this, but if we'll try to access this particular thing, right, it will say that the resource is not available, kind of error it will give you because we have already deleted it. Okay, I don't think that it should work. Okay, this is strange. Let me just check it again. If I am going into my not subscriptions, I want to go to my resource groups. So resource groups, if I go here, so ADLF group is right now for some reason not deleted or what? Okay, it has it has not deleted these resources, right? So I will come back again here, right, and I will try to delete this all resources. So why should I get charged? So you can click on this delete resource group. I will have to name my resource group. So my resource group is ADF group, and I can click on this delete button now. Okay, Control V, delete. Okay, why it's not deleting? Let me just refresh it. delete. Okay, and now it will delete all the resources that are present in that resource group. So we can even not delete these resources. Why? Because we will not get charged. If we will only be get charged in the data factory when we are utilizing or running a pipeline. Okay, same goes with our storages. If we are doing some kind of throughput, then only we will be charged until unless we are not use the full free tier of the resource. That was, I guess, 30 GB or something, right? So we can let it be, but I'm just showing you that if you want to save money, right, and you want to be on the safer side, you can do that particular thing also. Else, we have already created a trigger, right? That if uh, the trigger on the budget, that if there is some limit users, I have set my budget to 10 rupees, and if I am utilizing 8 rupees, so it will send me an email that okay, you need to look at your resources. Basically, you have used your resources up to 80% of the budget that you have set. Then I will get an other email at the 90%, right? And then subsequently I will keep on receiving it till the time I have set. Now you can see all the resources has been removed from the resource group. I can now close, refresh this. Okay, and now if I go back to my home, you can see even from the recents that data factory link and all those things has been automatically removed. Cool. So again, cleaning up your resource is very, very important. You need to keep this in mind if you don't want to get caught up with the extra bill, even for the bill that you haven't utilized the resources for. Cool. So this was pretty much it for this particular video. I hope you learned something new. I will see you in the next one. Till then, keep learning and keep growing. Bye bye. Hi guys. I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course. And in this particular video, we are going to see how we can launch a Azure Data Factory instance from scratch. So in the previous video, we have already launched a data factory instance, but we were using a predefined template that was given to us by the Microsoft people themselves. And we were using that particular template to launch the data factory. In this video, we will be doing each and everything from the scratch. Okay. So let's get started with the video and let's get straight into our system. So when you will be on your home screen of your Azure portal, this is how something it will look like. Maybe you don't have these resources and recent thing if you are using it for the very, very first time. Cool. So here what you can do is on the top of this search bar, either or even in this create a resource tab, you can click here. Okay. And then you can manually search what kind of resource do you want. So here, let's suppose I want Azure Data Factory, right? So I don't need to write Azure because we are working in the Azure cloud itself. So it clearly means we will be requiring Azure Data Factory. So, okay, private offers. Oh, no, I don't need any kind of offer. So here you can see, right? Just keep in mind, you have to read, right? Azure Data Factory. This is Azure Data Factory dashboard provided by into Intel organization, right? Which starts at this much cost and all those stuffs. Here it is Azure Data Factory provided by Microsoft. So obviously we will go ahead with this particular service, right? And here it's some icon, okay, benefit available and all those things, right? So I can just click on this particular service, right? Then it will ask you your subscription and your plan, right? And you can click on create. Okay. Now it will load you to a page where you will need to fill up certain information. So firstly, your subscription. So if you have more than one subscription, you can search. But by default, if you are having your personal account, you will only be having one single subscription. That is the highest chance. You can have multiple. It's not an issue. Then there comes the resource group. So if you have created any kind of resource group, you can attach that particular resource group if you want, or if you want, you can create a new resource group. So what is a resource group is, so our hierarchy will be something like this, that we will have our account, our Azure account basically. Okay. Below this Azure account, we can have subscriptions. Okay. So we can have multiple subscriptions. So let's say subscription 1, subscription 2, and so on. Inside this subscription, we can create resource groups. So these resource groups will do what? Okay, resource group, let's say resource group 2, resource group 1. So these resource group will keep a track of all the resources which is required for let's say running one service or a group of services. So we can create this resource group maybe based on the client. Okay, so let's suppose we are having a client 1. So we can create a resource group as, let's say, client 1, and we can create a resource group as client 2, and we can attach all the services that is required for client 1 in the client 1 resource group, and we can attach all the resource, or whenever we are basically spinning up a resource for, let's suppose, client 2. So we will attach that particular resource to a resource group of client 2, so that we have a clear segregation that, okay, if this resource is spin up, this is spin up for client 1. If this resource is spinned up, this is spinned up for client 2. So that we can have a separate segregation. We can bill accordingly, right? We can be transparent with the client that, okay, these are the resources that were required to complete your project. This was the total runtime of your instance, and hence this is the billing of it, right? So basically it creates a kind of transparency, and it is very, very easy to manage if we are working on multiple projects. So for my resource group, right, I have created my resource group as VS17. So when I will be creating any instance in this basically account or subscription, so I will attach it to my resource group, so that, let's suppose, when the admin looks into the account, that, okay, who is using what resources and how much was the billing of whom, right? So all these things can be done very, very easily. Okay. Then now we will have to give my instance name. So let's suppose I am giving my instance name as ADF demo. Okay. Here I can choose reasons. So is already taken, let's say, some random numbers. Okay. Now I will have to choose the instance. So this name should be unique in this particular region. Okay. So region wise, by default it's US East, but we have multiple regions: Australia Southeast, Australia East, Belgium, Brazil, Canada, right? Chile. Then we have US, France, Germany, Israel, and all these things, right? So is there is any reason for India? So we have South India, we have, right, and Central India we also have. So let's go ahead with Central India. Okay, it's usually recommended that you choose the region that is shortest to you or closest to you, right? In that case, the latency will be less. That's it. There is no other reason. I can go ahead with US also. It's not that I can't launch instance in the US. I can do it, but because my location currently is in the north part of the India, so I am choosing Central India, so that the data center is basically close to me. Then I can click on next. So if I want to create some kind of Git configuration, if I want to create the versioning and all these things, so I can either use Azure DevOps. Okay, I can give the account name, project name, repo name, branch, and all those things, root folder, right? Or I can use GitHub. So again, I can give my GitHub account. I can give my repository name, the branch name, and the root folder, and I can configure my data factory with the Git version system or the version control. Okay, but here I will not be configuring it for right now. I will configure it later on. Then I can click on next, and I can click on the I can jump onto networking part. Okay, so here you can see if a person can connect via public endpoint or not. So let's suppose if I want to keep the service in a kind of self-hosted environment, so I can keep it in the private endpoint. And here managed virtual network, so choose whether you want the default auto resolve integration runtime to be provisioned on demand instance in the ADF virtual network. Okay, so if we want this service of default auto resolution integration runtime, right, so we can just click on this, check this box on, right, else let it be, right. We will go ahead with the default configuration itself, but I'm just letting you know, guys, that these are the options that are also available to us. Then we will go on to the advanced thing. So if we are managing any kind of keys, any kind of, let's say, any kind of API key, secret key, right, personal access tokens and all those things, so these things can be managed with a service called as Azure Key Vault. Okay, so we can use, or we can manage these keys using the Azure Key Vault service if we want to. So we can enable the encryption thing, but currently we will not be managing any kind of, or basically using any kind of API or personal access token, so we need not do those things. And then we can provide some tag if required, so I can give a name and give the value of that particular tag, and I can do it. And then I am right now on the create and review page. Okay, so I can just click on this create, and if I want the template, so whatever details I have filled basically here, right, so all these things will be created in a form of a JSON file. So this similar kind of template we have seen in the last video also, right. So now if I am giving this template to someone, and like I can download this, I can give this template to someone, right, any other user can just launch his or her data factory using this template only. So the benefit will be that we both will have the same kind of environment, same kind of basically all these configurations set and everything. So let's say I have set some kind of network, I have done some kind of git configuration and all those things. So the other person who will not, like, the other person will not have to do it again manually if he is having the template. And then I can click on create. So here you can see it is submitting the deployment, and the deployment now is in progress. Okay, here you will be able to see the deployment name, when the deployment started, correlation ID. Okay, so deployment is succeeded. Okay, the resource group, then the deployment details. So this is our resource, this is the type of the resource, status is okay. If you want to get some kind of operational details, you can get all your operational details here. So basically, what was the operation ID, the operation name, provision operation, that what exactly did we do, what is the state, so it succeeded, what is the timestamp, duration, tracking token, service request, and all these things is available right here. Okay, then talking about the inputs, right, so if we want to give any kind of let's say key name, right, base URL and all those things, so these inputs are a kind of variables. Okay, then output, so currently we don't have any output, and template we have already seen that we can download if required. Okay, and now once the deployment is done, I can click on this particular button to go to the resource. Okay, and then I will click on my demo. Okay, so this is my resource. Here again you can see multiple things. I can delete my resource with the resource group that it is connected to. If I want, I can move it to some other resource group, right from here also. I don't need to launch it another time. I can directly move it if I want to. What is the status? So it's succeeded, the location is here, this is the subscription name. If I want to again move it, I can move the subscription, like move it to some other subscription if required. Subscription ID is this, type is data factory version 2, and if you want to look at documentation and all those things, you can just click on this get started part. Okay, monitoring and all those things you will be able to see here also. Pipeline runs, activity runs, trigger runs, CPU runtime, memory runtime, and all these details are here. Quick start tutorials, template gallery, training modules, you can view right here. If you go to the activity log, so you will be able to see all the logs related to your basically related to your instance. Okay, so you can see currently we have just created, right? We have created a data factory. So you can see create or update any data factory. So these are the logs, the change history and all those things you will be able to see right here. Then the IAM access. Okay, so if you are working in an organization, this particular thing will be very, very helpful for you, especially if you are on a senior role, right? If you are on a role of, let's suppose, senior data engineer, or maybe some kind of you are a product manager, or maybe a kind of engineering manager and all those roles. So it will be your responsibility to assign these accesses to the junior developers, or to the people who are in your working in your team, right? So that it is you who is having all the access and not them. Okay, so here you will have to if you want to view your access, you can view whatever scope and basically whatever things here. So I am the owner here, right? Because obviously it is me who has created this instance. So the role is service administrator. Description has full access to all the resources in the subscription. Okay, then if I want to check access, I can check it. If I want to grant access to this resource, I can click on this add a resource assignment. Okay, and then I can basically, if I want to add it to some other user, okay, so I can add some other user as, let's say, owner, collaborator, right? Access review operator service, right? Then you can see IoT operator onboarding, Azure resilience management, and for all these services you can see the description. Okay, see the category, and you can also see the details. So this is basically the administrator role privilege, and then this is the job role privilege, right? So here you will be able to see there are multiple, basically for every service you will be able to see some kind of job role. So if I search here for, let's say, data factory, okay, so there is one role as data factory contributor. So I can just click on this view. So you will be able to see these are the permissions. Okay, these are the permissions, these are the types, and this is the description, that he can acquire the policy token operation, he can get the administrator, like he can just read these things, right? He is having the right access. If you talk about, so he can read the data factory, he can create and update the data factory, he can even delete the data factory, right? And all these operations and all these basically authorizations he has to do these many operations if I'm adding someone as a data factory contributor. Okay, so here you can see the assignment, I can add assignment. Okay, and so here you can select the role, then you can come here on the members tab. So if you want to add some members, you can add your members using the Gmail account. I won't say the Gmail account, the Azure account of those members. So I can search. Currently, I'm not having any other Azure account, right? So I won't be doing any kind of adding members. But you can just search for the Azure account that your fellow developer or a colleague can have, and you can just click on that, like send him the request, just like you send your request maybe for your Google Drive, right? You can share your Google photos and any folder of your Google Drive, right? So in the very similar way, you will be assigning this particular, basically requesting the other person to join your workspace. Okay, so this is how you can do your role management part. Then if you want to add any kind of tag, you can add your tags, right? So it will help basically in the searching part. Then you can diagnose and solve the problems. So here, if your data factory will have any kind of issues, any kind of error, so you will be able to see all those basically issues and problems right here. You can also check the health of your data factory right here. Currently we will not be having any kind of activity issues, right? You can see Here in the map also, right, you will be able to see the healthy locations. So these are the locations where you can see Azure is having their data centers. So all the data centers and locations are currently active. If anyone will not be active or affected, so you will be able to see this affected location. Then resource visualizer. Okay, so currently we are only having this particular resource, so we can only visualize this resource as single one. If it would had been connected with some other resource, which moving forward we will do, in that case it will be a kind of uh, DAG thing that you will be able to see. So this data factory, it may be connected to some kind of synapse, right, and maybe some kind of blob and like that. Then if you go to settings, so we can change the networking part. We can manage the identities, the properties, logs, and all those things. If you want to get to the documentation, you can go on to this getting started part. Talking about the monitoring, so you can set alerts, some kind of alerts if you want to, right? You can create your alert rule and then you can set alerts. If you want to see the matrices of your data factory, you can just select here, like airflow integration and all these things you can uh, attach to it, and you can create your own dashboard if required. Then the diagnostic settings, if you want to manage all these things, you can do it. If you want to see the logs, you can see the logs of it. Okay, fail to data of the schema, please refresh the page. Okay, okay, so currently because you have not run anything, so you won't be able to see any kind of query history or any kind of logs. Then if you want to select do any kind of automation, CLI or PowerShell, or if you want to add any tasks, you can do it. Resource health, or if you want to get your support, so you can come here and get your support. Cool. So this is basically all about the launching pad, I would the launching page of Azure Data Factory. And now if you want to launch your Data Factory Studio, so instance has already been launched. But if I now want to interact with my Data Factory instance, so I will have to launch a Data Factory Studio. So this is how your Data Factory Studios uh, landing page will look like. If you want to set up again, if you want to set up your version control or your Git and tracking and all those stuffs, so you can set up a Git repository here, right? Here you can see your data factory. If you have multiple data factories, so we will be able to see a drop down of all those data factories here. So this is my home page, right? If I want to ingest my data, so I can just click on this ingest. I can use a built-in copy task, right? Or I can use a metadata driven copy task, right? Here you can see if I want to create some kind of scheduling, so I can run once now. I can create a schedule. I can also create a tumbling window. So what is this schedule and tumbling window? All these stuffs we will be for sure discussing later on. If I want to orchestrate, so currently we don't have any pipelines. So obviously we will not be able to orchestrate anything, right? But if we want to, so we can do that thing also. If we want to do the transform of the data using data flows, we can do it. If I want to configure my SSIS, right? Basically, a kind of maybe a hybrid cloud support or a private cloud support, I can do ingest my data from that particular thing also. Okay, so here you will be able to see all those things. Cool. Here this section will now, if you will go on to the author part, so this will be the section where we will be dealing with, or we will be creating basically our pipelines. Okay, so here we can create the data sets, we can create pipelines, right? We can create data flows, we can do the query power query part. Here you will be able to monitor your pipelines, you will be able to trigger your runs, you can see your change data capture, then integration runtime and data flow debugging. Also you can set your alerts and see your matrices. If you want to manage the things and manage your whole infrastructure of this instance of the data factory, you can do it from this manage tab. And here, if you want to do the learning and all, so you can for sure go ahead with this tab. Cool. So here also on the top of it, you will be able to see the updates. If you want to switch to other data factory, you can see your notifications and you can get your settings and all those stuffs done right here. Cool. So this is basically how you can launch your Databricks Azure Data Factory instance from very scratch without using any kind of predefined template. Cool. So I hope you learned something new from this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course, and in this particular video we are going to see, using the copy data activity, how we can copy the data from one Azure blob to the other Azure blob. So in this particular course we have already talked about multiple things, right, related to Azure and related to cloud. We have talked about what exactly cloud is, how many different kinds of clouds are there, what is Azure, what are the different services in Azure related to the data engineering domain. Then we talked about the most used service in Azure with respect to the data engineering domain, that is Azure Data Factory. And in the previous video itself, we launched a data factory instance from the scratch. And in this particular video, we are going to see how we can do the copy data event. So with that said, let's get started with this particular video and let's get straight into the system. So as in the previous video, we have already created a Azure Data Factory instance. Right now, what we will be doing is that we will be uploading, or we will be basically transferring or copying the data from one of the Azure blob to the other Azure blob. Okay. So the very first thing, or the very first option that I will be doing is to select this ingest. I will click on this ingest, right? And then I will click on this type, that is built-in copy task. So here you will be able to get single pipeline which is capable of smoothly copying data from over 100 of different sources. Okay. Here also, if you want to read about what exactly this tool is, so use copy data tool to perform one-time or scheduled data load from over 100 data sources. Follow the wizard experience to specify data loading settings, or let copy data tool generate artifact for you, including pipeline, data sets and link services. Okay. So I will click on this. Run once and I will click on next. Okay. Then I will have to select a source type. So here you can see there is all, and these are the sources using which I can connect to. So for Azure, I will be able to select Azure Blob storage, which I will be connecting to. Then Cosmos DB, Data Explorer, Data Lake, right? MySQL, Postgres, Delta Lake, data files. Then talking about the different databases, so Amazon RDS for SQL Server, Redshift. I can click select to Impala, DB2, even Google Ads, Google BigQuery, Hive, MariaDB, MySQL, Postgres, Oracle, right? SAP, HANA, Teradata. Then talking about the file system, so I can connect to S3, FTP file systems, Google Cloud Storage, HDF, SFTP, right? Then we can also connect to protocol, HTTP, ODBC, right? REST APIs and all those stuffs. Talking about no SQL databases, so I can connect to Cassandra, MongoDB and MongoDB Atlas. These are the services, or you can say basically the apps which I can connect to. So I can connect to Dataverse, Dynamics, Hotspot, Jira, right? QuickBook, SAP, Shopify, and all these services. So you can see there are a lot of services. Here we will be utilizing our Azure Blob storage. Okay. So if I have already some predefined connection, I can use it. If not, I will click on this new connection, right? In this new connection, I will be, first of all, I will have to put my name. So the name of the storage account is, let's suppose, Azure Blob Storage 1, right? And all these things are currently fine, right? Here, if I want to give this any kind of description, I can give the description. Here you can keep the default runtime. The account key will be same. You can see all the subscriptions. So here I will have to select the subscription. And currently, because I have not created any kind of storage account, right? So I will first of all have to go back here, right? And I will go to my home and I will search here for blob. Okay. I will go to my storage account and here I will have to create my storage account. So you can see here subscription is there. Then I will be selecting my resource group, that is VS17. So here I can say as, let's suppose, Azure Data Engineering, okay, ADE hyphen copy data demo. Can only contain lower letters and numbers. Okay, fine. I cannot use hyphen. So I'm using this only. Okay, so it is available. No worries. And then what we can do is I can select my default zone as Central India. Preference storage type. So I can go with, let's suppose, blob storage. I can go ahead with the standard itself. Redundancy, make read access available to the event zone of the regional availability. Okay, fine. Then I will click on next, right? Here talking about the advanced parts of it. So talking about security. So we can configure security settings that impact the storage account. Okay. So here you can see if a secure transfer of REST API operation is required, I can click on this. Allow enabling anonymous access on the individual container. So for sure I will not be allowing any kind of anonymous access to the containers. So I haven't checked it. Then enabling enable storage key access. So I have enabled it default and all those things. Like I have not enabled it. It is by default. So I will keep it by default. Minimum time TLS version. So version 1.2 and all these things, right? So hierarchical namespace if you want to add, so you can add it, right? So these are the access tiers. Okay, this is exactly what I wanted to show you, the access tier part. So here if you feel like, and here it's also written very clearly that if you want to keep your data in the hot access tier, so optimized for frequently accessed data and everyday user scenarios. Okay. Then there is something called as cool tier. So it is optimized for infrequent accessed data and backup scenarios. And there is cold tier that is optimized for rarely accessed data and backup scenarios. So in hot tier, we will be keeping that particular data that we need to interact with on a daily basis. Okay. Then there is something called as cool tier. So let's suppose we are having a data that we only require once a month. Okay, on a monthly basis or maybe on a quarterly basis. So we can use that particular data, or we can store that data in the cool tier, basically, not in the cold, in the cool tier. So what is the difference between these tiers is, so if I'm going ahead with the cool tier, so I will be charged a little less as compared to the hot tier. Okay. And then there is something called as cold tier. So let's say if I'm having a data for last 20 years, right? So maybe, and I only require the data for, on a frequent basis, I only require the data for my last 5 years, right? So the other 15 years of the data, or the previous 15 years of the data, I will be storing in the cold tier, so that if I require it, maybe anytime, in any point of time, I will be able to access it, else it will be kept as a archive in my storage account. Okay. So here, because I have to frequently access it, I will go ahead with the hot tier. And it's not that if you are if we go ahead with the cold tier, right, and if you want to access it, you will not be access it on a daily basis. You will be able to access your data on a daily basis also, but Azure will automatically transfer that particular data from cold tier to the hot tier. Okay. Then if you want to enable the large data shares and all those things, you can do it. If you want to enable SFTP, you can enable your SFTP from here, right? If you want to enable your network file system, you can sorry, right? If you want to enable you all these things, so you can enable it right here. Okay, so I will keep it default only. I'm just letting you know the options. Then talking about the networking part. So public access, access your resource from anywhere through public network. So we can allow or disallow. Sorry. Okay. So I can allow or even I can disable from public network. So let's suppose I am working in an organization, right? So an organization will not want that anyone can access their data from anyone, right? From anywhere basically. They may restrict some kind of, let's say, inbound or outbound access. Okay, so here you can see if public access is enabled, so allow inbound and outbound access with the option of restrict to select inbound access using resource access configurations of this resource. If I disable it, so it will restrict basically the inbound while allowing the outbound access. And if I restrict by parameter, okay, so this is the mostly restricted. So restrict inbound and outbound using a network security parameter. Secure by parameter offers the greatest level of inbound and outbound restriction to secure your resource. Okay. So here there is no kind of very sensitive data that we are going ahead with. So we will go ahead with the allow public access as enabled. Then talking about the data protection part, right? So you can select all these things. So if I want to enable the soft delete, so I can enable soft delete and it will retain the data, the deleted data basically for 7 days, right? For soft delete for containers, it will again keep it for 7 days. For file shares, it will also keep it for 7 days. If we want to enable the versioning of blobs and change, basically if we want to capture the CDC, we can enable these things also. Okay, but currently I will be not enabling it. I am keeping it by default. If you want to do any kind of encryption, you guys can do the encryption part. If you want to add your tags, you can do it. And then you can click on your review and create button. So these are the things you can review it. If you want to change it, you can change it. Else you can click on create. Okay, so my storage account deployment is now done. And now I can click on to go resource. Right. So here you will be able to see everything, right? If you want to click on the containers, so you can see your containers are here. Again, if I talk about the overview, right? So here, if you want to upload any data, you can do it. If you want to open it in Explorer, you can do it. Delete, move to some other subscription, you can do it, right? And all these things, you have all the essential information about your container right now. Okay, so this is your container that is right now running. I guess you guys are aware about it. You can see, right, your storage account or maybe your container, whatever you want to say. So your resource group, your location, right, your primary access location, subscription ID, disk state, you can also see that is available, right? Performance, replication, account kind, provision state, and created. Then the properties you can see, right? The hierarchical name of the blob service is basically disabled, right? what is the access tier, blob anonymous access, soft delete, container soft delete, versioning, change feeds, right? And NFS version 3 is disabled, and all these details basically you will be able to see right here. If you want to do your monitoring part, so you can see your monitoring, the total ingress, basically the inbound traffic, sorry, outbound traffic, total ingress, right, inbound traffic, and all those things, average latency breakdown, and you can see all these things here. Then you can see your capabilities. You can host your static website if you want to, data protection, right, life cycle management, front door using CDN, custom domain security, and all those things you can done here. Recommendation and tutorials and tools and SDK are available right here. Then the same thing, if you want to see the activity log, you can see those logs here. If you want to add any kind of tag, you can add your tags, diagnosis, or solve any problem. If any kind of issue arises, you will be able to see all those things. Access controls, we have already talked about it in the previous video. If you want to do the data migration part, okay, if you want to maybe ingest your data from some other data source, you can do those things also, right? Let's suppose from other file, or maybe ADLS Gen 2 I want to store my data from, I can do those things also. I can define the events, and based on the events I can do whatever I want to. Then storage browser, right? I will have different kind of storages available in my storage account. So I have my blob container, I have file shares, tables, and queues. So for different use cases, I can use any of the storage account I want to. Then storage mover. Let's suppose I want to move the data from uh, maybe my current account to AWS or something. I can do that also. Partner solutions, right? Resource visualizer, and all these things are very similar to the ADF only. You can go and check here, right? Now what I will do, I will click on my blob services, okay, and then I will add a container here. So let's suppose I'm adding the container name as input, and I will click on create, and inside this input, okay, not input, so let me change this container name to, I can maybe delete this container, and I can add as, let's suppose, ADF container. Okay, ADF is fine. I can click on this, and inside this container I will be creating a directory as, let's suppose, input. Okay, that's it. And now I will come back here, and if I refresh it, so most probably I will be able to see my storage account name, and then I can click on this create, or first of all I can click on this test connection. So test connection is successful. Now I can click on the create. Okay, now what I can do is, from the source type is my blob storage, connection name is this, right? Now I have to get my data set. Okay, so what I will do, I will come back in this input, and I will upload some data. Okay, so I will click on this file, and let's suppose I want to upload uh, life expectancy data. Okay, and then I will click on this upload. Then, okay, so this is not the data I want to upload. This is my IPYNB file. right? So this is the data that I want to upload. Now let's suppose if this data already exists or file already exists, I can also click on this overwrite if file exists, right? If I want to do any kind of other updates, I can do it also, right? And then I can click on this upload part. So now the data has been uploaded. Now I will go back to my data factory. I can now click on this browse. I will go to ADF, then input, and this is the file name that I want. So I will click on this, okay. And then I will select this binary copy option. Okay, so compression, if I want to compress the data, I can click on that compression type. Maybe if I want to compress to ZZ, maybe zip, maybe tar or something like that. But I will not be doing the compression part here. So I will keep as compression. So here why I am doing the binary data like binary copy is, so here the files will be treated as binaries. Schema uh, schema definition will not be enforced. Okay, destination cannot be relational database. Okay, so I will click on this next. Now we will have to select the destination type. So I will again go to my Azure blob. I will select the destination as this. Okay, and now I will go back here, and inside ADF I will create a folder, or maybe let's not create a folder. Okay, uh, I will do what? I will select a path as ADF, and if I click as OK, and here I just insert something as output. Okay, and let's say here I'm giving the file name as I'm keeping my file name as none. Okay, let's see what happens. Okay, it will what it will do. Let me tell you. It will just give the default name of this file. If I'm keeping any file name, specific file name, let's suppose output.csv. So it will overwrite this file name to output.csv. Okay. And here, if you will look closely, so in my ADF, currently I'm only having my input directory. I am not having my output directory, but I have manually inputted it, right? So what it will do is it will basically create this particular directory by its own. Then compression type, I don't want any kind of compression. Copy behavior, I can keep as, let's say, default only. Maximum concurrent occurrences, block size, and all these things, I can just click on next. Okay, pipeline name, let's say copy pipeline. Okay, data consistency validation is required, no need. Enable logging, let's enable logging. Okay, so storage connection name, blob1, warning only, and all those things. Okay, let's disable it. We will use it this later on. Okay, and then degree of parallelism, maybe auto, preserve, attributes. Okay, then I will click on next, right? And this is the summary basically of my whole copy data tool. Okay, so I have to copy my data from Azure blob to Azure blob, right? Name is this, and all these things are fine. Okay, and then I will click on next. So now you will be able to see it is now validating. So it's basically validating all the permissions, right? If we have selected all the required outputs or given all the required parameters or not, and all these things, it is validating. So just like we compile our code, right? So it's you can correlate with the compilation of the code. So you can see uh, creating data set succeeded, creating pipeline succeeded, and running the pipeline has also been succeeded. Okay, I can click on finish. Okay, and now if I will go to this monitor part and pipeline runs, so I can see my copy data, copy pipeline done here, right? And if I come back here and if I refresh this, So you will be able to see a output directory has been created, right? So this directory was earlier not existing, but because my pipeline ran successfully and I had given the destination folder as adf slash output, right? So it has been created, and now if I go back into go into this directory, you will be able to see the default file name here, right? Last modified at this, access tier, blob type, size, and all those things are available right here. Now if I want to preview this data, I can just click on this, right? And no, not in snapshots, I can okay, earlier we had the option to preview the data here itself. If I copy the URL, okay, I can download and preview. Obviously, that's not an issue. Here I can also change the tier, right? If I want to now go keep it to archive or maybe cold, I can do it also, right? Uh, Talking about versions, snapshot, edit. Okay, in edit, we were able to see it right here, right? And if I click on preview, right? So now you can see the data. So you will have to go into edit. Earlier, if I remember it correctly, it was available in the overview tab itself, but right now it has been changed to this edit tab. And now you can see the data that is ingested in the blob using the copy data activity. And this data is exactly similar to the data that we are having in our input folder, right? If you will click on this preview, so you can see both of the data are similar. Cool. And now if I want to go back here, right, and if I want to know more about my pipeline, so I can get all the information related to my pipeline, right? Again, all the things which we had done, right? So okay, here pipeline runs, right? Update pipeline, right? And now if I want to update anything, let's suppose I want to change my source, right? So I can change the source, I can change my destination data set, and like that. Okay, sync here I can change, right? Copy data behavior, if I want to change, I want to change all those things, right? Whatever things we had done uh, earlier, right? We can also modify this particular activity again if I want to. If I want to add something more to this activity, I can click on this, and let's suppose if I want to add some kind of currently what can I add? Okay, maybe a Python job. Okay, but currently we are not having any kind of Azure notebook created, right? So no worries, in the upcoming videos for sure I am going to show you guys how we can create an like a multi-activity pipeline. Okay, so I hope, and all the details is also available here, right? Even in the pipelines you can see your pipeline, right? The data sets are here. There is a destination data set, right? That is this one. Okay, this is our destination data set, and this is the source, sorry, this input one is the source data set, and this output one is the destination data sets. So currently we have not created any data flows and all those things, so it's not visible for now. Cool. So from here also, if okay, not this one. Okay, so from here also, if we want, we can trigger our pipeline, right? We can debug it, we can validate, right? We can add trigger, And if I want to run it again, so I can just click on this and I will click on OK. So again, my pipeline will run from directly uh, from the canvas itself. Okay, so it is right now in running phase. So I can also come on to my pipeline or the monitor tab, right? And you can see it is right now in progress. And if I refresh it, so the status has been succeeded. And now you can see both of the pipeline runs detail right here. Again, nothing will change here because we are overwriting basically the data in this case. Okay, so you will be able to see the very same data here. Cool. So I hope now with this particular video, you guys have understood how you can also create a blob storage, right? How you can connect your blob to your ADF canvas, and how using the copy data activity, you can copy your data from one blob storage to the other blob storage. Cool. So I hope you learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course, and in this particular video we are going to see how we can connect to ADF using multiple sources. Means we have a ton of options using which we can connect to our ADF. UI which we have done till now is one of the options, right, using which we can interact and we can connect to our Azure Data Factory. If you will come here and you will look at the documentations, you will see we have a bulk of options using which we can connect with our ADF, right? So if I talk about this particular course, so what we will be doing is that we will be focusing on the data engineering related services in Azure cloud. So we have already talked about in this particular course that what is exactly a cloud is, how many different types of cloud are there, what is Azure, how you can create your free Azure account, as well as we have also learned about the basics and I would say the introduction of Azure Data Factory. So with that said, let's get started with this particular video and let's get straight into the system. So as I have already told you that there are multiple other ways apart from the UI that we have already seen to connect to our Azure Data Factory. So the very first way is the Azure CLI, second is the ARM, third is Azure PowerShell. Then we can also use .NET, Python, REST API and Bicep to connect to our Azure Data Factory. Okay, so one by one we will quickly look at that how we can do all these things. Mostly in this course what we will be doing is that we will be connecting with our ADF using the UI only, right? But we should also be aware about the different other choices that are available for to us to connect to Data Factory. Okay, so that this quick start describes how to use Azure CLI to create a data factory. The pipeline you create in this data factory copies data from one folder to another folder in the Azure Blob storage. For information on how to transform data using Azure Data Factory, we can see on this particular link. Okay, so for introduction to Azure Data Factory service, we can go here. If you don't have a Azure subscription, we can create our account here before we begin. So prerequisite is that use Azure Bash environment in Azure Cloud Shell. For more information, we can go on to this link. So I will just click on this Launch Cloud PowerShell. Okay. So it's connecting to a terminal. Okay, so we are now connected to a PowerShell. So if we want to use, so type AZ to use Azure CLI and help to learn about this. Okay, so if I come here and I type as AZ, okay, and I can click enter. Okay. Something happen or what? Spring Blue Reconnector. Okay, confirm. Me just relaunch it again. Okay, and here if you will see, so you can prefer to run CLI reference commands locally also. We can install Azure CLI if you are running on Windows or Mac, considering the running CLI in Docker container. Okay, for more information you can visit on this link. Then if you are using a local installation, sign in with Azure CLI by using the uh, AZ login command. To finish authentication process, follow the steps displayed on the terminal. For other sign-in process, you can see on this particular thing. When you are prompted, install the CLI extension for the first use. For more information, you can see this. Then run Azure version uh, to find the version and the dependent libraries that are installed. To upgrade, you can run this particular command. So this is if we are going ahead with the local version. Okay, so let's see if this doesn't work. We will try to go ahead with local version. So currently we are connected, right? Now let's come here and prepare the container and test file. So what we will do, this quick start uses Azure storage account, which includes a container with a file. So to create a resource group named ADF quick start resource group, use the AZ resource group create command. Okay, so we will do what, AZ group create hyphen hyphen name, this is the name, right, and location will be US East US. Okay, so let's go ahead with the default commands itself. So I will copy it and I will paste the command here. Okay, if I want to change the resource group, I can also add my resource group here also. Okay, but let's go ahead with the default one itself, because then I will have to change it multiple times. Okay, so now you can see that in subscription this resource group quick start RG has been created, location is this, managed by is null, and it has been succeeded. Now create a storage account by using this particular command, that is az storage create, sorry, storage account create. Resource group will be this resource group that we have already created. Name of the storage account will be ADF quick storage, and location will be US East. So just copy it and let me paste it here. So a storage account with the provided name is already found. Will continue to update the existing account. Okay. So what I can do is I can just update this name. Let's suppose something like this, random numbers, and I will press enter. And I believe this will create now. Okay, is not a valid storage name. Storage name can be between 3 and 24 characters in length. Use number and lowercase only. So I have only used number and lowercase. So I guess the length is long. Let's say 14 itself. Okay. So now you can see that the storage account is getting created. Then we will create a container named this ADF tutorial by using this particular command, that is az storage container create. Right, we will add the resource group, the name, then the account name, and then uh, auth mode key will be key. So I will copy it, I will come back to the terminal, and I will paste it here. And here we have our account name currently as ADF 14, right? Azure Quick Start Storage 14, right? And then I will press enter. So now created has been true. It means it has been getting created. And now if I come back here, right? If I come here and if I show you guys also, okay? If I go to home, if I go to my storage accounts, so you will be able to see, right? This Azure Quick Start Storage 14 account has been created, right? And if I go inside this particular account, right? And if I go to, what did I just create? Okay, currently just the account has been created, right? So account has been created, and if I close this, now let's move forward with the documentation. So create a container has been created. Now in the local directory, create a file named this emp.txt to upload. If you are working on Cloud Shell, you can find the current working directory as this, and you can use the standard bash command like ca2 to create a file. Okay, so I can use this command, that is present working directory. So obviously this home/vishal is my current working directory, right? If I do ls, so I am having a directory named as Microsoft. So what I can do, I can just copy this and I can paste it here. Okay, we press Control C. Let me do ls. So the file has been created. So let's suppose if I do vim employee.txt, so you can see that this is text file is present here, right? And now I have to press colon wq, and if I press enter, so I will be out of my vim. Okay, and now use control D to save the file. Okay, fine. I just pressed enter. I will have to press control D. For that reason, it has put those spaces and all, but let it be, no worries. Now upload the new file to your Azure container using this command. So Azure blob upload, account name is this, name of the file will be input. It will create a folder as input, and employee.txt, container name will be this, file name will be this, and auth mode will be this. So let me come here. Let me paste here, and the account name will be Azure Quick Start Storage 14. So you need to keep this in mind. So client request is done. If I come here and if I go to the blob service, so you can see Azure factory tutorial, and here you can see this input folder, and inside this input folder you will be able to see your employee.txt, right? Here in edit you can also see this is text file. Okay, and let's go back to the documentation. Now we will be creating a data factory. Okay, we will create a data factory. We will create a linked service. Okay, create and run the pipeline, and then clean up the resources. Okay, cool. So I will copy it again and I will come back here. I will paste the code. So AZ data factory hyphen create resource group is this and data factory name is Azure tutorial factory. I hope again this will give me an error. This is a very generic name. Yes. Okay, so we got the expected error. So again, let's suppose I am giving the name as 14. I hope this time it works. Okay, so now we have created the data factory successfully. And now I will come back here. So replace data factory with globally unique data factory name, for example, something like this, some random name. Okay, you can see the data factory that you created using Azure data factory dot show command. Okay, so if Azure we use az data factory show and we will give the resource name and the factory name, so we will be able to see our data factory. So here if I come and I have to give the data factory name as tutorial 14. So you can see all the details about the data factory. That encryption is currently null, key name is null, key version is null, right? Base URL is null, ID is this, principal ID is this, tenant ID is this, location you can see, name you can see, provisioning has been succeeded, right? And the same thing you can also verify if we come here and if I go to my data factory. So let me go to home and let me go to let me search here for data factory. Data factories, right? So you can see ADF tutorial data factory 14 has been created, right? And you can also see that the resource group is this. The earlier resource group was VS17, right? Now we have to create a linked service and data sets. The very same thing that we did in the previous video using the UI. Now we will be doing the same thing using the CLI or the uh, what we call this Azure PowerShell. Okay, so here we will do Azure storage account show connection string. Resource group is quick start RG, right? Name is this is I will have to change to 14 and key is primary. Okay, I will come back here. I will paste it and the name is storage 14. So this is the connection string that we have got, right? And then in your working directory, create a JSON file with this content, which includes your own connection string from the previous step. Name the file as this file. Okay. So, okay, I will have to do what in this particular case then? That I will have to come back here, right? Will have to do cat. I will have to copy this, paste it here. And if I do ls, so you can see that the JSON file has been created, right? And now I will have to do what? I will have to add this JSON and here I will have to put my details that I have got here, right? So I will do dot, let me open an online notepad. Okay. And First of all, let me copy this, paste it here, and then I will come back here. I'll copy this and I will paste it here. Okay, and then I will do here, I will do what? Vim Azure storage dot JSON, and here I will just control X and I will paste it here, and then I will do what? WQ, right? So now my JSON file has been created. Okay, and then I will create the link service named this by using the Azure Data Factory create command. So I will copy it, I will come back to the terminal and I will paste the code, and let me run this code. Quick start. RG, it's resource group is fine, right? I did not change the name of resource group. Resource group is fine. Data factory and the resource web is not found. Okay, quite interesting. Data factory resource group is ADF quick start RG, and here if I talk about, so ADF quick start RG. I guess, okay, let me do one thing. JSON validator. If I paste it here and if I validate my JSON, so okay, we have got an issue with the JSON. Okay, not this. This is not my JSON. This one I have to validate. Validate JSON. Okay, my JSON is correct in this case. Under the resource group RG was not found. If I do vim this, type is blob, account name is this, account key is this, blob endpoint is this. Okay, fine. This looks cool. So I can do colon WQ to enter my, sorry, to exit my Vim. Link service dot create resource group. Did I change the resource group name anywhere? So create resource group ADF quick start RG. Fine. So resource group was same all the time. Then why it's saying that the resource group was okay, fine. My bad. I have to change the data factory name, right? It's saying that data factory name is not found. Obviously, why? Because we are having the data factory name as ADF tutorial 14. Okay. So now you can see that we have successfully created this linked service now. Okay. Now what we will be doing is in your working directory, create a JSON file with this content, that is input data.json. Again, I will have to come here. I will have to do cat and come here, copy this, come here, paste, Control D, right? If I do ls, so I can file my JSON file. I will do now what? Not cat, vim input data.json. right? I will come back here and I will copy it. I will paste it here and then I will do colon WQ. Okay, done. Now create a input data set with name this. So I will again copy this, come here, paste, and I will have to change my data factory name, ADF tutorial factory 14. Rest of the things are fine, I guess. So again, the input data set has been created. Now I will have to create this output .json. So I will come back here. I will do as output dataset dot JSON, not Vim. First of all, I will have to cat output data dot JSON and control D ls. We have got output data dot JSON. Then I can do Vim output data dot JSON and I will copy it, come back here, paste it, colon WQ, enter, done. Okay. Now create the output thing, come back here, copy it, paste it here. Now I will change the data factory name. Now the output set has been also created. Now I will create the pipeline. Okay. So this will be my pipeline name or basically the JSON file name. So I can do again cat and paste it here, enter, sorry, control D. Then I can do Vim ADF, enter, come here and add this JSON file, right? So it will add my pipeline name. You can see the properties and you will see the activities, right? So the activity name is copy from blob to blob. The type of activity is copy, right? You can see the policies that are attached here, right? All the types. Sync is nothing but our binary sync, right? Reference name you can see here, right? Input will be my input data set that I already created here, right? And the output will be this output data set that I had created, right? So using this JSON file, my data factory will basically do all those things in a kind of automated way, you can say. WQ, done. And now I will come back here. Now create a pipeline named this particular thing using this code. So I will now create a pipeline, come back here, paste it here, and I will press enter. Okay, fine. I will have to change my data factory name. So data factory name is 14. And now you can see the pipeline has been successfully created. Now we need to run the pipeline. So I will copy it. I will paste it here and create resource group is fine. Name of the pipeline is fine. Data factory name is 14. Okay. So now you can see a run ID. And now if I come back here and if I go to this data factory, launch the studio, okay, I should have done it earlier only. And if I come to my monitor part, so you can see that this ADF V2 quick start pipeline was successfully done. The total duration it took was 22 seconds. And simultaneously, if I come back here in my storage accounts, okay, and if I go to my quick start storage, and if I go to my containers, ADF tutorial. So here you will be able to see the very same thing that we did. Now the employee.txt file is also present in our output.json output folder, right? From input folder, it got copied to the output folder. Okay. And now run the pipeline. Now we can also verify, right, using this particular command. So here, if we come back to our terminal, you will see the run ID is this, right? So we will have to replace the run ID here. So I can copy the command, paste it here, and instead of this run ID, I will paste my this run ID. So copy and paste it here, and if I press enter, data factory name I will have to change. So you can see all the information, exactly the same information that we are getting here in the UI, right? The same information you will get on the terminal also, that it was successfully ran, right? Ran ended at this much, started at this time, status was succeeded, right? And all those things, duration in milliseconds, right? So basically, if you will look here, so we are aware about that it took 22 seconds, right? And if we convert this 21,507 milliseconds, so it is nothing but 21.5 seconds. That is near about 22 seconds, right? Rounding it off to 22 seconds. So what all information we are getting on our UI, the very same information we are also getting on the terminal itself. Okay. And now what we will do is we will create our, we will delete the resources. Very, very important thing if you are in the learning phase, right? So az group dot delete, and I will click on yes, and I will be deleting all the resources that are present in that resource group. It's taking some time because it has to basically shut down all the resources that are shut down, as well as delete the resources that are associated with the resource group. Right, so now it has been deleted. Okay, so if I come back here to my home, if I will go to my resource groups, so you can see we don't have any of the resource group available. If I come back here also, right, I guess data factory will not be deleted. I will have to manually delete these data factory. So data factory dot 14, right, this is the data factory that we created using the UI. So if I will have to go to my home, data factories, right, so even here you can see that the data factory has been deleted. I guess this is due to the soft delete that it has done. Or if I may, yeah, now you can see that the data factory was not found. It may have been deleted by subscription and all those things, right? So we can just close this, right? We can also close the JSON validator. So now even the resource cleanup has been done, right? Now we can stay confident that okay, we will not be charged for any of the services that we have used in this particular demo. Cool. So I hope you guys have understood, and in this particular video we did the very same activity, right, that we did in the last video using the UI, In this particular case, we have used the Azure CLI to do the very same copy data activity, right? Way is different, interaction is different, right? There we are using the UI, here it is terminal. Again, like if we have to create a very complex pipeline, so here creating that particular JSON file will be a bit difficult, right? If we have to manage the access, right, we have to do some kind of let's suppose we have to put some kind of if else condition, we have to attach that particular thing to some other service, right? Basically multiple activities are connected together in a large pipeline. In that case, we can do, I am not saying that we can't do any complexity of like any high complexity pipeline. We can do the very same thing using the CLI also, but again it will become more difficult to manage those things. Okay, that's what I am saying. So that's pretty much it for this particular video. I hope you have learned something new in this one. I will see you in the next video. Till then, keep learning and keep growing. Bye bye. Hey guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course. And in this particular video, we are going to see how using different ways we can programmatically create the Azure Data Factory. So in the previous video, we have already seen how we can create an Azure Data Factory and do the copy data activity using the Azure CLI. In this video, we will be moving forward with other options that we have to connect and to interact with the Azure Data Factory in a programmatic way. So with that said, let's get started with this video and let's get straight into the system. So as I have already told you that in the previous video, we used Azure CLI to connect to our Azure Data Factory. Then we using JSON files, we created our data sets, we created our uh, what we call this Azure blob, right? And then we moved the data from one location in the Azure blob to the other location. We basically did a copy data activity, which we have already also did using the UI. So we have already covered how we can do the copy data activity using UI, which moving forward we will be using the most. We will not be using this programmatic way to interact with the Databricks. Mostly we will be using the UI itself. And the second way that we have done is using the Azure CLI, where we don't have any kind of UI to interact with the Databricks. We just have a terminal, and using that terminal we were able to create and we were able to interact, and even after doing the job we were able to delete our resources just using the CLI commands, right? Now let's move forward and let's understand how we can create an Azure Data Factory using the ARM template. Okay, so this quick start describes how to use an Azure Resource Manager template ARM to create Azure Data Factory. The pipeline you create in this data factory copies data from one folder to another in the Azure blob. For tutorial on how to transform data using Azure Data Factory, we can go on to this link. And this copy data activity also we have we have done multiple times, so we already know aware about that what kind of activity it will be. So an Azure Resource Manager template is a JavaScript object notation, that is a JSON file that defines the infrastructure and the configuration of the project, right? So we will be having a JSON file where we will be defining the infrastructure, means what all tools we will be using, what will be their configurations, right? And all those details will be in a JSON files. The template uses a declarative syntax that we have to declare everything, right? Means we have to step by step write each and everything, right? We just can't we just can't write any it in an anonymous way and it will work. You describe your intended deployment without writing the sequence of programming commands to create the deployment. Okay, so now like we will not do it in the same way, like just like we did line by line. So we can just see here how we can do it, right? So prerequisite will be an Azure subscription. So what we can do is we can create a file employee.txt, right? Save it in this particular folder, okay? And then we can, using this particular template, right, we can just create and do the copy data activity. Here you will be able to see you are having each and every detail that is required here, right? You have your data factory name, okay? You have your location, the storage account name, the blob container, any variables, resources, right? Each and every detail is written in a JSON kind of format. Then if you want to deploy the template, so you can click on this particular button, right? Select or enter the following values, okay? Unless it's specified, uses the default values to create the Azure Data Factory resources. So we have to describe these values, and then we have to review our deployed resource. Some data factory will be created. This storage account will be created, and you can select the storage account and go into containers. Then you can upload your file. Then you can come on to your Databricks, Data Factory Studio, and then you can click on the author tab, and then you can just trigger the pipeline. Then you can monitor the pipeline, and the pipeline will be succeeded, and your file from input directory will be from input directly it will be copied to the output directory, right? And that's it. And then you can clean the resources using these commands. Similarly, we can do the very same thing using Azure PowerShell also, right? So there you can see here, right? So this is the UI part, right? Creating the storage account. We can do it from the UI, and then using Azure PowerShell. First of all, we will launch the PowerShell. We will connect it to our Azure account. We will get the subscription. We will select the subscription using the subscription ID. Then using these variables and the values, we will be creating our resource group. Then we will resource group first of all. Then we will create a resource group and run the following command, right? New resource group name. Okay, fine, right? So we will be running this command after creating the resource group. Then we will create a data factory. So this is basically the variable created for the data factory. This is basically a variable resource group name, and this is the value that has been assigned to the resource group name. And with the same variable name, we have created a resource group here. Similarly, this is a variable with this particular data factory name, and using this variable, we have created the data factory in this particular command. Then we can create the linked service using the JSON files, right? Then we will create the data sets using the JSON files. Then we will also create a pipeline using a JSON files, and then we will create a pipeline run. So basically, using the run ID, we will be running our pipeline, and once the pipeline has started to run, we will be monitoring the pipeline. So such kind of detail will be provided in the terminal. Pipeline is running in status in progress. Once it is succeeded, it will be given as succeeded, and then we will be having our resource group name, data factory name, run ID, pipeline, right, last updated, and all these details we will be having in the terminal itself. We will not even have to go to the UI and all those things, right? And then we can run the following script to retrieve copy data run details. For example, the size of read and write and all these details, right? So if we want to know more about the details, just like we click on that view button, right, on the specs button. Not here. Right? Just like this particular button, the details that we get, the same details we will be getting here. Okay. and then we can deploy the resources, and then we can clean up our resources. Similarly, using .NET, okay, .NET now becomes a kind of programming language, right? So we will require some IDE to do those things. So we can do it using the Visual Code, right? So we have to create a project, right? And then we have to install the packages. Then using C# and all those things, we can do the very same things that we had done till now. Then using Python, right? Again, Python comes into the category of programming language. So if you are dealing with the programming language, we will have to use our IDE in this particular case, right? So again, we will have to install some kind of Python packages. So we will install Azure Management Resource, right? Then we will install Azure Management Data Factory, Azure install Azure Identity, right? And then we will be create a data factory, first of all, client. So we will do all the necessary imports. Okay, from identity we will import the client secret credential. Then azure.management.resource, we will be importing the resource management client. Then azure.management.data factory, we will be importing Azure Data Factory Management Client. Then Azure Management Client Factory.models, we will import everything. Then from datetime, we will import datetime and delta time, and then we will import our time. Then add the following functions to that print information. Okay, so here print items, so it will print the resource group name and the resource ID. Then properties, it's going to print as the properties.provisioning state, and print activity run details, it will be basically printing as the status, right? Outputs, data read, data written, copy duration, and any kind of message if there is any kind of error that we face. Then we have our main function. So here we will require our subscription ID, we will require our resource name, we will require our data factory name, and then using the client ID and the client secret key and the tenant ID, we will be able to authenticate into our into our account. Then we will be creating a data factory. So resource client dot resource groups create or update, we will be giving the resource group name and the resource group parameters, and then df underscore resource, we are creating factory. So using this factory instance and passing a location parameter, we will be creating an instance. Then adf.client factories.create or update, we will be giving the resource group name, the data factory name, and the data factory resource, and then we will print the items in the data factory. Then we will create the linked service. Then we will create our data sets, create the sync data set, and then we will create our pipeline, something like this. Okay, so we will give the activity name, blob source is this, blob sync is function of this. We must have already created the function, right? Blob where, okay, fine, it's not creating the function, it's just creating the instance of these functions. Okay, then dataset references, right? So this is the inbound dataset reference, and this is the outbound dataset reference. And then we have the instance of copy activity. So here it has given the activity name, inputs are this, outputs is this. Okay, source is blob source and sync is blob sync. And then we are giving the pipeline name as this, params of pipeline is currently empty, right? It has taken this 2 times. Note the parameters in the pipeline, add them to the JSON parameters shown below as parameter for each. Pass the parameters in the data flow to create. Okay, fine. Okay, and then we are creating our pipeline object. So pipeline resource activities, we are doing this copy data activity, and params, we will be passing the params for pipeline. And then adf.client pipeline.create or update, resource group name, data factory name, pipeline name, and pipeline objects. And then we will be creating the print item of pipeline. And now using this create run function, we will be basically running our pipeline, and then we can monitor our pipeline using this particular code, right? Once done, we will be starting the main method which we have created here, this one, okay, which is basically ultimately calling the functions and the resources which we have created till now. And then we will start the main method and we will run our whole program. So this whole program can be also written in one single file, something like this. Okay, so we can create one single file, we can copy this code, and then we can run this code just like we do. And in the console output, we will be getting the name of the data factory, ID, the location, tags, name of the storage link service, okay, name of data source input, data source output, name of the pipeline we will be getting, then pipeline run details, okay, time zone, activity details we will be getting, how much bytes got written, how many bytes got read, was the activity successful or not, and the copy duration, basically how many seconds did we did the pipeline ran. Then clean up the resources. So using this particular function that is delete, we will be able to delete our resources. So adf.client.factories.delete, we will give the resource name and the data factory name to get it cleared and get it deleted. Then using the REST API also, we can do the same thing, okay. So we will be connecting to our Azure account, we will get the subscription, we will select the subscription, then we will pass a few parameters, and then using the basically the body and the kind of JSON responses, or you can say JSON hits in this particular point of time, we will be able to create the copy data activity, something like this. So these will be the request basically that we will be throwing to the data factory. So here you can see, right, method is put, okay, again method will be put, okay, we will be getting a post method. So mostly we will be using a put or post method. Wherever if we want to insert something, we will go ahead with the put method, and then if we want to hit something, we want to get it run, there we will be using the post method, okay. And then using bicep also, we will be able to do the same thing, okay. Using bicep also we can do, and we can interact with our Azure data factory, or not only Azure data factory, I would say we can interact with almost all the services that are present on the Azure cloud. Again, I'm saying almost, it's not that we can interact with all the options available here, right, with all the services, but with Azure data factory, at least these are the options that are required to connect and to interact and to do any kind of stuff that we can do using UI is possible using a programmatic fashion, in a more automated fashion, using the different options that are provided here. We can do it using our Azure CLI, we can do it using Azure Resource Manager, Azure PowerShell. Then talking about the programming language, so we can use .NET and Python. What I feel like is Bicep is also a programming language, right? So Bicep is a domain specific language, okay. So we can also use Bicep to do, if I categorize it in the programming languages, and if we want to do using the APIs, so we have even the option of REST API calls if we want to interact with our Azure data factory. Cool. So if you ask about why this comes into picture, so first of all, it's more of a thing, right, that we have given a multiple option to interact with the platform. So how the user is convenient and maybe comfortable to use our platform, he can do it firstly. And the second thing is that providing these programmatic options to interact with the platform, we give more of a flexibility to the developers. Okay, so we need not interact using the UI. So any kind of manual intervention will not be required at a very high level. We will only have to interact at a very low level if we are creating these programmatic way of interaction. So most of the things, right, and at least whole of the pipeline we will be able to automate. Okay, we will be able to automate, and we will also be able to use the CI/CD facilities, which also we can use using the UI also, right? But that automation is up till a certain limit. If we are doing the stuffs using UI, if we are doing the UI, if we are doing the thing in the programmatic way, the automation is has more room and more option to be done. So that is the main reason that uh, we have an option to connect with the data factory in the programmatic fashion also. Cool. So I hope you guys learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course, and in this particular video we are going to understand about one of the components and the concepts of Azure Data Factory, that is pipelines and activities. So we are going to do this particular thing in the documentation way. We will be reading the documentation and then we will be following if we have to follow anything that we can do practically. Else we will be understanding each and everything from the developer's point of view. So with that said, let's get started with this video and let's get straight into the system. So today's topic is pipelines and activities in Azure Data Factory, and the same can also be followed in Azure Synapse Analytics, right? So the same thing and the same concept you can apply on both of the platforms, that is Data Factory and Synapse. So this article helps you to understand pipelines and activities in Azure Data Factory and Azure Data Analytics, Azure Synapse Analytics, and use them to construct end-to-end driven workflows for your data movement and data processing scenarios. Okay. So a data factory or Synapse workspace can have one or more pipelines, right? A pipeline is a logical grouping of activities that together perform a task, right? So a pipeline can be what? So right from let's suppose ingesting the data, okay, then doing some kind of maybe transformation activity, right, then storing it somewhere, okay, and then maybe doing some kind of analytics on that particular data. So this whole flow or this whole, so one piece of it can be an activity like extracting the data, transforming the data, storing the data, right, creating the analytics. These things are activities, and the group of activities, group of all these things put together in a certain flow, in a certain pattern, can be categorized or can be called as pipeline. Okay. For example, a pipeline could contain a set of activities that ingest and clean log data and then kick off a mapping data flow to analyze the log data. Okay. The pipeline allows you to manage the activities as a set instead of one individual. You deploy and schedule the pipeline instead of activities independently. Okay. So as I already told you that activity is one independent task. So we can also run and we can also execute one activity if required, like an activity independently. But mostly we don't run activities independently every time. So we will not be running our pipeline in such a way that first I ran the activity of ingesting the data, then I ran the activity of transforming the data, then maybe creating the analytics. We will connect it together, we will create a pipeline, and then using that, like using that pipeline, we will be running the group of activities together and we will perform a certain logical task. So the activities in a pipeline define actions to perform on your data. For example, you can use a copy data activity to copy data from SQL Server to an Azure Blob storage. So this is an activity. We have just copied the data from uh, SQL Server to Blob. So this is one activity that we have done. Then use a data flow activity or Databricks notebook activity to process and transform the data from the Blob storage to Azure Synapse Analytics pool, on top of which business intelligence reporting solutions are built. Okay. Then the other activity can be what? That using the data flow activity or using Databricks notebook, we will be able to transform or process the data that we have stored in the Azure Blob storage. And then on top of it, the other activity can be that we are connecting that particular notebook or the data source using to Azure Synapse Analytics pool, on which we will be creating our BI reports. Then Azure Data Factory and the Synapse Analytics have three grouping of activities. First group is data movement activities, second is data transformation activities, and the third one is control activities. An activity can take 0 or more input data sets to produce one or more output data sets. Okay. So the activity can take 0 or more input data sets. Okay. And the produce of it will be one or more output data sets. Okay. So just understand and keep in mind this particular thing. The following diagram shows the relationship between pipeline, activity, and data set. So data set is maybe an example. It can for example, it can be a table, it can be a file, it can be an object storage, right? It can be some kind of container or something, right, where we have stored the data. So this activity consumes the data. So activity can be what? Maybe a Hive query, maybe some stored procedure call, maybe some kind of copy activity, right? So so activities consumes the data and even produces the data, right? Maybe if some kind of Hive query you have run, so first of all, it will consume the data. If it will run the query on that particular data, and then it will produce the data. Okay. So activity does consumption and production of data both. Pipeline can be used for maybe scheduling, monitoring, and managing the group of activities. So is a logical group of what? Is a logical group of activities. Pipeline. Okay. So an input data set represents the input for an activity in the pipeline, and output data set represents the output of the activity. Data sets identify data within different data sources such as tables, files, folders, and documents. After you create a data set, you can use it with activities in a pipeline. For example, a data set can be input output data set of a copy data activity or an HD Insight Hive activity. For more information about dataset, you can visit to this particular article. Okay. So there is a default soft limit of maximum 120 activities per pipeline, which includes inner activities of containers. Okay. So this is basically a soft limit. Means you can say that Microsoft recommends us that we should not exceed this 120 activities per pipeline limit, and 120 activities is more than enough to create a very complex pipeline. Okay. So 120 activity is more than enough. But even if you want to create, or if your requirement is that you have to create more than 120 activities, so we can break that pipeline into multiple pipelines, right? And then we can create that whole pipeline. So let's suppose we are having a very complex pipeline, right? We are maybe ingesting the data from, let's suppose, hundreds of sources, right? Then we are dumping it somewhere. Then we are doing the transformation for one kind of I would say requirement, right? Then we are doing the second requirement. Then we are maybe training our machine learning model. We are creating our models, right? Then we are again having uh, some kind of requirement that we have to enhance our data, right? For creating those models, right? We have to train some kind of time series data and all those stuffs, right? So we have a very, very complex pipeline. In that case, what we can do for every single activity or for every single, I would say, use case, we can create a separate pipeline, right? If our pipeline is getting more and more complex, it means we are adding more and more, you can say, activities or more and more um, situations to it, right? Outcomes to it. So for every individual outcome, we can create an individual pipeline so that even the maintenance of that pipeline will be easy, right? And the complexity will also get reduced, right? So, and again, 120 activities is, I would say, more than enough. Then data movement activities. So copy activity in data factory copies the data from one source, one data source to the sync data source. Okay. Data factory supports data stores listed in the table in this particular section. Data from any source can be written to any sync. For more information, see this particular article. Select a data source to learn how to copy data from to and from that source. Okay. So supported as source, supported as sync. So here, if you will look closely, so the third party data, I won't say third party, I would say the external sources, right? Let's suppose Amazon RDS, right? Redshift, DB2, Google BigQuery. So we can for sure use these data sources as a source. Okay. We can ingest the data from these sources, but we can't write or we can't use it as a sync to these sources. Obviously, because none of the organization or none of the cloud provider will want, right, that you ingest the data from, let's suppose, Amazon Redshift, and then you do the transformation on my platform, and then you go and again dump your data on your Redshift, right? Why any of the organization would want that, right? So you can for sure, but you can for sure ingest the data. Okay, if you want to bring the data from Amazon platform to Azure platform, you are more than welcome, right? But you won't be able to write the data from back from like Azure to Amazon in this data movement activity, right? Let me make it very, very clear. In this data movement activity, you will not be able to do it. For sure, you can move your data from Azure to Amazon also, right? Just the way you are moving your data from Amazon to Azure. Okay. But for that, you will have to further create certain connectors, and then using those connectors, you can do that particular part if required. Okay. So these are the list of data sources from where you can ingest the data, and this column 2 gives us if that we can use that particular source as a sync or not. So note, if a connector is marked preview, you can try it and give us the feedback if you want to take a dependency on preview connectors in your solution. Okay. Then the data transformation activities. Azure Data Factory and Azure Synapse Analytics supports the following transformation activities that can be added either individually or chained with other activity. Okay. So we have a data flow activity. Here the compute environment will be Apache Spark clusters, which will be managed by Azure Data Factory. Then we have Azure Functions, where the compute environment will be functions. Then we have Hive, Pig, MapReduce, Hadoop streaming, and Spark streaming. So we can use HD Insight Hadoop for these activities. Then we have ML Studio activities. So we have to use Azure VM. For stored procedure activities, we can use Azure SQL, Synapse Analytics, SQL Server. If we want to go ahead with USQL, we will have to use Data Lake Analytics. If we want to do custom activity, we can use Azure Batch, Databricks Notebook, Azure Databricks, jar activity, Python activity, Databricks. We can use Azure Databricks for it. And Synapse Notebook activity, we can use Azure Synapse Analytics. Then control flow activities. So the following control flow activities are supported. So we can append variable activity. So it is nothing but add a value to the existing array of variable. Okay. Then execute pipeline. So execute pipeline activity allows a data factory or Synapse pipeline to invoke another pipeline. Okay. Then filter, apply a filter expression in an array, in an input array. Then for each activity defines a defines a repeating control flow in your pipeline. This activity is used to iterate over a collection and execute specified activities in a loop. The loop implementation of this activity is similar to the for each looping structure in the programming language. So just like we have the for loops, right, and the for each loop in the programming language, the same kind of activity and the same kind of you can say computation it will be doing in data factory also. Then we have a get metadata activity. So get metadata activity can be used to retrieve metadata from any data in the data factory or Synapse pipeline. Then if condition activity. So the if condition can be used to branch based on condition that evaluates to true or false. The if condition activity provides the same functionality that an if statement provides in programming language. It evaluates set of activities when the condition evaluates to true, or other set of activities when the condition evaluates to false. So just like we have an if else statement in the programming languages, right, that we check on a certain condition. So if that condition is true, so we will execute X state, and if the condition is false, we will execute, let's suppose, the Y state, right? So this is what we do in if else, and the same kind of if else activity is also possible in the data factory. Then lookup activity. The lookup activity can be used to read or look up a record, table name, value from any external source. This output can further be referenced by succeeding activities. Then set variable. To set the variable of an existing variable. Until activity implements do until loop. It is similar to do until looping structure in programming languages. It executes a set of activities in a loop until the condition associated with the activity evaluates to true. You can specify a timeout value for the until activity. So until activity can be you can say can be equivalent to the when clause, right? So let's suppose we are doing the when, right? So when, let's suppose if I is equals to 10, right, then you stop printing the let's suppose hello, right? Else you will, and if we are doing that, if we have written, okay, let me open my Epic Pen once. So if we are using the Python language, right? So let's suppose we are using when I is equals to 10. Okay, right? So it's not when it's while, sorry, it's my bad, right? So when we use the while condition, right? So while I is less than 10, okay, and we will define I is equals to, let's suppose, 1, okay, we can do what? Print, let's suppose, the value of I, okay, and if we don't increment the value of I, it will keep on running till infinity. Why? The value of I will always be 1. It will check that while the condition is less than I is less than 10, print I, so it will print 1, right? In the second iteration again it will check if I is equals to 1, yes it is equals to 1, it is less than 10, yes it is less than 10, it will print 1. So this loop will keep on running till infinity, right? So either to prevent this infinity thing, we can put the timeout value, right, in the until activity. We don't have any kind of timeout activity in the Python programming language. In the until activity in Databricks, we can put up this timeout value, or here in Python what we will have to do is that we will have to increment the I value from 1, okay, and then it will again check that okay, if it has printed 1, it will check. Now I has become 2, it is less than 10, yes, it will print 2. Then once it has printed till 9, okay, it will again go. Now the I has become 10 after printing 9 here, right? So 9 plus 1 is 10. Now it will check again if 10 is less than 10. So no, 10 is not less than 10. So it will come out of the loop and it will start printing the or executing the lines that is below this particular loop or the condition. Okay. So the same kind of while condition that we use in Python is this until activity that is there in the Azure Data Factory. Then validation activity. Ensure a pipeline only continues execution if the referenced dataset exists, meets a specified criteria, or a timeout is reached. Then wait activity. You can use a wait activity in a pipeline. The pipeline waits for the specified time before continuing with execution of subsequent activities. Web activity can be used to call a custom REST endpoint from a pipeline. You can pass dataset and linked services to be consumed and assessed by the activity. Then webhook activity. Using the webhook activity, call an endpoint, pass a callback URL. The pipeline run waits for the callback to be invoked before proceeding to the next activity. Then if we want to create a pipeline using UI, we have already created that particular thing in our Azure Data Factory. We can go on to this author tab. We can click on this plus button and we can go on to this pipeline, right? So here, once we have created the pipeline, okay, let's suppose this pipeline has been created. Okay, so here you will be able to see these activity tabs, right, that we are talking about right now. Okay, so if you want to do any activity, let's suppose you want to do copy data activity, right? So copy data activity we already have. Let's say data flow activity. Okay, so we can connect call this, or you can say just drag and drop. I won't say call. We can just drag and drop this data flow activity, and then we can pass the parameters. You can see here in the third section we will be able to pass the parameters. So here the general thing, if you want to give any name, description, state and all these things, then in the settings we can do the data flow setting, right? We can add any kind of data flow. Currently we don't have any. The compute size, right? And then we can add the parameters right here. Then the properties are also right here. User properties we can add, right? And if we want to add this property, so we will have it properties, right? So here we also have the properties if we want to add something. Okay, so here you can see Data Factory displays the pipeline editor where you can find all the activities that can be used within the pipeline in the number one thing. In the number second one, the pipeline editor canvas where activities appear to be added to the pipeline. So here we can also add these particular these two activities. Okay, these we can connect these two activities. Okay, something like this, right? Then let's suppose if we want to connect a notebook. Okay, so I can do it something like this also. So on success, I want to connect this. Let me delete this connection. Let me bring this notebook here, right? So let's say using data flow, right? On success, I am connecting it to the notebook. Any kind of transformation has happened, and let's suppose instead of this copy data activity, okay, I will ingest that data into not data explorer, let's say my data lake. Okay, and then I will be connecting it to this thing. So you can see this is activity 1, right? This is activity 1, this is activity 2, this is activity 3, and the grouping of all these 3 activities is pipeline 1, right? So this is what we have been doing till now. The pipeline configuration plane, including parameters, variables, general settings and output. The pipeline properties pane where the pipeline name, optional description and annotations can be configured. This pane also shows any related items to the pipeline within the data factory. Okay. Then using JSON also we can describe the pipeline, right? So this is what tag name. Okay, I guess from here. Okay, yeah. So this is describing basically this JSON file, right? So the name basically means the name of the pipeline. Specify the name that represents the action the pipeline performs. Maximum characters is this. Start with a number or an underscore. The following characters are not allowed. Okay. Then the description, specify the text describing the pipeline for use. Activity. The activity section can have one or more activities defined in it. See the activity JSON section for details about the JSON activities elements. So here we will be defining all the activities similar to this thing that we are describing in the UI. Okay. Then parameters. So the parameter section can have one or more parameter defined in the pipeline, making your pipeline flexible for reuse. So these parameters that we are defining here, right, for every single activity, as well as the optional parameter if we want to use for this whole pipeline, we can use it here or we can add it here. And the same thing in JSON can be added here. Then total concurrency. So the maximum number of concurrent runs the pipeline can have. By default, there is no maximum. If the concurrency limit is reached, extra pipeline runs are queued until earlier one gets completed. Then annotations, a list of tags associated with the pipeline. So all these things can be put up here. Parameters, concurrency, and annotations, right? Then activity JSON. So activity JSON can be described as in this way, that the name of the activity, the description of the activity, the type of activity, right? So you can see name of the activity, specify the name that represents the action that performs activity. Description is describing the describing basically that activity using text, and then the type of activity. So is it a data movement activity, a data transformation activity, or a control activity? Then the linked service name. Okay, here we will be giving the linked service name. So if you will go to any of the activity, you will be having some kind of linked services here, right? So you can give all those details here also. Then the type properties. So properties in the type properties section depend on each of the activity. To see type properties of an activity, select links of the activity in the previous section. Okay, then policy if you want to attach, and then depends on. So this property is used to define activity dependencies and how subsequent activities depend on the previous activity. Okay, then talking about the activity policy. So if we want to attach any kind of policy, right, so we can attach those policies. So policies that affect runtime behavior of an activity giving configuration options. Activity policies are only available for execution activities. Okay, so here different type of activities were there, right? So only the execution activities can have the activity policy. So here you will have to get the name. So you will have to put the pipeline name, the properties of activities, right? So you will give the activities here, then you can give the policy, and then you can give parameters. So timeout specifies the timeout for the activity to run. Retry, maximum retry attempts. Retry interval in seconds. So the delay between retry attempt in seconds. Then secure output, when set to true, the output from activity is considered as secure and are not logged for monitoring. Okay, so this, if you are putting the secure output as true, so the output, so basically the output, right, from this activity will be considered that it is a secure output, right, and it will not be logged for the monitoring purpose. Then there is something called as control activity. So control activity has the following top layer structure, right? So name, description, types, and depends on. So name of the activity, right? Description is the description of the activity. Type means see the type of activity, data movement activity, transformation activity, or control activity. Then type properties. So properties, in the type property depends on each type of activity, right? To see type of properties of an activity, select links in the activity in the previous section. Then depends on, so this property is used to define activity dependency and how subsequent activities depend on previous activities. Then comes the activity dependency. So activity dependency defines how subsequent activities depend on previous activities, determining the control of whether to continue executing the next task. An activity can depend on one or more multiple previous activities with different condition, different dependency conditions. So the different dependency conditions are succeed. Okay, here if you go, so first one is on success. Okay, so this is the succeeded condition. Okay, then there is failed. So this is the failed condition. Okay, so if we see, like if we have a certain condition that if data flows fails, then you run this notebook. So we will be connecting it from this one, and we will remove this connection. Then select it. Okay, and I can delete this. Okay, so now it has become that on failure of this data flow, you have to run this notebook. Earlier it was that on success of this data flow, you run this notebook. Then there is skipped. So let's say if this data flow skips, then you run this notebook. So we can connect it using this connector. Okay. And then there is last as completed. So once this data flow has been completed, then you run this notebook. So we can connect it like this, right? Something like this. So this is on success, this is on completion, this is on fail, and this is on skip. Okay. So let's delete these. Okay. So for an example, if pipeline A has an activity A, if pipeline has activity A and activity B, the different scenarios are bound to happen. So activity D has a dependency condition on activity A with succeeded. B only runs if A has a final status of succeeded. Activity B depends on condition on A with failed. So B only runs if activity A has status of failed. And if it has a dependency with completed, so activity B runs if activity A has final status of succeeded or failed. Okay. So here you can see, right? So on completion means it has completed the pipeline run, and after completion it can be either a success or a fail, right? So on completion means it will run on either of both of them. It will also run on success status, it will also run on the fail status. Okay. Then if there is a skip dependency, so activity B runs if A has a final status of skipped. Skipped occurs in a scenario of, let's say, activity X goes to activity Y, and then there is activity Z, where each activity runs only if the previous activity succeeds. So if activity X fails, then activity Y has a status of skipped because it never executes. Similarly, Z has also a status of skipped as well. Okay. So let's say there is also another pipeline where activity X, Y, and Z are there, and for any reason this activity X fails, and we have this the dependency as on completion of X you run Y. So if X fails, right, this, sorry, not on completion, on success. Okay, on success you run this X, sorry, you run Y after the success of X. So if X fails, the Y activity and the Z activity will be skipped, they will not run. Okay. So using the JSON, this is how you can define your activities. Then sample copy pipeline. Okay. So again, the copy data pipeline that we have used, the JSON file is right here. Okay. Note the following points. In the activity section, there is only one activity whose type is to set to copy. Okay, so here only one activity is set to copy, right? The input from activity is a set to input data sets, and the output of the activity is set to output data sets. Okay, here you will see inputs, the name is input data set, and for outputs the name is output data sets. In the type property section, blob source is specified as the source type as the source type, and SQL sync is specified as the sync type. In the data movement activity section, select the data source that you want to use as the source of sync to learn more about it. Okay, so here if you will see, so the source data set is the Azure blob and the sync data set is SQL sync. Okay, batch size can be this and the timeout is this much. Then sample transformation pipeline. So here you can see, if you want to do any kind of transformation, we can also do it using SQL. So in the following sample pipeline, there is one activity of type HD inside Hive in the activity section. In this sample, the HD inside activity transforms the data from Azure blob by running a Hive script file on Azure HD inside Hadoop cluster. So you can see the name of activity is transform pipeline. Properties, we have the description, right? Activities. So you can see HD inside Hive. So if we want to run any kind of, let's suppose, Hive query or something, so we will have to give the path of the file. So this is the file path or the script path that's given. So ADF get started /script /partition weblogs.hql, right? So this is my Hive query language script. Okay, then we have the linked service right here. Okay, input table and partitioned table are defined right here. Then input will be Azure blob input, and again output will be a blob itself. Then we have 3 number of retries, and the name of the activity is nothing but run sample Hive activity, and the linked service name is HD inside on demand linked service. Okay, so in the note the following points. Okay, in the activity section, there is only one activity whose type is set to HD inside Hive. The Hive script file partition weblogs.hql is stored in the Azure storage account specified by script linked activity called Azure storage linked service, and in script folder it contains the ADF get started folder. The define section is used to specify the runtime settings that are passed in the Hive script as Hive configuration set values. Okay, then the type property section is different from each transformation activity. To learn, we have to go on to this link. Then multiple activities in a pipeline. Okay, so the previous 2 sample activities have only one activity in them. You can have more than one activity in a pipeline. If you have multiple activities in a pipeline, the subsequent activities aren't dependent on previous activities, and the activities might run in parallel. You can chain 2 activities by using activity dependency, which defines how subsequent activities are dependent on the previous activity, determining the condition whether to continue executing the next task or not. An activity can depend on one or more previous activities with dependency activity condition. Okay, so if we are defining more than one activities in a pipeline and we have not defined any kind of dependency, so those activities will run in parallel. Okay, I won't say it will run in parallel, it might run in parallel, right? So we have, you can see right here, we have multiple activities. So if we have not defined any kind of dependency, right, if we are just relating these things, basically so this is nothing but the dependency that we are defining right here using this connect. Okay, so if we will just run this pipeline, so what it will do, it will run all the activities in the pipeline and it can run in parallel. So even if my data flow activity does not run fully, then also it can start executing this pipeline activity, and it may start executing this SQL activity also, right? But because we have to create a flow and we have to do a logical process that okay, if this either this fails or this skips, right, something like that, then you have to do the next activity, and once that activity has done, then you have to do the third activity. So this thing can be defined using the activity dependency. Okay, and this is how you can basically chain. So here we are chaining that on success you have to run the notebook. Okay, and if this notebook either runs or fails, so on completion of running this notebook you have to run this usql activity. Okay, so now I have created this activity dependency similar to this dependency that it is talking about. Okay, then scheduling the pipelines. So pipelines are scheduled by triggers. There are different types of triggers, that is scheduled trigger, which allows pipeline to be triggered on the wall clock schedule. So let's say if I have scheduled my pipeline to run on 5 p.m. every day, it will run on 5 p.m. every day. Then manual trigger, so we can manually go and trigger the pipeline. For information about triggers, you can go on to this article. So to have your trigger kick off a pipeline run, you must include a pipeline reference of the particular pipeline in trigger definition. Pipeline and triggers have many one-to-many relationship. Okay, multiple triggers can kick off a single pipeline, and the same trigger can kick off multiple pipelines. So one trigger is defined. Once the trigger is defined, you must start the trigger to have it start triggering the pipeline. Okay, so if a trigger is defined, right, so let's suppose if I am defining that at 5 p.m. my pipeline should execute, so I have to trigger that pipeline, only then my pipeline will get started. For example, say you have a scheduler trigger A, that wish to kick off my pipeline, copy pipeline. You define the trigger as shown in the following example. So you will have to give the trigger, you will have to give the pipeline, and then you will have to give the copy source name also. Cool. So these were the basically components, or I would say pipeline and activity components in the Azure Data Factory, right? So how we can define these components, like what is an activity, what is pipeline, what are variables, right? How we can define it using JSON, and also how we can define those activities from the UI, right? We have covered all these concepts in this video. Cool. So I hope you learned something new in this video. I will see you in the next one. Till then, keep learning and keep growing. Bye-bye. Hey guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course, and in this particular video we are going to talk about pipeline parameters and variables in Azure Data Factory, as well as the same concept can also be applied to Azure Synapse Analytics. So in the previous video we have already seen about pipelines and activities in ADF. So this particular video will be somewhat correlated to that particular video itself. So with that said, let's get started with this video and let's get straight into the system. So today we are going to understand about pipeline parameters and variables in Data Factory and Azure Synapse Analytics. So this article helps you understand the difference between pipeline parameters and variables in ADF and Synapse Analytics and how to use them to control the behavior of our pipeline. So pipeline parameters that are defined at the pipeline level and can't be modified during a pipeline run. Okay. So these parameters, pipeline parameters, as the name itself suggests, that these parameters will be defined at the pipeline level. If we want to pass any kind of variable to the pipeline, in that case we will be creating a pipeline parameter, and then we will be assigning those values to those parameters, and these pipeline parameters cannot be modified during a pipeline run. Pipeline parameters can be used to control the behavior of a pipeline and its activities, such as by passing the connection details of a dataset or a path of a file to be processed. Okay. So these pipeline parameters, it can basically control the behavior of that particular pipeline. Controlling the behavior means, so let's suppose if I am passing a parameter of a connection string of a data set, so it will pick up that particular data, right? So how it can be, let me just give you an example. So let's say I have a parameter one that specifies a connection string of a data store. Okay, connection string of a data store. So here I can pass any connection string depending on what data I want to process, right? And the pipeline, let's say this is the pipeline that we have. So these are nothing but our activities, right? So this parameter is on a pipeline level, right? It means it will apply on this whole pipeline. So I can let me do Control Z and change the color. So this is my pipeline 1. Okay. So here, right, let's suppose we are using this data, this connection string as a data source in this pipeline. So earlier I can give this connection string as, let's suppose, a SQL database, a connection string of SQL database. Later on I can modify it to, let's say, MongoDB. So both of the processing of a structured data and semi-structured data will be different, right? So depending on the kind of data, we may give some kind of condition here, right? That if, let's suppose, the structured data is coming, you process in this fashion. If the unstructured data is coming, you process in this way, right? So depending on this connection string variable or the value that I will be passing, the behavior of the pipeline can change, right? So this is what it's saying. Then how to define a pipeline parameter? So to define a pipeline parameters, use these steps. Select your pipeline and view its configuration tab. So let's suppose this is my pipeline, right? So here you can see right here that we have a parameters written right here, right? Select the parameter tab and select plus new button and define new parameter. Enter the name and the description of the parameter. Select its type from the drop down menu. Data types can be string, int, float, boolean, array, object, or secure thing. Optionally, you can also assign a default value to the parameter. Okay. So if you will come here, if I click on new, so I can give the name, let's say connection underscore string. Okay. So if I'm already aware about the fact that it will be a string, and I can also pass some kind of default value. Let's say I want to connect it to my, let's say, localhost. Okay. I guess it's 5432 for MySQL database. Not very sure, but just for an example, right? So now it will become the default value. If I want to add more parameters, I can do those things right here. If I want to delete any parameter, I can delete it from here. Okay. So before each pipeline run, you can assign a new variable for your parameter in the right panel. Otherwise, the pipeline uses the default or the value previously defined. Okay. Okay, fine. Right. And then comes the pipeline variable. So pipeline variables are the values that can be set or modified during a pipeline run. Unlike pipeline parameters, which are defined at the pipeline level and can't be changed during a pipeline run. Pipeline variables can be set and modified within a pipeline using a set variable activity. Okay. So how can we do it? So pipeline variable can be used to store and manipulate data during pipeline run, such as storing the results of the computation or the current state of process. Okay. So these variables, just like we do in the programming in the programming languages, right? That we use variables to store some kind of temporary values. So let's say after we have done some computation, right, and we have to store some value, so we can set a variable and we can store that value, and that value stored value or the stored result of the computation can be used later on, right? Similarly, we can also store the current status of the progress. So let's say if my current status of the progress is I have ran till this particular checkpoint, so I can store that checkpoint in some kind of variable, and later on I can use it to restart my pipeline from that particular checkpoint itself. So note, variables are currently scoped at a pipeline level. This means that they are not thread safe and can cause unexpected and undesired behavior if they are accessed from within a parallel iteration activity such as for each loop, especially when the value is also being modified within the for each activity. Okay. So the pipeline variables are currently defined at a the variables, you can say, not the pipeline variables, because obviously pipeline variable will be defined on the pipeline variable itself. So just even the simple variables are defined at the pipeline level itself. Okay. So while defining and while using the variables, we have to be very, very careful. Means, let's say if we have defined a variable x outside some kind of for each loop, right? And then here I am using the for each loop. Okay, for let's suppose for loop, right? And then here I am defining the variable of x is equals to y. So here it can cause a conflict, right? Because both of these x variable, right, are having different values, even though the scope of this variable is inside this for loop, right? If I talk about the programming language, so the scope of this variable and this variable will be different. But here in the in the data factory, the scope of these two variables are same, that is on the pipeline level. Okay. So while defining and while naming these variables, we have to be very, very careful because of the scope of the variables. Okay. So to define the pipeline variables, follow these steps. Select your pipeline to view its configuration tabs. Okay, so I can, let's say, select my pipeline. I have selected my pipeline, and then I can view its configuration tab. Okay, so where will I get the configuration thing? Here only, right? In the variables itself. Okay. Then select the variables tab and select on new button and define new variable, enter the name, right? And select the type of the data from the drop down menus. Types can be string, boolean or array. Optionally, you can assign a default value to the variable. This value will be used as a initial value of the variable at the start of the pipeline. Okay. So again, I can come here, I can add a variable. Let's suppose status. Okay, it will be string, and default parameter I can give as start. Okay, right? I can add a new parameter. Let's suppose count, right? Count can be, let's say, integer, right? And the by default value can be, let's suppose, 1. Okay, and like that I can define the pipeline variables also. And if I want to delete any of them, I can just check it here, and I can click on delete to delete those variables. After defining a pipeline variable, you can access its value using a pipeline run by using variables, kind of variables expression @variables, and inside here you will pass the variable name, something like, let's say, status. Okay, expression in the pipeline activity. For an example, if you define a variable called flag of type array, it can be accessed. You can access its value in the activity by using the expression as @variable and flag, something like this. You can also use a set variable activity to modify the value of variable within a pipeline. So we can also modify the value by using the set variable activity. So let's say if something happens, if my function does not run properly, I have to flag this as false. So I can use the set activity variable to flag that particular value to false. Cool. So this is how we can use pipeline parameters and pipeline variables, right, inside the data factory, or I would say inside our data factory pipelines, to basically modify and to control the behavior of the pipeline. So I hope you guys learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course, and in this particular video we are going to talk about how to monitor Azure Data Factory and Synapse Analytics pipeline using annotations and user properties. So in the previous video we have already seen how we can create the parameters and the pipeline variables, as well as we have also seen what exactly is pipeline and activities inside the Azure Data Factory. So with that said, let's get started with this video and let's get straight into the system. So today we are going to see how we can monitor our ADF and Azure Synapse Analytics pipeline with annotations and user properties. So here if you see at this applies to section, so you can understand that, okay, if I talk about pipelines and activities, okay, so here also you will see that it applies to both Azure Data Factory and Synapse, right? Same here, it applies to both. But if like in some documentation, it may not apply for Synapse. So here you will see a cross, right? And in the Azure Data Factory section, you will see a tick, right? So it means that covering this single documentation can help us cover both of the services, ADF as well as the Synapse. Okay. So now when monitoring your data pipeline, you might want to be able to filter and monitor a certain group of activities, such as those of a project or specific department's pipelines. You might also need to further monitor activities based on dynamic properties. Okay, so we can achieve these things by using the annotations or user properties. So let's suppose if we have created multiple pipelines. So obviously when we will be working in an organization, there won't be a single or maybe 2 or 3 pipelines in our ADF that we will be having. We may have even, let's suppose, in 50s or even in hundreds, the number of pipelines can range up to. So we may want to filter a certain pipeline, or we want to monitor a certain group of activities, right? And such projects and pipelines can be of specific department, right? So let's suppose we want to monitor the pipeline related to the finance department or maybe to the sales department and like that, right? So to doing those things and to grouping those pipelines basically together so that we can filter out them easily can be done using the annotations and user properties. So Azure Data Factory annotations are tags that you can add to your Data Factory or Synapse Analytics entities to easily identify them. An annotation allows you to classify or group different identities in order to easily monitor or filter them after an execution. Annotations only allow you to define static values and can be added to pipeline, datasets, linked services, and triggers. So annotations will basically help us. So annotations are, you can say, the values for the filtration. Whenever we apply some kind of filtration operation, maybe on our data or on even on the web pages or something, so we filter according to some value. So we can filter it, let's suppose, with respect to the price, with respect to the rating, right? And maybe some kind of relevance, and all these filter operations can happen on any kind of application, on a web page, or even on the databases. So to apply those filters, we need some kind of filtering things. So these filtering operations can be done using these annotations. Okay. So, and these annotations allow us to define the static values that can be added to the pipeline, datasets, linked services, and triggers. Then comes our user properties. So user properties are key value pairs defined at the activity level. Okay. So just keep this in mind that annotations can be defined at any level: pipeline, data sets, linked services, and triggers. Whereas the user properties will be defined at the activity level. By adding user properties, you can view additional information about activities under activity runs window that might help you to monitor your activity executions. These properties allow you to define dynamic value that can be added to any activity, up to 5 per activity, under user properties tab. Okay, so under the user properties tab, we can basically add 5 user properties, right? uh, we can add up to 5 user properties per activity, right? And if we will come here, and if we you can see here in properties, if we want to add the annotation to our pipeline, we can just click on this new and we can add some kind of annotation, right? So let's suppose we add here, let's say sales, right? And we can add, let's suppose, sales pipeline, like that, right? And pipeline, something like that. We can add the annotations so that when we will be filtering these pipelines later on, so we can filter on these values. So create and use annotations and user properties. So as discussed, annotations are static values you can assign to pipelines, to data sets, linked services, and triggers. Let's assume you want to filter for pipeline that belong to the same business unit or project name. So we first create the annotation, select the properties icon, click on new button, and name your annotation appropriately. We advise being consistent with your naming. Okay, so you can click on here, right? And then you can click on new and you can add your annotations here. So when you go to the monitor tab, you can filter pipeline runs for this annotation. Okay, right? So when we go to, let's suppose, pipeline, okay, if I refresh this, okay, fine, currently we don't have any pipeline, right? We have not published this pipeline. So here, if you will see, right, so this pipeline is not published yet. Okay, so for that reason we are not seeing those pipelines, right? But when you go to your pipelines, right, and you can add your annotations to filter it accordingly, right? Now if you want to monitor for a dynamic values at activity level, you can do so by using the user properties. You can add these under the any activity by clicking on activity box, user properties tab, and then you can click on new. Okay, so let's suppose if you want to add user properties in this activity, so you can click on this activity, you can go to user properties, and then you can click on new, and you can give a key value pair, right? So let's suppose data flow. Okay, and the value that I want to give is uh, anything, let's say ADF data flow, like this. Okay, obviously we will be giving some kind of meaningful information here, but like that we can add those information. So here you can see that you can select on any activity, right? And then after selecting on that activity, you will have to go on to this user properties, then you can click on new. Either you can also auto generate. So no, I'm not seeing this option of auto generate right now. Okay, so either you can auto generate it, or by using, so you can see, right, for source value is here, right, destination value is something like this. So to monitor user properties, go to activity runs, monitoring view. Here you will see all the properties you have added. You can remove some of the view if you select the bookmark sign. Okay, so here you can also remove if you want to do it. Cool. So basically, to do some kind of filtration operation on our pipelines, right, and on our activities, we can add the annotation as well as the user properties depending on where we want to add those values. So if we want to add those values inside, like on a pipeline level, data set level, linked service level, or trigger level, we will have to go ahead with the annotations. And annotation will be a static value, a single value. Whereas user properties is a kind of key value pair that we'll be adding. And we can add those key value pair or the user properties in the activities that we have created. Okay, and in any of the activities, it's not limited to a certain activity. We can add the user properties in any of the activities that we have created, and later on when we will monitor our pipeline, we will be able to monitor and see those activity user properties values in the monitor tab also. Cool. So this is pretty much it for this particular video. I hope you learned something new. I will see you in the next one. Till then, keep learning and keep growing. Bye bye. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course, and in this particular video we are going to talk about nested activities in the data factory, as well as the same concept can be applied in the Azure Synapse Analytics service also. So in this whole course till now we have covered multiple concepts like what is a cloud, how many different types of cloud are there, what is Azure, how you can sign up and get free $200 credit of credit in the Azure cloud. Then we have talked about the Azure Data Factory. So we have already learned about what is pipelines, what are activities, how we can do copy data activity, as well as how we can interact programmatically with our Azure Data Factory. So we have already covered all these concepts in great detail as well as practically. And now in this video, we are going to cover the nested activities. So with that said, let's get started with this video and let's get straight into this system. So here for today's topic, it will be nested activities in ADF and the Synapse Analytics. So this article helps you understand nested activities in Data Factory and Synapse Analytics and how to use them, limitations and their best practices. Okay. So a data factory or Synapse workspace pipeline can contain control flow activity that allow for other activities to be contained inside of them. Okay. It means that we will have one activity. So we will have this. We will have basically this nested activity. Right? We can have our nested activity. And inside this nested activity, we will have few more activities. Okay, so this is nested activity. And inside this nested activity, we can have activity, let's suppose 1, activity 2, and so on. Okay, so like that. So this is the reason why it's called nested activity, because there are a few activities inside a certain activity. So this is what a nested concept is, right? So for other activities to be considered inside them, think of these nested activities as containers that hold one or more other activities that can be executed depending on the top level control flow activity. Okay, so depending on the control, or the, I would say you can say the condition, right, it will get executed. It means the inner activities will get executed according to that flow. See the following example with an if activity that has one activity contained. Okay, so here there is an if else condition or if else activity, right? Here you can have a true activity, right, where if the condition is true, you have to perform this activity. If the condition is false, currently there are no activities, right, but we can also add some activity here. If the condition is false, you can do this activity like that. Okay, so how, where you will be getting these things? So you can here search for it. Let's say if condition, right? Let me just make it a bit bigger. Okay. And now I can just drag and drop the condition here. So here you guys will be able to see that this is one activity. This whole bluish outline that you are getting, this is one single activity. And inside this one single activity, we are having other activities. So if the condition is true, I can click on this edit button. Okay, I can click on this add activity or even this edit button. So okay, fine. I can validate those activities. Got it. Right. So first of all, I will have to add an activity, right? So I can click on this. So let's suppose if the activity is true, let's say execute one of the pipeline. Okay. And then I can do what? I can do, let's say, or before that, let's say I'm doing, I can delete this. Okay. So first of all, I can do some kind of, let's suppose, filter operation. Okay. And then what I can do, let's suppose, I can execute a pipeline like that. Okay. And then in false, I can do, let's say, run a notebook, right? And then call a function like that. So, and then here in the conditions, so here you will be able to see this whole pipeline can be named anything. Let's suppose I can name it as if else activity, right? If I want to give any description, I can give it here. I can keep the state as activated or deactivated, right? Depending on my use case. Here, when you will come to activities, right? So here you can add some kind of expressions if you want to add. Then there are cases. So case can be either true or false, right? So in true, we have two activities, you can see right here. And in false, we have two activities, as you can see right here. And we can also edit these activities depending on the requirement, right? So if I will click on this edit, right? So you can see what filter activities do I have to do. So let's say filter data. Okay. And then in settings, I can get the items, I can get the collection and like that. So currently I don't have the whole, I would say the whole ecosystem to run this particular activity. So I'm just showing you guys a vague example, I can say, right? So this is not a real example. For sure, when we'll be moving forward, I will be using these things, and these like if else kind of activity we usually use inside a pipeline. Okay, we will not be creating this if condition activity individually. Mostly we will use this particular condition in a pipeline. So let's say I am having multiple data sources. Okay, so I am ingesting the data from, let's say, a Postgres database. Okay, and I am having, let's say, a MongoDB, right? MongoDB. So here we are already aware about the fact that here we will get the structured data and here we will get the semi-structured data, right? So here I can put this if else condition and I can validate the schema that, okay, if maybe if my data is semi-structured or if it is not in a tabular form, right? So if I can put a condition as, let's say, tabular. Okay, I can check the schema, and if my schema is tabular, so tabular is equals to true, then you execute, let's say, script 1. Okay, that will be basically, let's suppose, doing the filtration operation, aggregation and all those stuffs, right, on a tabular set, because ultimately we can't use the exact same piece of code for the tabular data and non-tabular data, or maybe the unstructured or the semi-structured data. We will have to change our code in such a way that it can get executed, like it can execute one of the type. Either it can execute the structured type or it can execute the unstructured type, right? So here I can do the same thing, that if it is structured, you execute the script one, or if it is if this tabular is equals to false, then you execute this script too. And maybe even the ultimate pipeline of both of these two can be a bit different. So this is where this if condition activity comes into picture. Okay, let's move forward and we will be understanding all the things. So here you can see one activity is given here, and here true, in true condition we have one activity. We can also keep this false condition as without any activity. There is not a strictness that we have to create activities for both of the conditions. Now control flow activities. The following control flow activities support the nested activities. So first control flow is for each. Okay, so for each is also a kind of nested activity. So for each activity defines a repeating control flow in your pipeline. So as we are already aware about that, for each is basically a kind of loop. Okay, so wherever we have to repeat the things or repeat our control flow, there we will be using this for each activity. This activity is used to iterate over a collection and executes specified activities in a loop. Okay, the loop implementation of this activity is similar to the for each looping structure in programming languages. So it's exactly similar to the for each loop or even the for loop if I talk about the Python programming language. So it is exactly similar to that loop implementation, right? Then talking about the if condition activity. So the if condition can be used to branch based on the condition that evaluates to true or false. So the condition the if condition activity provides the same functionality that an if statement provides in the programming languages. It evaluates a set of activities when the condition evaluates to true and the other set of activities when the condition evaluates to false. So just like in the programming language, we have the if else condition, that if that condition is true, you have to perform this statement, right? Or maybe these tasks. And if the condition is false, you have to perform these tasks, right? So this thing we do in the programming language also. And the very same functionality this if condition activity holds. Then until activity implements do until loop, which is similar to do until looping structure in programming languages. It executes a set of activities in a loop until the condition associated with the activity evaluates to true. You can specify a timeout value for the until activity. Okay, so until activity, if I associate with Python programming language, so it's equivalent to the while loop. Okay, it's exactly equivalent to the while loop in Python. So it will keep on executing. Okay, so just like we do that, right? While I is less than 5. Okay, so till my value of I is less than 5, it will keep on executing whatever I will try to execute in this particular loop. So let's say print high, right? So it will keep on printing high, right? So the very same thing, this until activity will keep on doing. It will iterate until the condition specified evaluates to true, or we can also provide the timeout value, so that this particular loop does not run till infinity. Then there comes the switch activity. So the switch activity provides the same functionality that a switch statement provides in the Python in the programming language. It evaluates a set of activities corresponding to the case that matches the condition evaluation. So switch activity does what? So let's say we have some conditions, right? Like let's say salary, right, is less than 10,000, right? Then we can switch as salary less than 5,000, right? Salary less than 2,000 and so on. So here again, if it's a kind of if else condition, but with larger number of conditions. Okay. Now let's understand this, how we can navigate through these nested activities. So there are two primary ways to navigate to the contained activities in the nested activity. So each control flow activity that supports nested activities has a activity tab. Selecting this activity tab will give you a pencil icon that you can select to drill down into inner activity panel. Okay, so this pencil tab, we can drill down to the inner activity. From the activity on the pipeline canvas, you can select the pencil icon to drill down to the inner activities panel. Additionally, the for each until activity supports double clicking on the activity to drill down on the inner pane. Okay. Then your pipeline canvas will then switch to the context of the inner activity container that you selected. There will also be a breadcrumb trail on the top, so you can navigate back to the parent pipeline. Right. So here you will see each of the things. So let me just do one thing. Let me delete these activities first of all, because right, it's not making any sense right now. Okay. So here you can see that this pencil button, like the documentation is talking about, right? So here we can click on this edit and we can go into the inner activity of that outer activity, right? So this was in if else activity, right? So if I go to again copy data pipeline, you will be able to see this if else activity. And now if I want to get into this true activity, okay, so here these are a set of one activities, right? And these are a set of other activities, and this whole is one activity. So this is why it's called a nested activity, that we are having activities inside the activity. Okay, I hope now it's absolutely clear why this is these conditions basically. So here we have if else activity, right? We can have for each activity, right? So even if I will expand my for each activity, you will be able to see the options of activities, right? Then we have until activity, right? So you can add activities, and the last one is what? For each if else condition, until and switch activity. Okay, so we can also see the switch activity. Okay, so let me just put it here. I will drag it here and let me open it. So here you can see we have the switch activities. So inside all these activities, you will see what's similar is, let me zoom out a bit, right? So here you guys will be able to see that one thing is common, that we have an option to add few activities inside these activities, whatever we have, the if condition, for each activity, until activity, and the switch activity. Cool. Now let's understand through the documentation, right? And then moving forward, we will be covering each of these activities in a great detail. Then we have nested activity embedding limitations. Okay, so there are constraints on the activity that support nesting for each, until, switch, and if condition for nesting other nested activity specifically. So if and switch can be used inside for each and until activities. So we can even use nested activities inside a nested activity, but for using that we have certain conditions. Okay, so the condition is what? That inside our for each and until activities, we can use the if and switch activities. If and switch activities can't be used inside if and switch inside the if and switch activities. So if activity and switch activity, it can't be again used inside if and switch activity. Okay, then for each or until supports only a single level of nesting, and these activities, that is for each and until, only only support a single level of nesting, means only this level of nesting it can do. What we can't do is inside this until, right, we can create an activity, and inside this activity also we can create a nested activity. So it's currently not possible. Maybe moving forward it may be possible, but on today's, that is 17th of December 2025, there is no such functionality provided by Microsoft Azure. So see the best practice section below and see how other pipeline activities can enable this scenario. In addition, the validation activity can't be placed inside the nested activities. So validation activity cannot be used inside the nested activity. If and switch can be used inside for each and until activities. Okay, for each and until supports only one level of nesting if it can't be used if and switch can't be used inside if and switch activities. Okay. Now talking about the best practices for multi-level of nested activities. In order to have the logic that supports nesting more than one level deep, you can use the execute pipeline activity inside of the nested activity to call other pipeline that then can have another level of nested activities. Okay. A common use case of this pattern is the for each loop, where you need to additionally loop based off logic in the inner activities. So even if you will open this particular documentation, right, you will be able to see how we can create an execute activity with the UI. Create an execute pipeline activity with UI. Okay. So what it will be doing, it will execute a pipeline, maybe send email. Okay. Okay, it's just in the JSON format for right now. Okay. Then a common use case of this pattern is with the for each loop, where you need to additionally loop based off logic in the inner activities. An example of this pattern would be if you had a system file that had a list of folders, and each folder there are multiple files you want to process. You would accomplish this pattern generally by performing the following. Okay. Using a get metadata activity first to get a list of just the folders. So using this metadata activity, okay, get metadata activity, what we will do is we will get a list of folders. Maybe currently it's not showing us, right? Get metadata 1. So kind of output that we will get is not shown. Okay. So don't worry. What we will do is we will basically get all the folders that are present in the location that we are trying to get the metadata of. Okay. It can be a database. It can be maybe a blob storage, right? It can be a container or anything. Then pass the result of the get metadata activity into the items list of a for each activity. Each iteration then represents a single folder to process. Okay. So we will use a get metadata activity, right? And we will get the folder list, and we will then attach this particular activity to the for each activity, where we will get what? We will get the list of files in the folder. Okay. And then we will process the list of files. Okay. In the inner activity panel for each activity, use another get metadata activity to get the files of list inside the folder. Okay. So what we will do, let me delete this one. For each we are going to use, let me delete this one and let me delete this one. Okay. First of all, what I will do is I will use this get metadata activity. Okay. So here I can add that where what kind of data set do I want to use. So let's say I want to use this data set. Okay. And new field I can add. So I can add here item name. Okay. And here I don't have the status. Timeout can is fine. This is fine. Cool. Parameters I can delete. Obviously I won't need any parameter. Variables I can also delete. These things I have created for the previous videos. Okay. So here I have created my get metadata activity, and on success I am connecting it to the for each activity. Okay. I'm connecting it to the for each activity, and then what I will do inside my for each activity, I will again use the get metadata thing. Okay. So here I will do what? I will use my get. I can search here get metadata. Okay. And here if I click, go to settings, right? Okay. So here I can do settings. I can create the data set as source. There I have selected source or destination here. Source one, right? So like here I can go and I can click on this thing, go on to source, field list, item name. That's it, right? And then what I will do is I will then process the file. So I will run this pipeline activity, execute pipeline. So here currently we don't have any kind of pipeline to execute, right? Invoke a pipeline. So I will have to create a pipeline in this case. But let's keep it till here only, right? It will give us a few error, but let's keep it till here only, right? Get matter detected to process file. Then call an execute pipeline activity that has an array parameters and pass it to the array of those file names. Okay. Then in the child pipeline, you could then use another nested activity such as for each with the passed in the array list to iterate over the files and perform one or more sets in the inner activities. So the parent pipeline would look similar to the below pipeline, something like this. And the child pipeline would look similar to this particular thing. So it will look something like this. Okay. So here you can see, and here let's suppose I can give this particular thing also. Okay, so I can get this metadata, and here I can get the pipeline dot parameters dot list of files. So at the rate pipeline dot parameters dot list of files. So parameters dot list of files. Okay. Cool. And then I can click on this. List of found was not found in the copy data. Hmm. Okay. I, I click on OK, let's suppose. And here if I go to this one, settings, item name I have given already. So if I come here, the files. Okay. So I guess I had some kind of expression of expression of type. String does not match the field items expect in an array. Okay, we need at the rate. The files was not found under the list of files. It seems fine at the rate pipeline dot parameters dot list of files. Under settings inside items, I have to put the same, right? Under settings inside items. Okay. And what's the issue with mine? Rest of the things seems fine here. Item name I have put. Then let me delete it. No worries. Okay, but it is required. Add a dynamic contingency. Execute pipeline one dot output. Put metadata name, item name. Okay, let's see. Okay, and now what I will do is before running this pipeline, I will publish it, or maybe I can't like I don't want to publish. I can just trigger now. Okay, and then I can click on OK. So now I can go to my monitor, and here you will be able to see that my copy pipeline is now running, and currently it's in progress. I think it will fail because we don't have any pipe. Okay, it succeeded. I can refresh this only. Okay, it got succeeded. Let me open this. Let's see what we have got, and we can click on this detail. Acha, okay, fine. Okay, so what what mistake did I do is, right, that I did not publish it. Okay, so it has ran the same pipeline. Okay, so publishing basically means updating, like saving, just like we do inside our VS Code, right? Whenever we change some code, so we have to do Control S if we have not enabled that auto saving, right? So until we don't do Control S, the newer code or newer file will not be saved. So the same thing comes here also, that we will have to first of all publish all. So publishing an error, you have to fix it before publishing. Okay, what's the error? Invoke a pipeline. Okay, so we don't have a pipeline. Let's create a new pipeline. Pipeline one. Okay, pipeline one. That's it. I guess now it's fine. So publish all two. Pipeline one should have at least one activity. So okay, I can close this. I can close and discard. Execute pipeline one. I can add an activity. Let's say copy data activity, not copy data activity because it will need something. I can't even do pipeline activity. I let me do get metadata activity inside pipeline one also. Okay, get metadata. So inside pipeline one, I will do what? Get metadata activity, right? And I will do the same activity here again. Source one. Get it from source and field list. You get the item name. That's it. Then I can click on cancel. I can publish both of them, and I will click on publish. Okay, so now it will be publishing, and publishing is now complete. And now what we can do is I can come on this copy pipeline, and I will trigger it now, and I will click on OK. So pipeline failed, right? Obviously we are aware about the fact that it's going to fail, right? And we can come here, right? We can come here and we can even get to know what was the reason of failure. So all pipeline run, right? You can see here code error, invalid template, unable to parse and get metadata one. Okay, so it was basically not able to get the metadata. So no worries. Currently, my agenda is only to show you how we can create these nested activities. Okay, so basically we created an activity inside an activity, right? And then we ran our pipeline, right? Because we don't have all those things set up, setting all those things will take some time, right? Like a bit of time. So what we will do is, moving forward, we will be seeing all these nested activities one by one individually in great detail. Cool. So I hope you guys learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course, and in this particular video we are going to talk about the linked services in Azure Data Factory. So till now in this particular course we have already covered multiple concepts like what is cloud, how many different types of cloud are there, what exactly Azure is, and how we can get free $200 worth of credits inside the Azure. And then we have talked about how we can use the services related to data engineering inside our Azure cloud. And we have talked about the ADF, that is Azure Data Factory, the service that is the most highly used service if I talk about the data engineering domain. So with that said, let's get started with this video and let's get straight into the system. So today's topic will be linked service in Azure Data Factory and Azure Synapse Analytics. Means both of the services will be utilizing the same concept when it comes to the linked service. So this article describes what linked services are, how they are defined in JSON format, and how they are used in Azure Data Factory and Synapse Analytics. So the Azure Data Factory and Azure Synapse Analytics have one or more pipelines, right? A pipeline is a logical grouping of activities that together perform a task. So we have already known this fact that both Synapse and ADF can have multiple pipelines, and a pipeline is basically a combination of multiple activities that are grouped together and they perform some kind of task. The activity in a pipeline define actions to perform on your data. Okay. Activities are nothing but the actions that will be performed on our data to basically convert that particular raw data into some kind of meaningful data. For example, you might use a copy activity to copy data from SQL Server to the blob storage. Then you might use Hive activity to run a Hive script on your Azure HD Insight cluster to process data from right uh, to process data from blob storage to produce output data. Okay, so the whole pipeline can look something like this, that we have an SQL server. Okay, from this SQL server we have moved our data to my blob. Okay, then from this blob, using HD Insight, okay, we are running some kind of Hive query. We are running some kind of Hive query on top of our data. Okay, to process the data from blob storage to produce output data, right? Then this output data can again be let's say copied to maybe a blob again, right? Finally, you might use the second copy activity to copy the output data to Synapse Analytics, on top of which business intelligence reporting solutions are built. Okay, so instead of this blob, what the documentation is saying that I can basically dump this data in my Synapse. So it's SY NAPSE. Okay, NAPSE. Okay, Synapse Analytics, and on top of this Synapse Analytics, we can do our BI part or the business intelligence thing, right? So these individual things will be one activity, right? So this is activity 1. Okay, this thing can be activity 2, and then this thing can be activity 3, right? Now a data set is a named view of the data that simply points to or references the data that you want to use in your activity as input and output. Okay, so data sets are nothing but it's the data itself, right? Or it references to the location where the data is kept, right? So here we will be creating two data set. Okay, the input data set in this pipeline will be my blob, right? And the output data set in this case or in this pipeline will be my Synapse. Okay, so this is nothing but a reference that, okay, let's say in this container, right, in this folder, there is my input data that you want to ingest into your HD Insight. And after doing your HD Insight processing, you need to write the data inside this Synapse Lakehouse, or maybe the Synapse folder, right? So these input data set and output data set will be nothing but the reference of the data that we will be using in these activities as inputs and outputs. So before you create a data set, you must create a linked service to link your storage to the data factory or the Synapse workspace. Linked service are much like the connection string, which define the connection information needed for the service to connect to the external sources. Okay, so now if I talk about here, so we need to create these connections. So if I need to ingest my data from SQL Server to blob, right? So I need some kind of connection between these two services, right? These two services are a separate container. If I talk about like this, so this is my SQL Server, right? This is my SQL Server, and this is my blob, right? They don't have any kind of connection between them. They both are basically running in an isolated environment. So to create a connection in between them, we need some kind of linked service, right? So we will be needing some kind of linked service. Okay, not server, service. Okay, linked service we will be requiring. And these linked service are nothing but a kind of connection strings, okay, which define the connection information needed for the service to connect to the external sources. Think it of this way: the data present represents the structure of the data within the linked service store, and the linked service defines the connection of the data store. Okay, so this data set and linked service are somewhat connected. Data set will represent the structure of the data that will be present in this linked store, right? Means if that data is an unstructured data, semi-structured data, or unstructured data, or basically the schema of that particular data, data set will represent the schema of the data of the service, right? Data set will basically, if I talk about data set, so it will represent the schema of the data that will be present in this SQL Server, or the schema of the data that will be present inside this blob. Okay, and the linked service will define the connection. Okay, linked service defines the connection to the data sources. So these two are the data sources, and linked service will define the connection of these two data sources. For example, blob storage linked service links to storage account to the service. An Azure blob dataset represents the blob container and the folder within the Azure account that contains the input blobs to be processed. Okay. Let me just remove these things, these lines. Okay. Now, before you, okay, this is done. So here is the sample scenario. To copy data from blob storage to SQL database, okay, you need to create two linked services. First one will be the Azure storage and the second will be Azure SQL database, right? then create two data sets. First one will again be our blob data set, which refers to the Azure linked service, and the Azure SQL table data set, which refers to the Azure SQL database linked service. The Azure SQL storage and the Azure SQL database linked services contains connection strings that the services uses at runtime to connect with your Azure storage and Azure SQL database respectively. The Azure blob dataset specifies the blob container and the blob folder that contains the input blobs of your blob storage. The SQL table dataset specifies the SQL table of your SQL database to which the data is to be copied. Okay, the following diagram shows the relationship among pipeline, activity, dataset, linked service, and linked service in the service. Here again, there will be a data set, right? It can be either a file or a table. The activity can consume the data or it can even write or produce the data, right? Pipelines is again a logical group of activity, and both activity runs on the linked service, right? So maybe an SQL server, right? A Hadoop cluster and like that. Okay. And dataset represents the data items stored in linked service. Okay. Dataset basically represents the data items that are stored in this linked service. So these are the services, right? Let's suppose the SQL server, let's suppose my blob, right? Maybe some kind of ADLS or anything. Those things will be present inside my, like that those things will be categorized basically inside my linked service. Okay, so how we can create a linked service using UI? So I hope I should delete these things now and make it clear. Okay, so how we can create linked service with UI? So to create a new linked service inside the Azure Data Factory Studio, select the Manage tab and then Linked Services, where you can see any existing linked service you defined. Select New to create a new linked service. Okay, so let's go back here. Let's go to Manage. And here you will see the option of linked service. So I will click on this linked service. So for the copy data activity, we already had created one linked service, right? So it is visible here. I can create a new one. Okay. After selecting the new, create a new linked service. You can choose any of the supported connectors and configure its detail accordingly. Thereafter, you can use the linked service in any pipeline you create. Okay. So I can create any linked service. So let's suppose, so currently I don't have the credentials of S3, right? But let's say if I want to connect to my S3, so I can click on this S3, continue. Here I will have to put some details. Okay, so here I can name my link service. Okay, and these things can be fine. So here I can use the authentication as, let's say, access key, or I can use the authentication as a temporary security credential also. Okay, so here if I'm putting this temporary security credential, I will also have to put a session token, right? But instead of this, I can, if I go to access key, so here I will have to put my access key ID and the secret access key, which I will get from my AWS account, right? I will not get it from these accounts. If I have already stored those secrets in my Azure Key Vault, I can directly access it from my Azure Key Vault. But currently If it is not, we have to directly pass. So it will again be a kind of connection string. Okay. Let's see if we can get some kind of access key. Obviously we will not get these access key id aws demo. Okay, demo. So if I show you, I just want to show you how it looks like. Okay. um I guess this is the one. No. Okay, so you can see, right? If you even see here, you will see here, right? It's blood, but it will have some string value like this, and the secret access key will be something similar. It can have some kind of numeric as well as the string values both. Okay, so this is how your secret access key will look like. So you can just copy and paste your access key and your secret access key here. Then your service URL will be this itself, right? And then once done, you can click on create. Okay, either you can test your connection to the linked service or to some kind of specific file path also. So you can pass your bucket name as well as your directory name here. And if you directly want to connect to just the S3 in that account, so you can connect to the linked service. Else you can directly connect if you only want to give some like the access of some specific bucket only, or maybe inside a specific bucket a specific directory only. That thing is also possible here. Okay, so I will discard the changes because I am not having the AWS S3 credentials right now. Okay, so what I will what you guys can see here is you can connect to all these services that are present, right? These are the Azure services themselves, right? So let's see now what's documentation is saying. Okay, you can, okay, it's not has created, right? So let's go ahead with some kind of SQL service. Okay, so I will have to launch SQL database in this case. Let's do it. Okay, so let's say I want to create an Azure SQL database and I want to link it to this SQL Azure database. Okay, so it will authenticate. So it has authenticated, right? So Azure SQL database linked service. Okay, if I want to add any kind of description, I can add it. Okay, then from this server name, currently I have not deployed any kind of server. So what I will have to do is I will have to go to my, okay, sign in again. I can go to home, right? And here I can search for the service that was SQL server, right? Azure SQL database, not SQL server. So SQL, Azure SQL database, right? So this is the service, right? So here what I can do, I can click on create. I will create the free offer one. Okay. So I will have to create the server. So server name, let's say, authentication mode is fine. Okay. And I can click on OK, right? So I have created a new server. I have done this and then I will click on. So here what I have done, added the subscription. It has automatically got the subscription. Resource group, I will add it to the VS17 resource group. Okay. Okay. Fine. I will have to add it to, because the server is in which one it was. Okay. It's fine. Let's say I'm adding it to the VS17, create new. Server name is, I will add the server as linked service demo server. Okay. and it's done. I will be using the description don't have the access of the server to be selected in the region. Okay, so let me put it to Central India. Okay, okay, and VS17 resource group it has added. So again, why I am adding it to VS17 resource group is so that I can have basically the access as well as the list of all the services that I am using in this particular video, right? So this server I am creating it somewhere else. This server is not getting created in my SQL database. Basically, the SQL database service, right? I am launching this particular server maybe in the Azure VM, right? So I can't remember all these things, right? That at the back end I'm launching these services also, right? So I am attaching it to the same resource group so that tomorrow, let's suppose if I have to bring down this particular database, so I'm aware about that. Okay, this is the server that has been attached to this particular database. So if it is in the same resource group, so again I will click on create and review, and I can click on create. So it is initializing the deployment. You can see SQL servers are created, firewall rules are created, right? Now my database is now in the deployment phase. So here you can also see, right, how different services are getting connected to each other, right? This SQL, Azure SQL database is a separately different service from ADF, right? But now just see how these two services will very seamlessly get connected to each other. Okay, let me just close this. Okay, and if I want, I can see the deployment details, and even I can go to the resource group, right? But that not necessary. I can come back here. Here if I refresh, so you can see link service demo, and let's say I'm using this free MySQL database, SQL authentication, and I can use identity based, let's say this only. But I have not created here my username and password, right? So what I can do, user assigned service principal. If I go with service principal, then I will have to add the principal key, right? Right. So I can go with system assigned identity management, right? Because here also the identity management I had done it automatically, the intra identity Azure identity management. Okay, so that's it, and rest of the things I feel is fine, and then I can click on create. So here you are now seeing, okay, that it will be created in a while. Right now if I check on this test connection, Okay, connection failed. Why? Cannot create SQL database. Cannot connect to SQL database. This. Okay, due to some authentication issue, right? User assigned manual entity, so credentials and all those things I will have to create. Okay, let it be, right. So just because of the authentication thing, we are not able to like basically basically connect to my resource. Or what I can do, maybe, okay, let me do one thing. Let me delete this deployment. Okay, uh, Azure database SQL. Okay, and here inside security and configure access connector, key connection strings. For the .NET part. Yeah, let me not waste too much of time. Enter, delete to confirm. So I will create a data source where I will require username and password to authenticate. Basically, that's what I will do. So I click on create SQL database. Okay, so subscription is fine. VS17. So now you see, right? As soon as I switched from the other thing, right? We did not have any servers inside other resource group, but as soon as I switched to VS17, the server automatically got attached, right? And here my database name is this. For authentication, where did it? Okay, it was an earlier thing, right? Advanced configuration. If I check, okay, this networking. No, not here. Additional settings. Ads. I will have to create basically whole of the infra again, right? Um, Let me just refresh the page. Create SQL offer for free, right? And I can click on VS17. Okay. Here I will create a new server. Let's say linked service demo. Okay. And I will be creating it in the Central Asia. And then I will use SQL authentication. So here SQL server admin login. So let's say admin. Okay. Let's say VS17. Okay. And but here it will be asking for the server. Let's check. So I'm inserting my password now. Okay. And then I will click on OK. Won't save it. And then I will click on review and create, and I will create the resource. So again, it will take a few minutes to launch it up. I can select the subscription. Server name will have to again change. So let it get deployed. It will again, I guess, take a few seconds now. Okay, so deployment is complete. Now if I go to this database, okay, and then okay, let's first of all try to do this. Right now I will come here and I will do this service one. Here I have this database SQL authentication. I can do username was vs17, right, and I will insert my password here. Okay, and then this is fine, and then I will click on apply. So now you can see, right, my linked service has been successfully created. Okay, and now I will be able to use this particular linked service now whenever I want to create any kind of activity. Okay, right, and now you can see, right, these are the databases and I can easily connect with this particular database just by using this particular linked service in any of the activity. And here if it would had any kind of data, that particular data would had been represented as the data set. Cool. Now linked service in the form of a JSON. So a linked service is defined in JSON format as follows. So we can also define the linked service in JSON format, something like this, where we can have properties as, let's say, name, and the description it is name of the linked service, right? Naming rule we are already aware of. Type of linked service, for example, is it a Azure Blob data storage or Azure Batch a compute storage, and see the description, right? Here if I come back again, right, and if I click on linked service new, so here you can also see we can add compute. It's not that we can only attach the storage as the linked service, right? We can also attach the compute as also as a linked service. So here we have Azure Batch, Azure Data Lake Analytics. We can use Azure Data Bricks, Azure Functions, HD Insight, Machine Learning Studio Classic 1, and Azure Synapse Analytics, right, for the compute thing. Okay, so we can also use we can also attach compute resources also as a linked service. Then property types. The type properties are defined for each data store or compute. So you can click on this particular thing to add that, and then connect via. So the integration runtime to be used to connect to the data store, you can use Azure Data Integration Runtime or Self-Host Integration Runtime. Okay. Then if you want to see the example of the linked service, so this is an example name, let's say Azure Blob linked service, type is blob storage, right? Then this is the connection string. Here you will have to put your account name and your account key, and here the name of the integration runtime you will have to add. Okay. Then create the linked services. So linked services can be created using the Azure Data Factory UI UX via the management hub or any activities, data sets, or data flows that reference them. You can create linked service by using one of these tools or SDKs. You can also use these tools if you want to create them programmatically, which we have already talked about. When creating a linked service, the user needs appropriate authorization to the designated service. If sufficient access isn't granted, the user cannot see the available resources and needs user manual entry option. Okay, so if you don't have proper authorization and the authentication, you will not be able to basically create the resources using the SDKs and the tools. Then data stored linked service. So you can find the list of supported data stores at this article, and the compute linked resources services. You will be able to get all the information at this particular link, right? Here also you can see everything, right, in the UI also. So for compute, these are the options which are available, and for data sources, there are n number of options that are available that you can connect to, right? So this is what it was about the linked service. So I hope with this particular video, you guys have understood how we can create a linked service, to what all services or basically the data storages can we connect a linked service to, and how we can connect, right? So for connecting to different data sources, there is a different way to connect, right? So I hope you guys learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course, and in this particular video, we are going to talk about data sets in ADF. So in the previous video, we have already created a linked service inside an ADF, and now we will be utilizing that particular linked service to basically connect to the data source, right? So in this particular course, we have already talked about multiple things like what is a cloud, how many different types of cloud are there, how we can create our own Azure account and get $200 worth of credit. Then we focused on a service called Azure Data Factory. So Azure Data Factory is the most used service if I talk about the data engineering domain. So we have already talked about multiple things inside the ADF, and today's topic will be data sets. So with that said, let's get started with this video and let's get straight into the system. So today's topic is data sets in Azure Data Factory and Synapse Analytics. So this article describes what data sets are, how they are defined in JSON format, and how they are used in Azure Data Factory and Synapse pipelines. So if you are new to Data Factory, you can go on to this particular link and understand about what is Data Factory and what is Azure Synapse. Then talking about the overview. So an Azure Data Factory or Synapse workspace can have one or more pipelines, right? We are already aware about this fact that Data Factory and Synapse can have one or more pipelines in their workspace. So a pipeline is basically a logical grouping of activities that are grouped together to perform a task, right? Pipelines are basically a group of one or more activities that are grouped together in a logical way, right? It's not that they are grouped randomly, they are grouped in a logical way where they will perform a certain task. The activities in a pipeline define actions to perform on your data, right? So activities are basically what? The actions that are getting performed on the data. Now a data set is named view of the data that simply points or references the data that you want to use in your activity as input and output. Okay. So data set is basically the named view of the data, means we are basically creating a view of that particular data, or the data set simply points to the data that we want to use. Okay, so this data set again will be a kind of a connection string or a pointer to the data location or the data store that we want to use inside our pipeline. Datasets identify data within different data sources such as tables, files, folders, and documents. So dataset can use different file, different I would say structure of data or formats of data that can be processed inside ADF. So we can process tables, files, folders, and even documents inside our ADF pipeline. For example, if an Azure blob dataset specifies the blob container or folder in the blob storage, which the activity should read the data. Okay, so where activity is basically to read the data, that data is present where it's present in my blob storage. So before you create a data set, you must create a linked service to link your data store to the service. Okay, so before creating a data set, we have to create a linked service. So what exactly linked service is, how we can create a linked service? So we have just talked about that concept in the very previous video, right? So if you haven't watched that video, go and first watch that video and then you can continue watching this particular video. Linked service are much like connection strings, which define the connection information needed for the service to connect to the external resources. Okay, so linked service again are basically a kind of connection strings that will basically create a connection between two sources, right? Think of it this way: the dataset represents the structure of the data within the linked service store, and the linked service defines the connection to the data sources. Okay, so dataset basically represents the structure or the schema of the data that is present in the data store, right? And the linked service will be the connection string that will provide the connection between both of the data stores, or I won't say both of the data stores. It will provide the connection between the data sources or the data stores. For an example, an Azure storage link service links a storage account. An Azure blob dataset represents the blob container and the folder within the Azure storage account that contains input blobs to be processed. Okay, here is a simple scenario. To copy data from Azure blob to SQL database, you need to create two linked service. Okay, so let's suppose I want to copy a data from my blob storage, okay, to SQL database. We will need to create two linked services. Azure blob storage. So the first linked service that I will need to create will be for my blob storage, and the second linked service that I will need to create is my Azure SQL database. Then create two data sets, that is delimited text dataset, which refers to the Azure blob storage linked service, assuming you have text file as source, right? And then the Azure SQL table, which refers to the Azure SQL database linked service. Okay, the Azure blob storage and the Azure SQL database linked service contains connection strings that the services uses at runtime to connect to your Azure storage and your SQL database respectively. The delimited text dataset specifies the blob container and the blob folder that contains the input blobs in your blob storage along with the format related settings. Okay, so the blob, so let's suppose we are doing the copy data activity. Okay, we are doing copy data activity. Okay, so this copy data activity will first of all will have to connect to blob, right, where my input data resides, right? So it will need the linked service first of all for the Azure blob storage, right? And then it has to copy the data to SQL server or maybe SQL database, right? So it will require the connection or the linked service to write the data right? To basically output the data to my SQL database, right? So that is the reason we require two connection strings, because the copy data activity will require one of the connection string, or basically one of the linked service, to connect to blob, ingest the data, right? And then it will require the second linked activity to output or to write the data to the SQL database, right? So this is what it has written. The connection string, the services at runtime to connect to your Azure storage and Azure SQL database respectively. The delimited text database specifies that the blob container and the folder where the data is reside, and it will also give us basically the format of the data that will reside in the blob. The Azure SQL table dataset specifies the SQL table in your SQL database to which the data is to be copied. Okay. Now the following diagram shows the relationship among pipeline activity datasets and link service. So we have already seen this particular diagram in the previous video also, that datasets can get consumed by activity, right? So here if I talk about, so here blob is getting consumed. First of all, the data inside the blob is getting consumed in the activity, in the copy data activity. The activity may be, and then the activity will produce the data to the other data set, right? That is the SQL DB, right? So here basically a consumption is happening, right? And here the produce is happening in the form of activity, right? Then pipeline. So if we have multiple activities, then that will be considered as a pipeline, that whole group of activities. And then the linked service. So this is the linked service that we will be connecting. So let's say this is my blob linked service, or maybe the input linked service, and this I can name as output linked service, right? And you can see right here, right? So we already have two linked service, right? Azure Blob Storage 1 and the SQL database linked service, right? So these are the linked service we have already created in the previous video. Now let's understand how we can create a data set using the UI. So to create a data set, with Azure Data Factory Studio, select the author tab with the pencil icon and then the plus icon, choose dataset. Okay. So we will go back here. We will click on the pencil icon and then we will click on this plus button, or we can also come here and select on new dataset, right? So let's click on this plus button and I will click on this dataset. Okay. Now where my dataset first of all resides. Okay, let's follow the documentation itself. Let's see. So you will be able to see the new dataset window of the connectors. I don't think it will give us anything, right? It will prompt us, right? And then set the properties. Okay. So now let's create first of all a dataset from my Azure blob, right? So let me copy it. Let me select it, right? And then I know that my data is basically a CSV file, right? So if I show you guys, so if I go to home and if I go to my storage accounts, right? If I go to file stores, right? Azure files. Okay. Yes, you can see, right? All resources. And here if I go to containers and ADF, so here you will be able to see this input folder is basically a CSV file that we are having, right? So here I will select the CSV thing, right? So name, I can name it as, let's suppose, data set demo input. Okay. And then I can select the link service as this Azure Blob Storage, and here I can select this ADF and input and life expectancy. I will click on OK, right? So you can see here the path has automatically been selected. First row will be header and input schema will be from store or connection. It's fine. I will click on OK. Right. So now my one of the data set has been created now. So okay, let it be. and let's come back here. Okay, now it's saying for JSON, right? Now let me create one more data set. Okay, let me create one more data set. So new data set, and this time I will create the data set for my Azure SQL database, right? I will click on this and I will click on continue, right? So let's say data set demo output link service will be Azure SQL database link service, right? And table name, I don't think currently we have any table. Schema name, let me go back here and let me just create a table. You can open it in full window, full toggle screen. Okay. And here what I will be doing is query editor. Okay. 03.48.192. So we have the tables. Currently we don't have any table. Okay. So what I will do is, so create table demo. Okay, but in that case, I will have to copy the structure of that CSV file, right? And that will become a overhead. It will not become a overhead. Let me do one thing. Let me be a lazy guy and let me basically add the data source and take help of ChatGPT. Okay, so life expectancy. So okay, now I'm being a lazy developer and I am just taking help of ChatGPT. Cool. So let me just copy it, go back here, and let me paste it here. Okay, and I will run this query. So now I believe we should have this table. Okay, so I will go back here. I will just refresh it, and I can use this table name, and I will click on OK. Done. And then we have created now. We have created two data sets, and now what I will do, I will just delete this pipeline one. I will come on this copy data pipeline. Let me delete these two activities. I have used it for previous video. Here I will use my copy data activity, right? And inside the copy data activity for source, I will be using which data set? Uh, Dataset demo.input, right? And I think Rest of the things are fine. And for sync, I will be using this output one. And rest of the things seems fine. Okay. And then I will do what? I will click on this publish all button. And then I will click on publish. So publish is basically saving the changes that we have made. If we will not publish, so the pipeline will be in the previous state only. Okay. Now, so the publish has been done, and now let's try to run the pipeline. And let's go to our monitor tab. It will take a few seconds. Okay, for some reason it failed. Let's check what's the reason. Delimited text column not allowed null to pop index one is empty. Okay, operation in the target copy data one failed. Delimited text column name not allowed null. Okay, so here I have I put any kind of not null condition. Let me close this. Let me open this. Obviously, because we don't have any data right here. Okay. What we can do now in this case is, okay, let me do one thing. Again, let me take help of ChatGPT. Bottom line, that SQL is not a problem for hygiene issue. So we had already used the dataset as true. Okay, let me just go to author, check my data source, input. So this is fine. If I click on preview data, okay. So due to this property zero column, the issue is happening. Got it. Earlier it was not here, but I guess this data factory has created it. Okay, so what I will do now is value allow first row as header. Okay, done. And due to this issue, so what I will do, let me do one thing. Preview data, and let me download this data or add this prop underscore zero column in the schema. No worries. Okay, I will add this prop underscore zero column in my table. Okay, so I will do what? Let me do one thing. Table dvo dot life expectancy. Okay, and now we don't have any table. So what I will do is just copy this, paste this here, drop 0, and it is int. Then now if I refresh tables, we have the schema ready. Now if I come back here, things are fine. I hope I have changed something. Let me publish. Publish. And now I will come back here and I will try to re-execute now. So trigger now. Okay. Go to monitor. Okay, it failed again. Make sure the column name is properly specified in the header. Column, the name of the column index 1 is empty. The name of the column index 1 is empty. Make sure column name is properly specified in the header. Okay, let me do one thing. Let me duplicate this. Okay, let me go to all resources, copy data demo, containers, ADF, input, life expectancy.csv. And if I want to, okay, got it. So let's say put it as ID. Got it. So here you can see we are having the values, right? Here we are having the values, but for some reason the header was not provided. In if I will show you the raw data, right? If I show you the raw data, here we don't have the values. These 0, 1, 2, 3 values. I guess it has been added by data factory. Okay, so if you see here, okay, we are having the rows. Okay, fine, my bad. We are having these rows, but we are not having the column name. Now I guess it will be fine. So I will just click on this. Okay, and let me do one thing. Um, 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 um. Yes, we. I will download this data only. Yes, replace it. Okay, and now again, for that reason we were able to get we were getting the issue. So let me again drop table preview life expectancy expectancy copy paste. Country did not add. Control C, control all, control V. Let me remove this constraint. I don't need any kind of constraint here. Here what I will do, I will add the ID column as int. I don't even need this not null constraint here. Okay, and rest of the things seems fine. Run, done, and let me again try to rerun the pipeline. It failed again. What's the reason? Okay, it's the schema issue now. For which column? For hepatitis B. Hepatitis B. Okay, let me do one thing now. Edit. Because of these long values, we are getting the issue now. Okay, let me do one thing. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I will have to display int table. Okay, and here I will be doing what? In hepatitis B, I'll be using decimal of, let's say, 12 and 10. Okay, Let me add this 12 and 10 value to all the places. So that even for the larger thing, it does not create me an issue. Let me just check. In fact, that number 5 is integer. So life expectancy, edit, or I won't go into edit. Let me come here, author, dataset input, preview. Okay, so expectancy is again a decimal. Two, come back here. Life expectancy is decimal. Fine. Adult mortality is fine. Percentage expenditure. So basically 1, 2, 3, 4, 5, 6, 7, 8. Okay, fine. GDP looks fine. Well, I don't think now we will get an issue with the it's fine. Okay. I think now things should run fine. Data activity, add trigger, run now. Okay. And let me go to monitor tab and let's see. Right. So these are the issues, right? Like now you can see that we are not getting any kind of large issue, right? These are a bits and pieces of issues that we usually get. Okay, again it failed. Now what's the issue? Population. Okay, precision is 19. Okay. Population, population. It's big int. Okay, let me keep the decimal. Sorry, let me keep it decimal 20 comma 10. Control all, control C. Okay, pipeline monitor. I hope this time it runs fine. So again, I can say that this is one of the uh, you can say what's happening. Adult mortality. Adult mortality. Where is adult mortality? Adult mortality is int, and the data that we are having. Are we having any decimal values in adult mortality? I don't think so. Okay. Should I do big int then? Or let me keep it decimal. I'm not doing the schema sanitization right now, right? Control C. Author, trigger, run now. Okay. Go back. So it's just the schema mismatch that's not allowing us to run the pipeline. Or I should have just used a simple file. I did not hope that these like the schema mismatch will happen. I thought the AI will do its job, but unfortunately it did not. And again, we have received the error. And column under 5 deaths does not exist in the target DBO. Seriously? Um, under 5 deaths. Under 5 deaths. It's after BMI and polio. Under 5 deaths is there. Under underscore 5 underscore death. So here it's underscore 5 deaths. Wait, it's underscore 5 underscore death, right? It's under 5 underscore death, right? If you will look closely. So it's under 5 underscore deaths, and here what we have given is like this, right? So that's the issue. We'll see. Now I hope it will run because the schema mismatch has been gone, right? And let me just try to rerun this pipeline. In HIV AIDS, okay. HIV AIDS. What's we have? Okay, and let me check other one also. GDP it's fine. Population it's fine. Thinness 19 underscore air. Thinness underscore 10 underscore 19. No, it's not the column name. It's thinness 19 underscore air. So let me thinness 119. Is it double underscore here? I guess it is something like this. Yes, and thinness 59 underscore years. So it is like this, right? And income underscore composition. So we have income underscore composition underscore resources, and then we have schooling, and we have schooling. Let me do one thing. Review the data. Income composition of resources. And here we have given what? Income composition underscore of underscore resources. And then schooling. Control C. Drop table. Control V. And then I can click on run. Come back here. Go to copy data pipeline. Trigger. Trigger now. Okay. Go to monitors. We could add created the schema much more earlier than this. Okay, fine. So currently what's happening is due to the schema mismatch, right? The source is not working perfectly fine. But this is exactly how we can use multiple sources, right? What I will do is in next video, I will create a dummy kind of data and then I will be using that particular data to show you guys how we can do it exactly, right? Now let's understand how we can create the data sets using the JSON. So a data set is defined using the JSON in this particular format, right? We can name of the data sets, then the properties, right? The type of the data set. It will take the linked service name, so linked service reference name and the type of linked service. It will take the schema, right? That is what we are struggling with right now. Then the type of properties. So name will be the name of the data set. Type will be the type of the data set. Specify one of the types supported by Data Factory, for example, a delimited text or this Azure SQL table and like that. Then schema of the data set represents the physical data and the shape and property types. So see these property types in this particular link. So when you import the schema of the data set, select the import schema button and choose to import from the source or from local file. In most cases, you will import the schema directly from the source. If you already have a local schema file, a Parquet or a CSV with header, you can directly use the service base, the schema of that particular file. Then in copy activity, dataset are used in source and sink. Schema defined in the dataset is optional as reference. You want to apply field and column mapping between source and sink, right? Then the dataset types. So we are already aware about that how many dataset types can be done. Then how we can create a dataset using SDKs and all. We already aware about this fact, right? And this is done. Cool. So, like why we were not successful is basically because we are not able to exactly get the schema, right, which my Azure blob is providing to the table, right? So no worries, I will figure out the exact schema, right? And then in the next video, I will try to show you guys how we can do this copy data activity. Else, I have already shown you how to move it from one blob to another blob. Is just that right now the sync data source is my Azure SQL table, right? And for that reason, due to the schema mismatch reason, we are getting this particular issue. Cool. So I hope you guys learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye.